once again this year, I'm sure this conference will be a success. So good morning, everyone. I will try to set the tone a little bit of what this session is going to be about by placing the emphasis on the human exposomics. And for those that are not aware of the term, I'm going to explain to you right away with emphasis on how we can prevent primarily and control chronic diseases. So I would like to thank my team at the Cyprus University of Technology and our collaborators from Mount Sinai and also from the Cancer Registry of Norway and the National Institute of Health in Italy. So I have no conflict of interest to declare. So my talk synopsis will be first talk about what is the human exposome and some definitions, what are the components and the tools that usually come along with this new methodological framework, and some very brief applications of the human exposome. So the whole presentation today is based on a recent publication we did with some colleagues from Harvard University and Mount Sinai, basically describing the human exposome applications and how exposomics can basically complement genomics and in the field to try to understand chronic disease process, control of these chronic diseases, and also in relation with the longevity saga and all the activities that are ongoing worldwide. So just to set the scene with respect to the exposome is actually, I'm going to start with the definition, we try to characterize all the non-genetic, basically all the environmental, let's say, lifestyle, metabolic risk factors that every one of us is exposed to from birth all the way till death. So if we are able to characterize all these non-genetic determinants of the disease and then couple that, integrate this with the genome, then we shall be in a much better position to understand the human phenotype. So Europe currently, as we speak, is trying to redefine how we understand and how we can protect human health in particular. And there are some very important initiatives that have been recently formulated in Europe. One of them is the investment of the European Commission on the Human Exposome Network that was established a few years ago. More than 100 million euros have actually been spent on this, positioning actually Europe as a global leader in research on exposome by linking environment, lifestyle, and health. Very recently, there was a European Parliament STOAS report on positioning and recognizing exposome research as a key to next generation public health. The S&D Group's recent health position paper also shows that appears to create a political movement also to facilitate these health in all policies, how we can incorporate the exposome into One Health and into health in all policies that are particularly taking place as we speak now in Europe. So the whole idea is how we can make this methodological framework that I'm going to share with you more mainstream. And in order to do this, we need to move from research to policy at the same time, supporting fairer and more data-driven prevention strategies across Europe, particularly focusing on vulnerable populations. So when we talk about the human exposome, usually we have three major domains that characterize a person's exposome. So we can start with a general external, the specific external, something that is very near to what the human experiences and contacts as an exposure, and also the internal exposures. So there are different components, allow me to say, with each one of the major domains of the human exposome. So we have some general external groups of components, as you can see here. So this can be meteorological risk factors, as you can see here, weather and climate, can be the natural and the built environment, can be psychological and mental health, socioeconomic status, policies that relate to health and the environment. So all these are examples of what the general external exposome domain is composed of. Then as you come a little bit closer to the individual and what the individual feels and contacts with, you can talk about here different chemicals. You can talk about that are present chemicals in the air, in the water, in food, noise, infectious agents, occupation and lifestyle relevant factors. All of them, and each one of them, are important as they allow us to better integrate the human exposome. And of course, when we talk about the internal exposome, then we talk about components that have to do with internal characteristics. So this can be small molecules, could be proteins, it could be various omes, various omics, or gene profile. And here, this is a scoping review that we did, where we saw how often and which combination of all these components that are mentioned one usually encounters in the global literature that mentions the word exposome in the field. I'm not going to go to these details, but I just wanted, first of all, to give you a small overview of what the exposome is composed of, and then what are the main tools. So what kind of exposomic tools we can apply in practice. So in addition to the questionnaires and the surveys, we have very important biomarkers of exposure to different environmental stressors. We can also have biomarkers of biological response. This can be inflammatory markers, various cytokines, it can be oxidative stress, tissue biomarkers, and so forth. Let alone omics platforms. This can be transcriptomics, proteomics, metabolomics, genomics, all these different omics platforms that are more frequently incorporated into scientific biomedical endeavors. Existing data sets, very important, the various health data sets that are at the governmental level, it can be at the country level, it can be at the municipality or zip code level, weather service data, hospital records, these are also coming up very strong in the research. Devices, various personal devices, sensors, these are stationary or wearable sensors that have applications for various environmental and health factors. Satellites, geospatial modeling, remote sensing, these are increasingly important in understanding the contribution of place as a major contributor to disease process. And of course, the various environmental testings and the clinical assessment, the blood biochemistry, and other relevant information, X-rays for lung metal content, amniocentesis, etc. All these different tools, assessments, and approaches are different tools that exposomics deploy. And then, of course, in addition to all these tools, because you are generating with this way, if one deploys such a comprehensive exposomic data collection, that implies that you need to start considering very seriously also what kind of advanced biostatistical algorithms you will need in order to better understand and to better process these rich data sets. So the human exposome concept, it's very important to mention that contrary to the genome, on average, we can state that inherently dynamic, more dynamic in time and space. And this really how it complicates things, because contrary to the gene, let's say I can measure the gene in a human DNA, but then for the exposome characterization, you need to do all these different characterizations for different exposures that I mentioned in my second slide. If you remember, I have to measure these factors, how they evolve in space and time, this global dimension of human exposure. Therefore, things start getting really complicated. But we have to understand that this new biology era that we are entering, it starts embracing this complexity. So we want to start moving away from the fragmented and the reductionist approaches that you usually engage, so far at least many of the epidemiological approaches. So basically our idea is how can we incorporate these measurements of the exposome here in the graph, as you can see here with the term exposures, and how we can incorporate and synthesize and therefore integrate all the multi-omics, let's say, biological information that we can acquire by incorporating measurements on transcription, measurements on translation, on function. So all these different omics data Because by doing this, we start getting closer to the actual phenotype, the disease phenotype, whatever we are after as a major health outcome or primary outcome in our study, in order to better understand how the interplay of all these biological layers, they interact with each other and they interact downstream the biological pathogenesis process. So things can only get complicated, but we really need to embrace that if we start monitoring these biological information changes over time. So this requires different study design, this requires different approaches, and obviously this new multi-omics era, as it has been characterized, considers genomics as a function of gene expression more than simply a DNA sequence variation. So it is also good to put here an equation, which I believe is really important to understand, and see that the disease phenotype is a function of the genotype plus the multiple environmental exposures that are part of the disease process, plus the interactions, the gene times environment interactions. So there are some diseases, for example, where the genotype is very, very important and much more important than environmental exposures, like cystic fibrosis, for example, or you might have a different scenario where environmental exposures are much more important than the genotypic contribution to the disease incident variation, like, for example, leukemia. So in this case, you really have to understand that there are most of the actually chronic diseases that are lying somewhere in between. So you need to start considering also the interaction, the gene times environment interaction to understand cancer, to understand type 2 diabetes, various metabolic other diseases. So we have to also embrace that heritability, which is basically an association, is not a causation type of studies, just like usually we have this kind of studies also from environmental epidemiology studies, are hint that this heritability is not solely dependent on genetics, but we're having a missing heritability component that maybe is associated with a black box, that this black box includes the genes, the environment, the lifestyle, the behaviors of people. So we need to understand that this biological reality, whether you speak at the gene level or the cell level or the macro scale level, either at the individual or at the population level, is far more highly variable than can be explained by genomics alone. So
2 minutes, okay.
2 minutes approximately, thank you. So this is an example with phenylketonuria, which is a genetic disorder that arises from a mutation of a particular gene. So if a person has this kind of mutated gene copies, then usually they cannot process the amino acid phenylalanine. And if you cannot properly metabolize this, that means you have an accumulation of this amino acid metabolite in the developing brain. So this genetic disorder, however, can be considered with a different approach, that whether you know, if you know this information, then you can start giving to the newborn baby an environmental intervention. For example, a low phenylalanine formula. And maybe you can manage this way, this genetic disorder, environmentally. So there are different data processes that I described before, the exposome-wide association studies, where you start incorporating different environmental variables, as you can see here, so you can create this correlation globe, where you see the different correlations between the variables, and then you can also create this Manhattan plot to the right, where you have these multiple one-by-one regression models that are running, and you account for multiple testing in order to see the significant ones, variables that may be associated with a disease of interest. And then you can also incorporate some feature selection algorithms in order to understand better the mixtures or the multiple exposure effects on the disease. This is an example of a recent study that we published on trying to understand how more than 125 biomarkers of exposure to xenobiotics. That was a randomized controlled trial on individuals consuming fruits and vegetables that contain pesticides and other chemicals as residues, whether these fruits and vegetables were consumed in the day versus the night, and whether the metabolism of these chemicals, depending on the time of the exposure, had a different effect on the body burden of these chemicals. And we did observe that for different chemicals like pesticides, smoking biomarkers, VOCs, etc. So this is almost the last slide here. I just wanted to briefly to share with you two scenarios, how the gene and environment interactions are very important. So you see here this scenario where the environmental stressor exposure levels has a totally different biological response depending on the genotype that is considered, whereas in the below case, you don't have an interaction between gene and environment for this particular case. And if you have this kind of interaction, then you might expect somehow a dysregulated multi-omics biological response and perhaps a higher disease risk. So this is my last slide. The key messages I would like to focus on first to remember is that the human exosome can actually complement the genome, but is more variable in time and space. The complex networks of systems that we would like to embrace will allow us to move one step forward compared to the reductionist so far approaches. The multi-omics view is very, very important, and this is what we really need to start working more on it. We have to make these processes cheaper. We have to make them more mainstream in order to better understand how they can help us to understand disease process. Exposome-based applications indeed have a value for chronic disease prevention. And last but not least, really the environment, because we consider that the environment is a prime driver of gene expression, there are very big opportunities within the precision health and the precision public health era. So thank you very much for your attention.
Thank you very much, Professor Makris. Very interesting. Yanni, will we allow time for questions or?
I guess since the lecture and time is over, we better go on.
Okay, but of course you have the opportunity with Professor Makris to discuss during the break. Okay, Dr. Zachariadis.
Yes, thank you. It's my pleasure to introduce next speaker, Professor Dr. George Boustras, who is a professor in risk assessment at European University Cyprus and Dean of the Ioannis Grigoriou School of Business Administration and Director of the Center of Risk and Decision Sciences. His lecture is about disaster risk reduction in the new environmental realities. Please.
Thank you very much. I'm no longer the dean. Thank you for taking me back a trip down memory lane 6 years ago. But still, you know, like I'm very happy of my accessor, of Pieris Houridis, and all the rest is actually right. I hope I have uploaded the right presentation, but anyway, if we haven't, you know, we're going to have a nice discussion and improvisation. Thank you very much, chairs. Thank you very much, Yanni, for an amazing conference that you organize. In many ways, it is amazing. In many ways, it is so well organized, and everything, all, I don't want to say all glory, and this is because of you. All these people that are going to be here, all these international speakers, all the acclaimed speakers that are going to be here today. I want to start by spending a minute talking about my colleagues, because I think this is correct, because if it wasn't for my colleagues, I wouldn't have been here today. Okay, I'm not taking an Oscar, so I'm not going to thank everyone, but I want to say a couple of words. I come from, with Christos, we started 10 years ago, the Center for Risk and Decision Sciences here at the university. We were 2 small labs. As you will see, we became a much bigger lab over the years. And we do 3 things. We do research. I'm going to talk about that in a minute. We do education and training, which I'm going to talk about in a minute. And we do consultancy. We do consultancy not for private organizations, unfortunately, because the disaster risk prevention industry in Cyprus is almost non-existent from a private point of view. But from a public point of view, we provide advice to the Cypriot government, to the government of the Hellenic Republic, the Office of the Prime Minister, the Office of the President of the Republic here in Cyprus. We work with World Bank, we work with Expertise France, we worked with OECD. So we do a couple of things. At the moment, we employ 20 researchers and 10 PhD researchers. A couple of years ago, we were 40 people, but we decided that we want to have a much well-managed team. When I started my career at the university, the then Dean of Engineering at Kingston University, he said, you are entering an industry with a lot of people with stress-related diseases. And as researchers, I think, we can testify on that. So sometimes it is difficult to manage talent. We have been around the block when it comes to European funding and national funding. We do mainly 3 things in terms of teaching and education. The MSc in Occupational Safety and Health. It has been going for 12 years now, very successful. And I dare say that it had a touch on establishing a safety culture at the national level in Cyprus. A touch. I'm not going to say that we changed things. The PhD in Occupational Safety and Health, already we had 10 graduates with an average of 4 Q1 publications per graduate, thanks to Christos mainly, because I do actually, like the talking, but Christos does the work. And the MSc in Disaster Risk Reduction and Security Management, which started in collaboration with the National Observatory of Athens, that we have a strategic collaboration. Since July, we started, after a competitive process, we started a UNESCO chair. So we have a UNESCO chair in Disaster Risk Reduction and Societal Safety in Southeastern Mediterranean. Why in Southeastern Mediterranean? The co-signatories of the chair come from all the region, and we are happy to say that we have very close relations with a lot of organizations, public, governmental, non-public, NGOs in the region. And among the signatories are the University of Haifa, in Israel obviously, the Lebanon Reforestation Institute, extremely successful and extremely active NGO in Lebanon, the National Center of Security and Crisis Management of Jordan. It is a governmental organization that deals with crisis management in the Hashemite Kingdom of Jordan, and of course the Union of the Mediterranean. I'm proud to say that our university has an MOU with the Union for the Mediterranean. The Union for the Mediterranean is the arm of European Commission for civil protection in the area of the Mediterranean. Thanks to the work that we conduct the last few years, we have established close partnerships with civil protection authorities, with civil protection ecosystems all around the Mediterranean. Just a couple of them here. There are many more. Just choose a couple of them. Nemausus, which is the Center of Excellence of Forest Aerial Forest Firefighting, based in Nîmes Metropole in Nîmes, in France. We have worked with the ecosystem of Western Balkans. Christos has conducted a large-scale exercise there. When I say large-scale exercise, I mean exercises that a few thousand people are taking part. A few thousand people wearing uniforms, hospitals, firefighters, policemen, forest firefighters, public health officials, ministries, ambassadors, various people. As if Western Balkans was not trouble enough, then we proceeded to the Caucasus, and we did the exercise with Armenia, with Georgia. We even had to go and talk to Iran, but we're still here, no worries. And last but not least, something that is very close to our heart. 3 months before the October 7 attacks in Israel and the consequent events, we concluded on behalf of the European Commission the large-scale exercise between Israel, Palestine, and Jordan. And when I say between Israel, Palestine, and Jordan, it wasn't, like people like us. It was officials, a few hundreds of first responders, the armies, and all that. And why I say that is because what we see now is very unfortunate. What we saw at that time was an image of collaboration between the three entities, and it was something very important. I want to say a couple of things. As we are here, we're talking about public health in a way, or in another way, the outcomes of catastrophes to us. I want to say a couple of things about Cement Fire. Cement Fire is a twinning project that we are concluding now, that we work together with Imperial College, with Wageningen University, based in Wageningen. I think, if I'm not mistaken, perhaps the global point for as a university for whatever has to do with soil, below the soil and on top. So agriculture, everything, fires. Pau Costa Foundation, a leading NGO, a partner of the European Commission in civil protection. Sécurité Civile, we have a close collaboration with the BOVO, with the Ministry of Interior of République Française, and Nîmes Métropole, which is, as I said, the base of the European Union for air firefighting. And if you are stressed, at some point, perhaps you can come with us, because through this program, among many other things, I choose to show you one thing that we are very proud of, that we conducted the first ever controlled burning. Controlled burning, as you see there, we actually burned legally in the presence of forest firefighters, the police, whoever you can imagine, outside in the outskirts of Nicosia, and we burned for a good reason. We burned just, like the, how do you say that? Just the shrubs that in case of a fire would act as multipliers of the fire. We have been monitoring this. It has been now 8 months. The results are amazing, both for the ecosystem, for sure for the fire ecological reasons, the results are great, and we will continue monitoring that. The results have been presented to the Republic of Cyprus, that is taking an action to standardize this and make it a practice that they are going to adopt, as well as the Hellenic Republic, that most probably in the new law for civil protection that will be voted in the beginning of 2026, controlled burning will be one of the tools that we're going to follow, we're going to adopt for prevention, because we spoke about prevention, and this is what I'm talking about today. In terms of firefighting in Cyprus, there are too many actors around. I don't want to talk about that. I just want to show you what has been happening for the last, this is not up to 2024, this is up to 2020. What you see, the little dots, everything there, are various different fires that started in Cyprus. What you will notice there is that the vast majority of the fires are not happening in the forest, but they are happening around the forest. And this is something worth noting, because actually, and obviously I don't mean that they should be happening in the forest. We're very proud of the forestry department, that they are defending the forests. There is no doubt about that. But the image that we have in our mind is that our forests are burning. Reality is that our forests here in Cyprus, at least, are not burning. What is burning is the WUI areas. And WUI areas are the wildland-urban interface. And why are they burning? Because we have stopped managing our forests. Sorry, we have stopped managing our land. We don't manage our vegetation. In other words, we have let the forest come to the city. What we believe usually is that the city has been expanded, which is right to a certain extent, but what we see is that the reality is that the forest has come. An example of that, a graphic example of that, is that in the big fires of mountainous Limassol last summer, you will notice that in the areas that they were cultivated with wineries, the fire just passed through. It is the equivalent of what we did in controlled burning. What did we do with controlled burning and with the wineries, with the vineyard, sorry? We removed all the excess fuel, yes, all the excess fuel. So we managed it. Summer 2025 looked like that. I wanted to tell you something. You see, I didn't, that's why I didn't upload the correct presentation, but still, I wanted to tell you for a minute only, and I'm not going to talk about that, about the impacts that forest fires have in our health, in our economy, and our societies. They are very profound. We started monetizing them. We started counting these impacts. We started really counting these impacts in a few parameters that I'm going to tell you a few years ago, but the majority of them we started monetizing in the last few years. At the moment, we are starting, together with the National Observatory of Athens and NOVA. If we have any Greek students here, you will know about NOVA. This is the one that you watch football. Basically, with NOVA and the National Observatory of Athens, and the Ministry of Civil Protection and Crisis Management, Civil Protection and Climate Change in Greece, we are starting an ambitious project to try to monetize the impacts of fires per year for the last few years. In terms of public health, I'm not a public health expert. I know that there is, especially with regards to air, Izan, I think that you have a very great network, and I'm sure that you're going to talk to us about this, of seeing the impacts on the quality, the air quality. But it is not only that. We need to do even more work on the impact that forest fires have in carbon emissions, and many more other things. I'm finishing with that, and I'm going to say that we, the citizens, we complain to the authorities for not taking action. Okay, for sure, yeah. But what I'm going to tell you is that we citizens are not taking any action. We are spectators, especially for the countries of the Mediterranean in the summer, when there is no football, there is no athletics, there is nothing else to watch. We just become spectators in the catastrophes that are falling. We do not take part in prevention. We should be taking part in prevention. It is great that we have volunteer firefighters. We have enough. We don't need more. What we need is citizens that are going to take action in prevention, in removing fire load, fuel from the forests, fuel from the areas surrounding our cities and our villages, and things can only get better. Thank you.
Thank you very much for the very interesting data. I think since we are a little behind time, we should proceed to the next speaker.
Right, so now we have a live streaming lecture from Dr. Dimitrios Kalogeropoulos. I don't know if this has been set up. Right, so Dr. Kalogeropoulos, can you hear us?
Hello, good morning.
Good morning, good morning. Allow me just 1 minute. We're very happy and proud to have you with us. Allow me just 1 minute to introduce you. Dr. Kalogeropoulos is internationally recognized as a pioneer in digital health innovation and agentic artificial intelligence, whose work consistently champions ethical, inclusive, and sustainable models of care. With a distinguished career spanning over 3 decades of meaningful impact in global health systems, policy, and implementation, he currently serves as the Chief Executive of the Global Health and Digital Innovation Foundation. Additionally, he holds the role of Health Executive in Residence at UCL's Global Business School for Health. So, really proud to have Dr. Kalogeropoulos delivering the lecture with the title, Artificial Intelligence for Improved Public Health, Burnout Prevention, and Climate Resilient Health Systems. Dr. Kalogeropoulos, the floor is yours.
Thank you. Good morning once again. I think that the context has already been provided for me. So I've been invited here to speak today about applying LLMs for climate health integration, foundations as foundations for adaptive resilience. In fact, in about 20 minutes, we're opening our venue here. We're hosting the first IEEE Global Public Health Forum. So it's a great pleasure to actually start the work for today speaking to you. Yeah, I think that what we heard in sort of a lot of detail just now is that climate change is more than an environmental challenge. It is a catalyst for thinking health equity, resilience, and our collective capacity to respond to crisis. We are already witnessing how shifting ecological conditions alter the distribution, severity, and frequency of both communicable and non-communicable diseases. And I will show you some evidence about this later in a couple of minutes, from vector-borne outbreaks emerging in new geographies to cardiovascular risks during heat waves to respiratory diseases driven by air pollution and wildfire smoke. The impacts are real and they are here. So these challenges affect us all, but they fall hardest on vulnerable populations and place extraordinary pressure on already strained health systems and workforces. We have seen that this pressure looks like, and both during emergencies and throughout the long uneven path to recovery, COVID, for example, and we have witnessed its lasting toll on the health and care workforce. Our collective response in future crises will depend on our ability to recognize opportunities, to use technology to solve problems rather than amplify them, to serve people rather than to add to the strain and strengthen our adaptive capabilities for the challenges ahead. So these are for us both a target that we're working toward and the ultimate cause for our contributions. Unpacking what is going wrong can be complex though. However, we can start by identifying the factors we do understand and begin to systematically integrate them into evidence-based solutions. So this is what I want to talk a little bit about this morning. About an aging population, for example, that shifts the burden of access beyond the acute care environments where most of capacity building efforts have been focused. And this is one of the main reasons why health systems are strained. Another is technology. Once fixed and contained, has become adaptive and dynamic. We're seeing that with AI and LLMs, for example, and their informal use by different doctors and the health workforce. But it also increases the cognitive load on physicians and users, so there's additional strain from there. Precision medicine and the pandemic have both revealed individual resilience as a critical variable in public health. And this is the opportunity when we start talking about climate health integration, about starting to discover that and how exactly it works as a factor for disease. So we're entering a new era of evidence-based medicine, that's clear. One that calls for a new understanding of patient safety, not only protecting from harm, but also strengthening the systems and people that sustain care. 3 actions for forward momentum it is that we are proposing, and I will briefly go through today. One of them is that fragmentation requires trusted connectors upstream, mechanisms that integrate data, workflows, and governance before crises occur. The other one is that these connectors must also enable research interoperability, ensuring that the same frameworks supporting care also advance knowledge, so learning as a core component of our strategy, and patient-reported outcome measures that capture evidence-based resilience can guide more efficient, adaptive, and equitable healthcare services delivery. And this is a very important aspect also in our policies and strategies that we pursue, because we all talk about patient-reported outcome measures. It's a little bit like the weather, and the British saying, but nobody does anything about it. So if we wanted to have a look at our state of evidence, and I think that most of you in this room will agree with this statement, is that our current state of evidence is impressive. We've accumulated almost all the data we could possibly need, but the paradox is that this data hasn't translated into equivalent value. So what we're really missing is not more data, but the right kind of data. That crucial 1%, if I can call it that, they tell me it's around 3%, but let's say 1%, that allows systems to connect, compare, and coordinate. data that enables integrative governance where evidence flows across care, research, and policy. So you can imagine I'm actually talking about the patient experience and how that is impacted by climate as well. But it is not that simple, there's more behind it. Now, to achieve that, we need a new kind of digital public infrastructure, one that treats data as a shared resource rather than a siloed asset. And our thesis here today is that large language models are uniquely suited to help build this, not because they're just powerful tools, and they are, we've all seen that, but because they're socio-technical systems designed to learn from context, collaboration, and diversity of input. And with a bit of support from international standards community, and we are also working in contributing in that direction, we can ensure that this infrastructure remains open, secure, and globally interoperable. For example, as you well know, yesterday was the first plenary meeting of the AI Office's Code of Practice on Transparency of Generative AI Systems. So I'm not going to go into much detail. I have no idea how many of you are aware of how LLMs are retrained, fine-tuned, and what the future for LLMs is in the audience today. But I'm just going to briefly say that we are building toward a model, and I will present 2 case studies where this is the case, where we are training, fine-tuning large language models. So these are foundation available models in the market, and there's a few of them, as some of you know, to be able to learn phenotypes from known associations using a research data integration layer. So the ambition there with standards is to produce time-resolved phenotype-ready data sets to integrate the different data that we have, that 99% of the data that we have access to, provided the adequate transparency is in place, use those data sets to learn basic knowledge about what it is that we are observing, and that includes climate health integration and other parameters, and I will again talk about this in a minute through concrete examples. Include the humans in the process, of course, expert reviews, holdout validation, annotation, capture, bias controls. There's a few very fancy terms that the industry is using as a validation layer to make sure that what it is that we're producing there is a good foundation for further discovery. Then move on to latent variable discovery. So this is what I mentioned ago as precision resilience. These are the drivers of risk and resilience. These are the connectors that will help us work together as an international scientific community around health and care, and eventually through a process of adaptive intervention, so applying the knowledge in a systems framework methodology to find out how much and how well it learns. We can eventually go back to dynamic risk stratification, and that's where we know that we actually have developed new capacities. So one of the case studies I wanted to talk about this morning is burnout risk detection, and I'm presenting this first because the core of my talk today is about climate health integration. So we're building then there an AI solution for burnout risk detection. This is our first study, and it comes from WHO Strategic Partnership Initiative for Data and Digital Health, where we've developed a blueprint for model development in workforce burnout prevention. This approach leverages systemic secondary healthcare data. This is the 99% I mentioned earlier, to identify high-risk zones for organizational burnout. So we're already narrowing down this focus. We're looking at workload, for example, and sort of clinical patterns that physicians have in their day-to-day clinical administrative patterns they have in their day-to-day routines. Using an AI-powered solution model to uncover and mitigate root causes through targeted health workforce optimization. So our strategic objectives here are to reduce burnout incidents in this sector, enhance health system resilience, reduce healthcare expenditure, increase staff retention, and improve quality of care. And there are 3 stages here. So it is a slightly reduced version of the model I showed you a minute ago, the methodology I showed you a minute ago. So one of them is the population level analysis. That's the 99% again of the data, where we're looking to conduct longitudinal analysis to understand differential susceptibility resilience across workforce segments. So this is a kind of phenotyping exercise where we're looking at bigger groups of people and their resilience to burnout and stress. The second one is grounding, testing, and refinement. Again, I mentioned this a minute ago. And then finally, model fine-tuning and system learning about things like role-based classifiers or multi-source data fusion to improve the model's adaptive learning capability and support proactive workforce resilience intervention. So here we're talking about personalized precision resilience, and we would like to know what factors strengthen each person to deal with stress and not move on to the later stages of burnout. So the second case study is applying a climate health foundation model, integrating environmental data, health outcomes, and workforce adaptation. And this is an IEEE a program that I'm chairing as part of Industry Connections program on AI for improved public health and climate resilient health systems. So today's event here in London is the inaugural event of this particular program. And what we're going to discuss in about an hour is, in this case, satellite and field data come together to show how a warming climate is reshaping health risk. What are you looking at here? I mean, that's one of the examples that we're going to talk about today. So what you're looking at here is a map of a deer that is actually migrating north from the United States into Canada because of the warming climate in the northern states. They don't like the heat, as you know, this observation was enabled through a NASA program, collaborating program, and it shows essentially deer ticks carrying Lyme bacteria moving north, exposing new populations and allowing us to map resilience at the personal level. Of course, there's a long way to go from this mapping to the kind of scientific discovery needed for to improve public health and care. But it's important to see this sort of, going upstream, this upper level, this helicopter view of health systems. And I think this serves as an indication of what it would look like. There's other areas that we looked at in our white paper and we're discussing today. So there's autoimmune diseases, and there's a lot to be said about autoimmune diseases, as you well know. And here we're exploring how geography and environment shape disease susceptibility among genetically similar populations. We see clear north-south gradients of autoimmune diseases, patterns that reveal how early environmental exposures can program lifelong health trajectories. And these are, again, studies that we have selected from the literature and would like to further expand toward real-time environment for public health, climate health integration. So the challenge and vision here is to bridge data ecosystems to operationalize climate health integration through a federated standards-based governance-driven framework, to learn latent drivers of personal resilience factors from geospatial, environmental, health system, and community data, support predictive surveillance, adaptive governance, and workforce resilience when dealing with the complexities of climate impact. So,
Doctor, sorry to interrupt, just 2 minutes, if it's okay with
you.
Yeah,
it's my final slide, yes. So, 4 enablers of precision resilience, community-driven AI development, standards-led federated governance frameworks, regulatory alignment, and reclaiming agency through socio-technical standards and AI as a living therapeutic. So this is what we're trying to achieve, and this is the Global Public Health Forum that we're about to inaugurate today. Thank you for your attention, and thank you also to the committee for inviting me to speak to you today about our work.
Dr. Kalogeropoulos, very insightful and interesting presentation. It would be great to have you here because we would have the opportunity to discuss more about this, because artificial intelligence in this domain is a very challenging and important topic. We would like to thank you and given the opportunity to wish you the best with the inauguration of the unit that you mentioned at the introduction. If I understood correctly, it's happening right now. It's going to happen in a few minutes.
Yes.
So best of luck. Best of luck with that.
Thank you. Thank you so much.
Thank you very much.
And thank you for the day.
So it's my honor to present the next keynote speaker, Professor Jean Chiard, who is director of the Climate and Atmosphere Research Center, KRC, of the Cyprus Institute, and grant holder of the MCARE Horizon 2020. Furthermore, he has established state-of-the-art observational infrastructure, such as the Cyprus Atmospheric Observatory and UAV-based atmospheric sampling systems to monitor pollution across the Eastern Mediterranean and Middle East. His lecture topic, I would say it's very interesting, is about air pollution over Cyprus and the broader Eastern Mediterranean and Middle East region, impact on air quality and public health. Thank you very much.
Thank you very much, and thank you for inviting me at the University of Cyprus. Last time I visited this university was from the invitation of George Bustas some years ago at his center, and I'm very happy to come back again, impressed how this university is growing and developing. So I will tell you a bit more about what you breathe every day in Cyprus, and give you a brief introduction of what we are talking about. Air pollution, and more specifically about PM, particulate matter, the particles in the air responsible for pollution, and give you some methodology we have been using to document this pollution in Cyprus, and give you some findings in Cyprus, but relevant also for the Eastern Mediterranean and the Middle East region, the EMA region. Okay, air pollution. First of all, it's a matter of perception by citizens, and if you ask the European citizens what are the two most important environmental issues, they will tell you climate change, of course, but air pollution comes second. So it's something that matters a lot for citizens. Now, if you ask them, what do you think over the last 10 years that the air quality in your country has improved or degraded? Many of them say that it has degraded, but especially Cyprus. Cyprus has the highest proportion of citizens considering that air quality in Cyprus has deteriorated. Is it true? Is it correct? Is it with data? Actually, unfortunately, it's true. And if you monitor the premature deaths due to the fine particle matter, PM2.5, over the last 20 years in Cyprus and the EU, you see that the trajectory of the EU is towards a great improvement over the last years, where there is no improvement anymore in Cyprus in terms of air quality, and Cyprus will hardly reach the target set by the EU by 2030 of minus 55% reduction of premature death. Now, if you translate it also in terms of money, because all the time you transfer what is the life loss in terms of economic cost, the welfare cost due to premature death of air pollution, and especially about PM2.5, is as much as 3.7% of the GDP of the island. And I wanted to bring this information compared with the amount of money that the country is investing in research, which is less than 1%. So you understand why it's important to invest in research, because it has very strong economic impacts. Now, in terms of premature death, if you like the main cause of this premature death, air pollution, indoor and outdoor, comes third, but then if you look at the breakdown between the outdoor and the indoor, outdoor pollution is responsible for more than 4 million premature deaths in the world. In Cyprus, it's about 700 premature deaths. Now, if you translate it into economic cost, is what I told you, it's for Cyprus a bit more than 3% of the GDP, and it's about almost 1 billion euro. It's not that small. There is different impact on pollution, which are short-term impact or long-term impact related to the exposure of air pollution. And basically, you have to remember two things. When you breathe air, what matters when you breathe these particles is the size of the particles and the chemical composition. The size, because the smaller they are, the deeper they enter in your lungs. And then as nanoparticles, they can cross the barrier of the lungs and travel all around your body, up to the brain. But also the chemical compositions, because many of them are cancerogenic, toxic. The sources are wide. For the man-made aerosols, you know very well that traffic is one. Biomass burning is a very important one as well. I will show you more. Industry, shipping. Natural sources are typically the sea salt you breathe, the desert dust, the smoke of forest, volcanic ash. Now, if you want to look at how they look like, these small particles that you see in the air, they have a very different types of shapes. Mineral, like dust, black carbon, soot, sea salt, and even bacteria that you could breathe that are few micrometer. But there are also a lot of pollutants that are in the aerosols, which are not primarily emitted in the air, but they result from the condensation of gases in the air onto the particles. This is important because half of the particles mass is due to this process. Now, if you want to see a little bit more about how small are, how teeny are these particles, this is a human hair, fine sand, and then you see that PM10 and PM2.5 are very, very small compared to these things. PM10 stands for the particulate matter, the quantity of mass of particles per cubic meter below 10 micrometer diameter. PM2.5, PM2.5, PM1, and PM ultrafine, PM01 micrometer nanoparticles. The size is important because I will do it with my hands. Particle up to PM10 will reach the nose, but will not go more than to the throat. PM2.5 will reach the lungs, and as I told you, ultrafine particle will travel all around your body. Now, size is important. I will go very fast. This is a typical size distribution of particles. Chemical composition is important as well, and I will develop this both information later in my presentation. The chemical composition of species can be a lot of everything, inorganic species, carbonaceous species, crystal matter, sea salt, trace elements, etc. Now, the regional context of the pollution in Cyprus and the Eastern Middle East is that, unfortunately for Cyprus, we are at nearby the two largest deserts in the world. This is the concentration of dust in the atmosphere from satellites measurements. So you see that in Europe you have not that much, but where we are, we have a lot from both Africa and the Middle East. But it's not just about natural dust, it's also about anthropogenic pollutions, and these are again satellite measurements of pollutant that is emitted when you burn fossil fuel, when you burn oil. And again, we are, unfortunately, in Cyprus at the interface of two major emitters, the European Union and the Middle East, with completely different trends. Well, you know that COP30 just started, and EU has committed to reduce their CO2 emissions, and they have started already a long time ago. This is not the case for the Middle East, and now Middle East is emitting more CO2 than the EU. Of course, it does not emit just CO2. CO2 is not an air pollutant. It's not bad for your health. It's bad for the climate. But not just CO2 is emitted when you burn fuel. You burn a lot of pollutants as well. And for the best, for the tourism, we have a lot of sun. But for the worst, for the pollution, because a lot of sun generates a lot of pollution as well, like ozone. So we are unfortunately in a region in the Eastern Mediterranean with a lot of sun. I was reading one of the brochures of the European University of Cyprus, claiming that we have 340 days of sun in Cyprus, one of the best places to relocate in the world, but also it has a counterpart. A lot of sun brings a lot of secondary pollution like ozone. And because we are not too far from these two largest deserts in the world, we are the country of the EU which is the most impacted by the desert dust. So these are measurements that have been performed at ground level. And here I give example of different sites. The station, the regional background measurement station operated by the National Air Quality Monitoring Network shows that we have a lot of events in Cyprus. We are the record breakers. And an example of photos that maybe you remember in 2015 if you're in Cyprus, this major dust event which happened for several days, which came from the Middle East. Now the challenge is already here, but will become worse because the EU is putting more stringent air quality directives, and these are the limit values which are currently revised. So if you see the PM2.5 and PM10 concentrations in Cyprus, and this is a report from the National Air Quality Network, I have put here in red the limit values set by the EU. So for PM2.5, we are below, that's good. For PM10, we are just at the limit, but the new directives put all the stations of Cyprus above the limits. So 100% of the Cypriot population will be exposed to air pollution that is not complying with the European regulation. This creates a big problems, of course. This is in front of us, because by 2030, we need to be below the blue line. So what we can do to reduce this pollution in Cyprus. And I will give you here some information, some points that we can look at in the future. So we are working with the local air quality network, and we are working with them in some different places, in Nicosia and Limassol, which is almost representing half of the population of Cyprus, if you include the large urban agglomeration, and the regional background side. We are using what they are collecting, so they are collecting particles on filters, so it's like a vacuum cleaner, you just suck air, and what you get in your filter is what you get in the picture here. When you have a dust event, it looks pretty reddish on the filter, and when you have pollution, it looks pretty gray, like the smoke of your car at the tailpipe. We are doing detailed chemical analysis in our laboratories at the Cyprus Institute. We are also using online measurements within the different types of stations. So what we have learned so far about what we breathe every day in Nicosia, and this is the chemical composition in percent from different types of sources. You will see that 38% of the pollution that we breathe on an annual basis in Nicosia is not produced by Nicosia, but produced by long-range transport, meaning by transport of pollution from the countries which are upwind of Nicosia, upwind of Cyprus. Unfortunately, none of them are European. We are surrounded by Middle East countries, which are not complying with EU regulations. So that's a reason why we have a lot of pollution. So this you cannot do a lot. But you have traffic, 20%, 16% biomass burning. You wonder what it is, biomass burning. Well, it's just what people are doing in the evening. It's not the fire, the controlled fire that you are doing to protect the forest, but it's typically the wood you are burning in your fireplace during winter, either for warming up or just for fun. And this is responsible for a big pollution. Just think of the technology behind. The car is an advanced technology which optimizes the combustion, and a lot of CO2 is emitted, but very few pollutants together. The fireplace is like the prehistoric age. There is no technology behind. You burn the wood like it was burned thousands of years ago with no better technology, so a lot of smoke and pollution emitted at that time. Now, if you look month by month, what we breathe in Nicosia, you see a very big difference. First, you see that during the summer period, this pollution from other countries is dominating the pollution in Nicosia, where during winter, it's not traffic, it's the biomass burning. Biomass burning during this period is more than half of what you breathe. This information is important because every type of source has a different toxicity. The biomass burning is one of the most harmful because it is co-emitted with polycyclic aromatic species, which are very cancerogenic. Traffic as well. Now, what is important for local stakeholders is to understand a little bit what is emitted at city level, that they can have something to reduce, and what is transported over the island. And this, they have to work with countries surrounding Cyprus. So this information we can get by applying different types of methodology. And what we have seen is that when you look at what is received over Cyprus, you have a very strong regional component, which is mostly long-range transport, which is sulfate-emitted combustion, alveol, fossil fuel, sea salt, dust. And what is the local pollution? And these are Limassol residential, Nicosia residential, and Nicosia traffic. You see that more or less traffic and biomass burning are the main local sources. They are the most toxic, I told you. You have also a small fraction of dust, is when you take your car, you put in the suspension the dust on the road. Because it doesn't rain a lot in Cyprus, there is a lot of dust in the road, and it puts dust in the air, and this is what you breathe as well. So the local pollution is important, so local stakeholders will be in capacity to take measures. Reducing traffic, a lot of things is done in Cyprus to reduce traffic or to improve the engines, to switch to electric vehicles. Biomass burning, nothing is done, no promotion to go through a clean combustion process of the fireplaces, unfortunately. We can have tools to better geolocate where are the pollution hotspots, where, when we are breathing pollution in Cyprus, where it comes from. So we can see it for the different components of pollution. Middle East appears always as a main emitter of pollution in Cyprus. You have to keep in mind that this pollution doesn't go as far as Greece. So Greece is never impacted by Middle East pollution. And of course, Europe is never impacted. Just Cyprus is impacted by Middle East pollution for different types of pollutants. North Africa is also a contributor for dust. But most of the dust that we receive in Cyprus is from the Middle East. Turkey and Eastern Europe are strong contributors of combustion with sulfur-containing species, mostly because Turkey has not signed the Gothenburg Protocol, and now SO2 emissions from Turkey is almost half of all the entire Europe. Now, if you look at the long-term trends, I showed you that there is no improvement for the past 10 years in terms of premature death in Cyprus. And these are concentrations of PM2.5 and PM10 in Cyprus. There was a decrease until 2015, but unfortunately for the last 10 years, there is something that is quite stable. But is it the case for all the different types of sources that are making the PM2.5 and PM10? Actually, it is not. Not all sources are stable. The sum of all of them are stable, but each individual is not. So if we go into details of the different sources impacting the pollution in Nicosia, you see that traffic has strongly reduced. So these are different trusses of traffic pollutants, and it has dropped over the last decade by a third. It is a lot, and it is because we have put in the market cleaner vehicles with Euro 5, Euro 6, which emits much less pollutant in the air. So traffic emissions have reduced. Good news. However, if you look at the dust that is suspended by the roads, it has increasing. It has increasing a lot, and somehow when you make the sum of the two, you have no improvement. So basically, if you switch all your cars to electric cars, unfortunately, you will not solve the problem of traffic emissions because your car will continue to put in resuspension a lot of dust in the air, and this will create a lot of pollution. Now, you would like to understand better what are the main sources in the region impacted your pollution, your air in Cyprus, and this is by the different sectors. So basically, Middle East and North Africa are the main regional sectors contributing the pollution in Cyprus, with a large influence of mineral dust from both. More pollution is associated with dust in the Middle East. Now, if you look at a little bit what is the trend of the pollution in the region, because half of the pollution, almost of what we breathe, come from the region. So we need to understand a little bit better how our region in the Middle East is behaving. Again, with measurements we have been performing in Cyprus, we have seen that, unfortunately, there is more and more emissions of pollution in the region. There is no control. I have just 2 slides, and it's done. And it stands for fossil fuel combustion, which emits a lot of sulfur. It stands also for biomass burning, fires, you know, these wildfires we have during the summer period. The region is impacted more and more by forest fires, driven by, of course, drought, heat waves, climate change. So we are also suffering in Cyprus from pollution, transboundary pollution, that is increasing. This will not help to achieve the limit values of the European Union. Conclusions, transboundary pollution, I showed you, dominates what you breathe in Nicosia, about 38%, especially during summer, more than half. Biomass burning during the winter period, your fireplace at your home is the main contributor of pollution in Nicosia and in Limassol, in other Cypriot cities. There is a large fraction of PM2.5 from regional sources, about 58%. Most of the local emissions that local stakeholders can mitigate are related to traffic, but also biomass burning, and I'm sure you have never heard any politics speaking about reducing emissions for your fireplace. The Middle East is the main pollution hotspot affecting Cyprus. Traffic emissions has dropped in Cyprus over the past decade. However, this has been compensated by higher emission of road dust and also by biomass burning. And last comment, increasing influence of anthropogenic emissions from the Middle East. This will not help Cyprus to comply with the European Union EU air quality limit values. Thank you.
Thank you very much. Indeed, very, very interesting data. And of course, here in Cyprus, we have one hobby that we do a lot is to cook on charcoal, especially all through the year, that could affect all this environmental pollution. Thank you very much.
And that concludes our session. On behalf of both of us, I would like to thank you for attending it, and we wish you all a very nice conference. The second session will come with the new chairs, Dr. Pavlos Neophytou and Dr. Pavlos Kosteas in a minute. Thank you.
Good morning. My name is Dr. Pavlos Neophytou. I am a chartered scientist and a European specialist in laboratory medicine, working at the Mendel Center for Biomedical Sciences. My co-chairman, yes, Dr. Kosteas apologizes for not being able to attend, so he's being replaced by Dr. Stefanou. The first lecturer of this session is Professor Giorgos Apidianakis. The title of his lecture title is Toxicity of Colon Cancer-Related Bacteria and Their Metabolomics. Dr. Apidianakis, he was, okay. Shall we move to the second lecture and maybe he can, I think he should be, maybe he can come later after the, move to Dr. Violetta, if possible. He's just outside. Let's do Dr. Violetta's talk first, okay? Associate Professor Dr. Violetta Christofidou Anastasiadou is a clinical geneticist at the Cyprus Institute of Neurology and Genetics and now at Karaiskagian Foundation. The title of her talk is Bridging the Gap, Integrating Polygenic Risk Scores, PRS, into Clinical Genetics for Personalized Medicine. Dr. Anastasiadou.
Thank you. Good morning to everyone, and I would like to thank the organizing committee for this invitation. And it's good I was on time to listen to the previous lecture, which was enlightening. So, since my husband just went through a serious illness, diagnosed with Q fever, Coxiella, Burnetti, and he's not dealing with animals in that way that he could capture these bacteria. So most probably our level of air pollution is much more than what we realize. So I am going to try to go on an overview on integrating polygenic risk scores into clinical genetics for personalized medicine. And are we there? This will be the introduction and the question. So genomic medicine, which is what we are practicing today, merging medicine, clinical practice, and genomics for the care of people and their families, is entering a new era, emphasizing on prediction rather than on diagnosis. Questions and answers, not there yet in this emphasization. So polygenic risk scores are a rapidly advancing tool in genomic medicine because they with this tool, we aggregate the effects of numerous common genetic variants that propose to estimate the individual's risk of inherited susceptibility to a disease and developing the disease. But what is risk? Risk of a disease is not a binary. It is a continuum, and we should remember this. So monogenic, pathogenic variants, although we practice mainly in this field of Mendelian inheritance and monogenic pathogenic variants, do not explain the majority of genetic risk of diseases. It seems that an individual's risk to develop a disease is almost always multifactorial and evolving over time. Our task as physicians and professionals and scientific community is to obtain accurate risk estimation, which is essential for risk reduction strategies. In any case, chemoprevention or reduction surgery or lifestyle changes and furthermore. So through GWAS, we were able to identify multiple common but with lower penetrance susceptibility loci, what we call SNPs, single nucleotide polymorphisms, which can be combined and give us a polygenic score, polygenic risk score, which may indicate the unknown inherited components, at least some of them. So risk is also a continuum. And we all have risks, and this runs from the low to the high of the wheel. But risk also has a very significant difference in perception among humans. So often we have to be very careful when we talk about risks with our patients to explain that an identified risk does not mean a diagnosis. Going to polygenic risk scores, if we try to describe them easily, we try to quantify the cumulative contribution of many small effect genetic variants to common diseases, such as cancer, diabetes, cardiovascular diseases, Alzheimer's, common or not so common, psychiatric disorders, common or not so common, autism spectrum disorder, which is becoming very, very common, and also congenital malformations, and the illustration is from pyloric stenosis, which is one of the commonest congenital malformations that likes very much males versus females. So using GWAS studies, what we are actually doing is we are transformating genetic data into numerical measure of predisposition. Is this okay? Is this correct? Is this enough? And is this safe? To use PRS, we need to integrate what we get through the GWAS studies and reconsider them and view them with the phenotype of the individual, the family, or the population. And of course, populations have different ethnic ancestry characteristics, and some are very homogeneous and others are very heterogeneous. So there are several steps in this effort of describing and integrating polygenic risks into medical practice. What is the proposed application? Clinical risk prediction. So we hope, or we believe, that we can identify individuals at a higher risk for diseases such as coronary artery disease, type 2 diabetes, breast, prostate and colorectal cancer, which are the most frequent, Alzheimer's disease or other deteriorating diseases of the elder age, and several other disorders. This way, we want to achieve preventative medicine, and this preventative medicine is actually looking at a personalized, tailored screening for individuals and their families, for lifestyle interventions that could be based on genetic risk, so prevention. Then the major practice today is in research and stratification, of course. Honestly, PRS are helping us very much to understand genetic architecture and designing clinical trials, because PRS are explaining this non-Mendelian tremendous heterogeneity of inheritance. So therefore, PRS would be essentially and in progress complementary to monogenic testing, because it will help us interpret those too many families, for example, with accumulated cases of breast cancer, for whom we feel that there is a genetic component, but we cannot really touch it and reveal it. So there are several studies using PRS. And of course, Estonia, which has a very homogeneous population and is very keen on clinical studies, has several studies through Estonian women through time that indicate risks, not so important though numerically. And then there are the existing national guidelines by NICE in the UK for breast cancer risk categories, which are mainly using still those guidelines that are based on other classical, let's say, risk factors, and they may want to implicate PRS in this. And there are discussions on clinical recommendations popping out of the PRS application, since to use PRS in clinical practice, we need to establish significant information of the person, of the family, of the community, and also we need to establish efficacy, accuracy, and non-harm. So many studies are working in this area. And very interestingly, cardiometabolic diseases, the community of cardiologists are very much keen for PRS applications. Still, they discuss very, very thoroughly efficacy, harm, and logistics, starting as a discussion over the use of PRS in everyday cardiovascular care, prevention, and management. And there are significant differences in perception between physicians, scientists, researchers, and the public on how PRS are efficacious for these patients or for the population, or are harmless or not, and how do they affect the economy of health. So a lot of questions. PRS for diabetes, another very common disease for discussion. A lot of SNPs influencing the development and the phenotype of diabetes type 2. There is a huge list of genes with minor significance, but and it is still increasing. And autism, an increasing healthcare problem. A lot of studies, a lot of families, concerns and expectations. Very little changes in what we estimated empirically in the risk of a family who has a first child with autism to have a second child with autism of unknown underlying genetic etiology. The same goes for psychiatric disorders. So there is a lot of ethical, social, scientific discussions and considerations about the timing of integrating polygenic risk scores in our practice today. This very nice viewpoint paper in ESHG, just 3 pages, is describing how PRSs are helping very much, or are really very, very promising in specialties like cardiology, psychiatry, rheumatology, endocrinology, and oncology. It also identifies that PRSs may be much more valuable than using classical tests like CRP or MRI of sacroiliac joint, or HLA B27, which is an HLA predisposing to rheumatoid arthritis and so forth. Nevertheless, the discussion is illustrating that what we have today is only data, or mainly data coming from the European ancestry population and much less from other populations. So there is a bias in what we receive as information and applicable utility. There are also very variable public perceptions for the use of PRSs, not only coming from the people, but also from health professionals. And a lot of people say that they are not interested to use PRS services because their physicians are not introducing them as practicable and useful. So there are many challenges in today's practice. Do we really get to an early risk detection? Do we add predictive power at this time in life? Yes, we know that we have improved risk models that rely on age, BMI, cholesterol, and several other factors, but there are still a lot of other factors not being illustrated.
One more minute, please.
Okay. And there are a lot of limitations, and there are a lot of LC discussions. So there is significant academic value for PRSs, but there are still a lot of faults in today's applicability, and we should be very careful and aware of the risk of causing medicalization of what we know as normal diversity in human species, misdirecting our priorities in public health, making people reassured in a fake, false way, or making people anxious and looking at their life with fatalism if the score is high. And furthermore, there are fears for this not ready time for application because of the possibility of offering these products to direct-to-consumer practice, and there is a fear for privacy risks and misuse and several other concerns. So we look at PRSs applied in medical practice, but it seems that we are not there yet mature. Thank you.
Thank you very much, Dr. Anastasiadou. Due to lack of time, we will now proceed with the second talk of this session.
Yes, so I'd like to invite our next speaker, Dr. Yorgos Abidianagis, who's an associate professor in the Department of Biological Sciences at the University of Cyprus. And the title of his talk is Toxicity of Colon Cancer-Related Bacteria and Their Metabolites.
Thank you very much for the introduction, and I would like to thank Dr. Ioannis Patrikios for inviting me year after year in this conference. I would like to talk to you about bacteria, toxic bacteria, and some that counteract this toxicity. On the one hand, in the lab, we're dealing with Drosophila basic research, so we have the Drosophila Biomedical Research Unit, and we also run the Cyprus Intestinal Health Study for colon cancer prevention. And yes, there is a way to make a meaningful joint analysis of the two. We are working on colon cancer prevention, as I said, which, as you very well know, is a major clinical problem with around 2 million cases every year. the third most diagnosed, and the second deadliest. So there are well-established risk factors, vague though, risk factors of CRC, old age, which actually appears to lower, the limit is lower and lower these days. So the screening was for 50 years and above, and now it's lower than that. Ethnicity has a role, family history, of course. Diabetes, inflammatory bowel disease increases the risk by much. And then there are the more loose factors, diet, lack of exercise, obesity, smoking, heavy use of alcohol. But nowadays we talk a lot about microbiota, and they're implicated in all diseases, and definitely in this one. So in 1884, I think, Koch described his postulates. It was a way to define a microbe as an infectious agent, and he had established 5 rules that if these apply to the microbe, then the microbe is an infectious agent. Now we can make a modern version of that regarding a microbe being implicated in a disease. So 1, 2, 3, the simplest version of that is a microbe has to be linked to the disease. It doesn't have to be always present, but it has to be linked to the disease. Rule number 1, we have to see that in humans if we're talking about clinical research. Then step number 2, we have to verify that this microbe can cause a disease. So we have to test it in different settings to realize if it has to do with, if it can cause the disease and how it might be causing the disease, so that we know more about its capabilities. And the third, of course, would be to eliminate that microbe in humans and see if that changes the outcome. So if you have 1, 2, 3, you prove your case, and we shouldn't need any more evidence in order to establish a microbe as a causing agent. Are there any bacteria that consider causal to colorectal cancer? Yes, these 3, Fusobacterium nucleatum, Bacteroides fragilis, and E. coli, particular much causality about them. So Fusobacterium nucleatum is very potent because it's found usually in the mouth, in the oral cavity, and it travels to the intestine in case of tumors, establishing and promoting tumors. That's very potent. Its function is very potent. Now, Bacteroides fragilis and E. coli are always there. They're opportunistic pathogens, but they can cause disease only in some people under some circumstances. So that's the most common way of bacteria and factors being implicated in disease. That is the opportunistic nature of many, many different factors. And the point is why such bacteria can cause disease in one case and not in the other case. An extreme case of that is, for example, a Helicobacter pylori, that on average half humans on Earth may have it, but it causes disease to very, very few people. So definitely things to consider regarding the ability of a microbe to cause disease is what else is there, that is what other microbes are around that microbe, especially if we're talking about the intestine, which has many, many different microbes. Also, of course, the intestine itself, its whole physiology and its factors, regeneration being a major one, and the metabolites that surround the microbes and the intestine, the intestinal cells. So one example of the importance of such interactions, and I'm going to focus on bacteria-to-bacteria interactions, although there are many, is what we studied regarding Pseudomonas aeruginosa, an opportunistic pathogen, and its interaction with E. coli, the symbiotic E. coli, the one that doesn't cause disease but help us actually sustain a healthy gut. What we found is that, for example, in flies, we saw that the green line shows if we infect flies with Pseudomonas, then all flies die within hours. If we infect them with E. coli, this particular strain of E. coli that is not harmful, it doesn't kill any flies. And if we add both of them, then pretty much animals are saved from death. Most animals are saved from death, which means that E. coli can help against infection. So we screened for genes that might be doing that is genes of E. coli. We screened the whole genome of E. coli for factors that might help against Pseudomonas aeruginosa, and we found that lactic acid, the production of lactic acid by E. coli, can help inhibit the growth of Pseudomonas aeruginosa. We've seen that in mice. We gave antibiotics to mice, so they are susceptible to Pseudomonas, which is usually the case due to its opportunistic nature. If we, and that happens in humans a lot, if we consume a lot of antibiotics, then we are more susceptible to infectious diseases. Then we gave E. coli along with Pseudomonas, and we see that we can save many mice from death. And actually, data that are not shown here is that if we provide E. coli, the mutant version of E. coli that doesn't produce the lactic acid, it cannot do that, cannot benefit against Pseudomonas infection. Thinking about such interactions, we tried to screen many different combinations, that is combinations of, let's say, bad microbes, virulent microbes, the ones on the top, and try to see what happens if we combine them with other microbes, many of them being virulent also. And to our surprise, we found many green interactions. Green means that although a microbe might be virulent and you add it along with another virulent microbe, you end up with a positive result. And that's the green cases, which were many more than the red cases, which were what we would expect. If we add a virulent bug and another virulent bug, putting them together, you're going to make it worse. And actually, in many cases, we found exactly the opposite. That was to our surprise, and we take advantage of that information because the previous microbes I showed to you were human microbes. And so along with the Cyprus intestinal health study, we developed Drosophila as a translational tool in order to see which microbes have harmful potential, and in combination with other microbes, what is the outcome of that. We have studied many aspects of the gut, but of course the bacteria and their volatiles through volatolomics, an aspect of metabolomics. In the intestinal environment, we try to see the metabolites and the microbes and how they might be affecting toxicity in the gut and the prospects of CRC. So for example, we found that two bacteria in green here, Faecalibacterium prausnitzii and Phascolartrobacterium faecium, are more prevalent in healthy people as opposed to cancer-prone individuals, while Bacteroides intestinalis is found more in cancer-prone individuals, and we think that might be an instigator, or at least might be, under some circumstances, contributing to disease. So we established a protocol so that we assess the volatiles and that are emitted from feces and the intestinal epithelium in general. And we also try to see what bacteria per se might emit, and we analyze that. We can identify many different volatiles, chemicals that are produced in the fecal environment. And we also can establish interactions between specific bacterial species and metabolites. That is, nonetheless, these are associations. So we can associate microbes with metabolites. So if one increases, the metabolite, if a microbe increases in numbers, then the metabolite increases. So but that's only an association, and we want to find causal factors. Thus, we establish a protocol to see if bacteria that we isolate from human gut, what metabolites they produce, and what the effect of these metabolites might be, in combination with others that are produced by potentially beneficial bacteria. And we test that primarily in mortality, in rate of mortality, and also the ability of the intestine to regenerate, two main outputs. So on the one hand, we found that intestinalis per se, and its supernatant that is not shown here, is more toxic than other bacteria, and when in combination with other bacteria, The commensal ones I mentioned, shown in green, then its effect is less, so its toxicity is less. We also find quite important effect on intestinal regeneration. So intestinalis tends to dampen intestinal regeneration, which is vital for the health of the organ. But the commensal bacteria, if given along with the intestinalis, they mitigate that effect. So pretty much saves the regeneration capacity of the gut. The next step, this study is still unpublished and ongoing, so I'm not going to give you many more data about that, but I'm going to explain to you our efforts. So we are assessing now the metabolites that these bacteria can produce. We have
One more minute, please.
Yes, all right. So we have metabolites that are produced, and we made heat maps of this. So in orange, you can see what microbes can produce, intestinalis and the other two. We can pinpoint many factors that are produced. Those in blue are metabolites that are consumed by the bacteria in the media. So we have a list of chemicals that are produced by intestinalis, and we are assessing their potential, as we speak, we are assessing their potential for toxicity, and also we are focusing on one chemical, benzanoic acid, that is higher in healthier individuals as opposed to cancer-prone, and this is produced by the two commensals I mentioned to you before, and that's where we stand. I would like to thank the people involved. Thank you very much.
Okay, because of time, I think we'll go to the next speaker. Thank you once again, Dr. Abithenagis, for an excellent talk.
The next speaker is Professor Yorgos Spyrou from the Cyprus Institute of Neurology and Genetics. The title of his lecture is Network-Based Bioinformatics and Multi-Source Data Integration, Targeting Epstein-Barr Virus, Multiple Sclerosis Understanding, and Drug Repurposing. Dr. Spyrou.
Thank you. Thank you, Yannis, for the kind invitation. I'm very glad to be here to present bioinformatics aspects of interactions. It was great to listen from Yorgos Abithenagis, the interaction studies before. So we will see now how we can deal with bioinformatics to bridge together something that we know that it is connected, Epstein-Barr virus with multiple sclerosis. So we know that EBV infects more than 90% of the population, and at the same time, MS is a chronic autoimmune demyelinating disease. We have data that indicate that EBV is a requisite risk factor for the development of MS, and we are sure that we don't know yet what is happening during this triggering. There are studies that have confirmed that more than 99% of patients with MS have been infected with EBV, something that is importantly higher than the seroprevalence in the global population. And this EBV seroconversion increases the risk of MS development by 32-fold. Also, we know that there is an early sign. So after EBV seroconversion, the levels of biomarker for neuroaxonal degeneration increased. So we understand that we can catch something early enough. And at the same time, we know that it is not a one-to-one relationship. So there are other factors, genetic, lifestyle, more than the EBV infection that triggers MS. EBV, we know that it is a double-stranded DNA virus. It is transmitted by saliva and infects oral epithelial cells, and introduces a variety of different programs within B cells regarding and depending on the stage of the B cell. There are two hypotheses of activity and triggering. The driver hypothesis, that it is based on the periodic EBV reactivation that drives to the pathogenicity of the autoimmune response, and the hit and run hypothesis that it is the more direct one that causes immune dysfunction that finally leads to the central neural system autoimmunity. In our lab at the Cyprus Institute of Neurology and Genetics, we gave the first PhD topic early enough COVID. So our PhD student, Anna Onisiforu, did a great work. We published 3 publications. Now Anna has her PhD and works autonomously in the University of Cyprus. But also we did other works that tried to combine together viral data for COVID and for drug repurposing as well with the Virtu drug developed by George Minadakis. So we had an experience, we were exposed to the so-called viral bioinformatics, and almost a year ago, we were very lucky that we joined 2 consortia, European consortia, that they deal with this theme. So Behind the Mess tries to understand why Epstein-Barr virus triggers multiple sclerosis, and this will be done through in vitro modeling of multiple sclerosis and EBV infection, and with developing animal models of prodromal MS that will identify new pathogenic mechanisms and design new treatment approaches. So we are the bioinformatics part that will connect the dots and try to find hypotheses that some of them, they will be based on the data that will be derived. And the other consortium, it is IMBMC, that tries to find drugs. And the hypothesis is whether we can hit Epstein-Barr virus to treat MS or to, let's say, have a positive response. Also, we will have the opportunity to analyze single-cell data and bulk data as well, integrate data with lifestyle and omics to generate profiles, because bioinformatics generate profiles, and then by having this multi-omics or multi-source data integration, we can understand better what is happening, or we can feed AI algorithms for better predictions. So we have very nice teams already assembled within our department. And now I will share with you some very preliminary results that they deal with the cell type specific roadmaps of EBV strain protein interactions in MS subtypes. So we gave resolution, we worked with several strains of EBV and also with several types of multiple sclerosis to understand what is happening in the interactions between virus and host, and at the end, MS triggering. So we collected data from specific databases for the 4 subtypes of MS, and finally, we had the opportunity to have commonalities and unique findings between the MS types. Now I am just highlighting the common thing. So between the 4 subtypes of multiple sclerosis, we can see the obvious. So we can find genes that are related with the immune system, signaling by interleukins, cytokine signaling in immune system, and other related pathways. But also there are interesting findings with the unique between these subtypes, and also the viral interactions between each type separately that will follow. Also, we work with EBV human-host interaction, so it was a tedious effort to collect, analyze, and connect these dots, having the interactions between EBV and the human host. So we collected from several databases what exists for 3 strains. We found data, and then we generated the EBV host interaction, and from there, we as you see, it is a herbal, so we understand almost nothing. But behind the herbal, we can find numbers. And here comes network science and graph theory to find the topologically meaningful nodes that are either hubs, so multi-connected nodes, or bridges that they connect modules of specific interest. But if we try to give more cell-specific content to this herbal, we have again a herbal, but it is cell-specific then. So we analyzed B cell-specific interactions. So we found the proteins that are expressed in B cells, and we found these interactions and what are the connectors between EBV host and MS, but expressing in B cells, T cells, and also NK cells. So major cell type characteristics of the immune system, and also by highlighting through network science analysis the best connected genes, we can analyze them through pathway analysis and to see again the easiest thing, the common between them. We can see that we have highlights in mechanisms that are related to cytoplasmic translation, ribosomal functionalities, and expression of the genes. But if we go deeper and we try to work only with families of genes and proteins within these cells, there is a more interesting view. So on the left, we have the EBV proteins, and in the center, we have the proteins that are expressed in the B cells, the T cells, and K cells, and non-specific cells. And then on the right, we have the connections with one type of multiple sclerosis, the relapsing remitting multiple sclerosis. So we see this crosstalk visually, but then we can also again analyze and find patterns based on network topology in this reduced network that brings together B cells, T cells, and K cells, and the interaction between EBV and MS at the end of the story. Trying also to bring a view from another point, we designed a Greek P strategy. So we asked ourselves, okay, we have the Epstein-Barr virus MS connection, but we have also the other autoimmune neurodegenerative diseases MS connection, and we have other viruses from the same family that are connected to this disease as well. So we can have other viruses, Epstein-Barr virus, MS, autoimmune neurodegenerative diseases connectivity. And from there, we try to bring together these diseases. We try to generate a specific diseasome, so disease-to-disease network, but only keeping the autoimmune neurodegenerative diseases and the 3 types of multiple sclerosis. And we can see that the neurodegenerative diseases are more.
Please,
but
2 more minutes, please.
But interestingly, we see that MS is related more to the autoimmune diseases and not to the neurodegenerative diseases. And from there, we analyzed more, and we found specific centralities, network centralities regarding this relationship between MS types and the other diseases. And interestingly, all the MS types, they are well above mean regarding their connectivity with others, or their capacity to bridge modules together, or their clustering coefficient, meaning that my neighbors talk to each other even without me. So the diseases that are connected with multiple sclerosis, they share also meaningful commonalities between them. And if we bring this AI neurodegenerative diseasome only around MS, only keeping the first neighbors around MS, then we have this network to analyze and to reduce. And from there, we can see that we have these diseases that they are sharing common with all the subtypes of MS on the left, and we see many autoimmune diseases, including Behçet disease, including Lewy body dementia, poliomyositis, Sjögren's syndrome, etc. And also we have another list that has only commonalities with the most common type of MS, the recurrent relapsing MS. And this is the P scheme. So we have this EBV and Friends network with MS and Friends network. And from there, we're just discussing, I just saw the preliminary results of sharing common drugs between the nodes of this P. So we can see that there are common drugs shared between MS and other diseases in this spectrum, MS and viral infections, etc. And from there, we can highlight drugs that can be transferred from the one side of the P to the other, so they will promote drug repurposing. But this is not the only one. They will promote even more understanding through the drug targets that we have and the pathways that we can see. For example, this NR3C1 is a very interesting target that is related to stress hormones, and also it could be related to the awakening of EBV latency. With this, I would like to thank the teams that work and produce these results. I would like for you to stay tuned for our new results, and thank you for your attention.
Thank you very much, Professor Spyrou. Now we will move on to the next lecture.
Okay, so the final presentation in this session is by Terry Birvolakis, who is the CEO and founder of Albida Therapeutics, and the title of his talk, From Hope to Pipeline, a Social Purpose Playbook for Rare Disease and Gene Therapy. We're finished. This session's closed then. So, okay.
Could Mr. Alexis Papadopoulos and Professor Apostolos Papalois please come to the chairing desk?
Good evening, everybody. It is my great pleasure and honor to co-chair with Dr. Alexis Papadopoulos the next third session in the 13th Multidisciplinary Approach Biomedical Research Congress. And I would like also to take the opportunity to congratulate Professor Ioannis Patrikios for this worldwide international well-recognized institution. So we are moving now to our program, into the first presentation from Dr. Antonis Kakas. The title of his presentation is Computer Science and Biomedical Research Center. Professor Kakas is from the University of Cyprus.
Right. Hello, everybody. Let's talk about AI. I'm going to change a little bit my talk to my presentation so we can talk about AI. If you would allow me, cheers. What do? Put my glasses, do this. So let's first ask this question: what is the goal of good AI? And it's nothing more than helping the human mind do its job, whether it's scientific or whether it's anything else, medical, entertainment. It's just the tool to help to enhance the human faculty of thinking and therefore to catalyze good reforms in our society. So a good principle for good AI is recognize the difficulty there is to reproduce intelligence, have artificial intelligence. Don't be so, I would use the word, cocky, that you can surpass human intelligence, and work with human intelligence. The father of AI, which is not Hinton or whatever, is Turing and McCarthy, recognized from the very beginning that this is not an easy problem and that there will be no perfect super intelligent systems, and you can start from there. So therefore, allow your systems to be fallible, or at least when you design them, allow them to be in a dilemma, to come up and say, well, I'm not sure. It could be this disease, it could be that disease, it could be malignant, it could not be. But I'll give you the reasons why. Okay, so the upshot of this is keep the human in the loop, work with the human, and develop AI systems that will enhance the human faculty of thinking, and we will enhance the job of the medical practitioners or the medical researchers, for example. The thing to remember, and it's very important, is that this intelligence that is portrayed in these AI systems that we have all around us is not theirs. It's actually the intelligence of the human. It's a reflection of the developer or the user of the system. Probably all of you are using LLMs. Do you know what LLM is? LLM, an example of that is ChatGPT. And you might be amazed by what it does. But let me tell you, it's just reflecting your own intelligence and your own expertise. Believe me, that's what it's doing. So therefore, if you want to do good AI, you have to promote this human-machine interaction. And one thing that AI needs to provide is this explainability. You should not just say, yes, this is 80%, 85%, 90% accurate in diagnosing or predicting that this is the protein fold structure, or this is a malignant tumor, or this is not. It should be able to explain it in the same way that a fellow doctor will do, so that we can join together forces and move ahead. And this explanation should be natural, should be at the same kind of cognitive level as humans, and they should have this very important thing that's lacking at the moment from the AI systems, is they should be coherent and forthcoming. They should tell you frankly what are the assumptions on which they're basing their prediction or their position. And therefore, this explanation should be a seed for further debate and change. So let me give you an example. You probably heard about this AlphaFold that got the Nobel Prize in chemistry. One of the people was half Cypriot, Demis Hassabis. The intelligence is not in the algorithm. The intelligence is in the deep mind, or metabolics or whatever, okay? But it is worthy of a Nobel Prize because it's the analog of a microscope or a telescope. And the future drugs that we hear are going to come from this organization, and that people there, and Demis also talks about it, but he talks about it carefully, although in the press it's portrayed quite differently, that somehow magically this AI is going to give us new future drugs. The actual future drugs are going to come from the humans who are using this powerful microscope to do their work. Okay, and we are doing similar things here in Cyprus, in the sense that instead of billions of budget, we have maybe 10,000 a year, maybe less. But what we're doing is we are trying to work with the human with the experts. And here you see just an example of how we're trying to get feedback from the theories that we are developing. In this case, we give a full explanation, a verbal, a visual explanation, and then we're trying to get feedback, and we're asking what are the dominant set of features that support the asymptomatic prediction. You tell me would additional features overturn this for this case. So this is the process we need to do to actually have a good evaluation and to actually work together with the experts to improve our systems. And these kind of mainstream AI things, black box, cannot do that at the moment. You need to work with a less budget. It's not big, it's better. You need to bring in the human like that. So therefore, I want to stop here and invite you to ask me anything you want about AI, because I'm sure you have hundreds of questions in your head. I see outside November is the AI month of the university. Ask me. I've been working in AI since '89. Ask me anything you want. You'll get an honest, non-biased, non-market-driven opinion. Thank you. If you don't want to ask, then more time for the next speakers.
So, Professor Kagas, thank you for the nice introduction. Yeah, we can ask anything. You can ask anything you want for AI, especially in medicine, as that was a very nice kickoff to start with. Yes.
But I alluded to it, but the AI is cocky AI. Do you know what cocky means in English slang? But AI is what we hear from the tech colonialism companies who are promising super intelligence in 5 years, in 10 years, in 15 years, and that we will not need to do anything. We will just have these super intelligent machines that will solve all our problems, etc. That's bad AI. That bad AI that is AI that doesn't recognize the supremacy of the human mind.
Can I ask something? So I think we're convinced that AI will not replace human minds and human beings. But what about certain specialties in medicine? For example, radiology. I mean, you can reach an 80–90% of coverage from AI, I guess.
I got the point. So, but that's the whole point. You have to do, that is a tool, like AlphaFold is a tool that AI provides, and it's there to enhance you, the radiologist. Are you a radiologist? I don't know. No. So, you, the radiologist, that's what it is, okay? And this 89–90%, do you trust it just by the figures, or would you trust it more if it was explainable? It could tell you at the cases that Y is predicting one or the other, and it also has to do what humans do as well. Where is it? Where is it? It should also be able to come and say, I don't know. Tell me the cases I don't know. What's happening in, let me tell you something about research in AI. What's happening in research in AI is this factor. I want to bring my accuracy to 89, 90, 95, 96, 97%. Okay. By doing that, actually, you mess up your model. Why? Because you're trying to force difficult and complex cases into the mainstream measure of your accuracy. Instead of saying, well, there are these cases, maybe 10%, 15%, which I cannot really decide, take them outside, and then your accuracy on the ones that you can decide will shoot up to 95, 96, okay? And those that you don't understand, if you can explain them, then you can get feedback, and then you can proceed and continue your study on these difficult cases. This is the kind of approach that we take in these various studies that I've been saying. Okay.
Professor Kakas, further to the question of Dr. Papadopoulos, I would like to hear and I guess the audience, your vision, your opinion about the future concerning the quality and reliability of the data used from artificial intelligence. Who is going to be responsible for it? Medical association, medical schools, big organizations, independent organizations? We'd like to hear your opinion.
Yeah, I had a slide for that, because it's a standard question. Okay, I have an extreme kind of position on this. And maybe I can say it here, and maybe you can understand it easily. I think AI should be treated like the pharmaceutical companies. If you want to bring something out, a drug, a vaccine, or whatever, pass it through clinical trials, and then bring it out. Pass it through clinical trials for what? For toxicity in the mental and societal world. This is the way we should move. And I think this is the way we will move. At the end, this is what's going to happen. Okay? You cannot just sell general. It's like now AI is being sold as a vaccine or a pill that will unregulated and that will solve all your diseases. Okay? You need to start saying, okay, look, bring me task-oriented systems. Tell me what this system is supposed to do. Let me pass it through trials. Okay, we need to define what is a trial, okay, for AI. But I guess I've been reading about the history of pharmaceutical regulations that are very, very useful for anybody who's interested about AI ethics, because you can see the history there. And somehow follow that path where in our society, any artifact is not allowed to go on the open market unless it's been certified in some way. Even this thing here. So that's the way to go. Thank you very much. I'm happy to answer questions. If you want to read. There is this article. It's very easy to find, called "The Pollution of AI." If you put that CACM, you will find it. And if you want to read Greek, I have a kind of a popular article on my website that will tell you about these things. Sorry to take a little bit more. Bye.
Thank you so much, Professor. So it's my pleasure to invite the next speaker on floor. The next speaker is Mr. Michalis Kythrotis. He's the Managing Director of Kostas Christodoulou Company Medical Equipment. Michalis shows particular interest in the transformative role of AI in medical imaging, especially its potential to improve diagnostic accuracy, workflow efficiency, and patient outcomes. Michalis, thank you for the speech.
Thank you very much for the invitation to participate in this very important congress. I'm touching a very hot topic, and following the previous presentation, I hope that I will give some insight on how an AI can enhance radiology. So, AI in radiology has become from a concept to a reality. So AI now is a daily reality in the radiology world, and it tries to enhance the accuracy, the workflow, and the patient care. And we can see its adoption into various modalities. As very rightly Professor Kakas says in the previous presentation, AI is not here to replace humans. So which are the current trends in AI in radiology? In this presentation, we will see how we can see some workflow automation and smart triage, especially in X-ray, screening in programs like breast and lung, CT lung. And we can see how cloud-based tools are also used to help us get better and faster results. How does actually AI enhances radiology? It improves the diagnostic accuracy, as we will see in some of the tools that we can utilize today. It reduces the reading times, especially for the, let's say, more simple cases for the radiologists. It streamlines workflows, and it supports the decision-making of the radiologists. We will see later some clinical applications across modalities. For example, in X-ray, as we said before, triage and detection of urgent findings, breast cancer screening, and in MRI, cardiac and prostate reporting, as well as faster scans. If we're about to, let's say, divide the main MRI AI tools, we could divide them in, let's say, the ones that they are able to detect and give some abnormalities, and the ones that they can make the scans faster. So, in practice, they help us to detect abnormalities, as we said before. They generate some automated reports, but at least in EU, there is no first written reporting. It's always validated by radiologists. It triages critical findings, and it enhances the image quality and reducing the scan time. Let's go now and see some of the, let's say, leading AI companies that they try to help in the radiology work. I just selected 6 companies here. Of course, the time is not enough to get into the deep waters, but just touch some base. So Milview is a French company that has workflows for triage and reporting in X-ray. Agfa is also an X-ray company that has early warning systems for critical findings. Therapixel is a French company again that has a system for breast cancer screening. Medicus Imaging is a Dutch company for quantitative cardiac imaging. Deep Health is a company that has several AI tools. Today we're going to look only at prostate MR. And Subtle Medical is a US company with tries to image enhancement for faster MRI scans. So, Milview, what does this AI software do? It processes X-rays to detect pathologies and assist in the classification of and prioritization of examinations, that triage we have told you before. The anatomical areas covered by this system is thorax, foot, ankle, hand, fingers, wrist, elbow, shoulder, knee, pelvis, clavicle, hip, scaphoid, and femur. And which are the pathologies detected? We get some fractures, dislocations, periarterial collections, pulmonary nodules, pneumothorax, and pulmonary opacities. And actually the system automatically measures this in the number of the anatomical areas. So as we can see here in the diagrams, there are annotated squares precisely pinpointing the detected anomalies. We can also filter the system to automatically prepare a preliminary report, which can be easily edited by the radiologist. And this is the idea, that these reports would not go out before the radiologist approves them. So a very important message from the company is that the AI tool is here not to replace the radiologists, but to make them irreplaceable. Is for them to save time for what matters most and the patient's health, and to focus in, let's say, more complex cases. Another system we can look at is from Agfa Radiology Solutions, the ScanXR in critical scan. This is at the radiography level, not at the radiologists, where a patient, when goes into the X-ray department and has a scan, you get a critical alert of certain pathologies, and this accelerates the communication between the radiology and the clinical teams. It improves the delivery of patient care and avoids the patient recall, so that the patient would not leave the X-ray department of the hospital before it actually, when a pathology is detected. Another system from Therapixel for MammoScreen has to do with breast cancer screening. This allows the radiologist to validate the suspicions, identify what they might have overlooked, and focus on uncertain studies requiring more attention. This is available in both full-field digital mammography as well as digital breast tomosynthesis. So it allows the radiologist to detect and characterize suspicious tissue or lesions, whether likely to be cancerous. They can use it concurrently with their current breast imaging viewer, and is synchronized with their worklist coming for the PACS. What is very, let's say, unique for MammoScreen is that they have the Mammo score to provide an immediate level of suspicion scoring for screening. This score ranges from 1 to 10. So to confirm the certain findings and pointing out unsure cases that demand further scrutiny. It increases the confidence and works in hand with the radiologist's viewer, and it enhances the efficiency as it helps to read faster the benign cases, so the radiologist can, let's say, focus on the most complex cases. The fourth system that I would like to see today from Deep Health is prostate MRI. This is a very specific AI tool that supports the clinical imaging using AI for the interpretation of prostate MRI examinations. And which are the benefits that this system gives? It simplifies the reading process. For example, it completes the PSA density calculation. It interprets this using artificial intelligence, the segmentation of regions of interest, and it gives valuable results in a standardized and comprehensive report. The key features of the system is very user-friendly interface. You can get customizable hanging protocols, seamless integration into the existing workflows. You get individual lesion overview, which, for instance, includes volume location per PI-RADS region and PI-RADS scoring. And you get automated prostate segmentation results, for instance, prostate volume and PSA density. Finally, you get a visual representation, for example, a 3D rendered key images for a lesion in the prostate gland. Metis, as we said before, is a Dutch company that gives mainly solutions in the MR and CT field. We're going to touch now only on a system AI tool that saves time and validates solutions for cardiac MRI post-processing. This AI tool excels in evaluating heart structures and functions with advanced algorithms powered by AI. It is vendor independent. It enables quantitative assessments of the heart function, strain, perfusion, viability, mapping, and flow in 2D and 4D. And these systems can be seamlessly integrated into healthcare IT systems and data records, for instance, the PACS. Its key features: it gives valuable insights into the heart's function through comprehensive assessment of the systolic functions based on volumetric measurements. It evaluates the blood flow in greater vessels to better understand the patient's cardiovascular condition and diagnose the underlying cardiac diseases contributing to reduced cardiac function through advanced tissue characterization analysis. The final AI tool we're going to look at, it doesn't have to do with detection, but it's actually a system that it falls into the second category, as we talked before, is the one that gives faster results. It's a system, Subtol MR by Subtol Medical in the US, that is FDA approved. And it helps in the quality of accelerated MRI protocols using sharpness enhancement and denoising. It actually puts noise and then takes out the noise through the AI tool. It's applicable for 99% of the MRI procedures. It can be used with any scanner and field strength and is easily implemented with no change in the workflow. As we can see in some of the pictures below, you can get up to, let's say, 50% in some brain MRI or in some...
Dr. Githiotis, 1 minute left.
Okay. And this software is vendor neutral and it achieves additional time slots, improves patient comfort, and extends the lifespan of your MRI. Now that we have seen all these MRI tools, it is important to say that these tools are clinical decision support and not a replacement. The AI complements the radiologists, and as told in the previous presentation, and it does not replace them. It documents the interpretation and consistency and lets the radiologist focus on more complex tasks. The benefits are both for patients and professionals because we get faster diagnosis and treatment, reduced workload and burnout, improved accuracy and outcomes, and broader access to expertise. So we get an evolving role of the radiologist, which is a supervisor and validator, greater focus on the patient care, and enhanced multidisciplinary collaboration across specialties. And the key takeaways of this presentation: AI is here and is actually transforming the radiology world, but it enhances the accuracy and efficiency and gives better results, and the radiologists remain essential for the quality and trust of the results we give to the patients. Thank you very much for your attention, and I hope I gave you a good presentation.
Mihaly, thank you so much for the nice presentation. Any questions? Professor Kakas?
I was very pleased to see the mammo screen case, where it had this yellow part in the middle, which is this dilemma thing, which, as I said, it should be part of all AI systems. They should be honest and say, in these cases are difficult cases, and I don't know how to do it. The other thing I wanted to ask is whether the prostate thing by deep thing, is actually the one that the UK NHS has announced that they will use now, this use AI analysis to help them in the management of prostate cancer, what kind of treatment and triaging.
It might be the one, because Deep Health comes from the UK, yes, so it might be the one. I don't know if it is actually the one, but we can look into it and see if it's actually the one. And I know, like in our country also, they try to see screening, especially for the breast, to apply AI, and probably they will try to implement a system in the screening, at least for mammo. I don't know for maybe CT lung, but maybe for prostate, MRI may come later as a program.
Anyway, thank you very much. It was a very nice talk.
Any other questions? Okay. Thank you very much for your attention and the invitation.
And now we are moving to the last presentation of this AI session. I would like to invite you, Dr. Prodromos Kaplanis. Dr. Kaplanis, he is an adjunct professor in the School of Medicine at the European University of Cyprus in the branch of Frankfurt, and he is currently president of the Cyprus Association for Medical Physics and Biomedical Engineering. The title of his lecture is Trustability and Reliability of AI in Radiation Protection.
Thank you very much indeed. Well, may I start by congratulating the organizers, and especially my dear friend Patricios Ioannis, and also to express my gratitude for being here among so many scientists with whom I share the same passion, the passion, of course, of biomedical science. Now, the title of this presentation is Trustability and Reliability of AI in Radiation Protection. In other words, can we trust it enough, and is it reliable enough? It has been prepared by me and from a student of mine back in our medical school in Frankfurt. Right, I will start with a brief introduction, and then I will talk about some of the applications of AI in radiation protection, 4 to be exact, and then what do we need to start trusting AI? That's what I call the pillars of trustworthiness. And then I will present a case study from Sellafield, and some conclusions. Right, now, radiation protection by itself is a most complex field, and the slightest of errors can have profound consequences. Imagine, for instance, if we are to estimate, we can't calculate, but we can estimate the dose of a fetus. The mother-to-be has received a lot of radiation, and we need to estimate as accurately as possible the dose the fetus has got. So you can realize that the slightest error can prove very, very harmful. But now we are introducing an even more complex tool in a complex field. But why do we do that? What's the promise? Well, AI promises to have enhanced accuracy in dose calculation, real-time monitoring, automated image analysis, and I will stand in the predictive maintenance. The law in Cyprus says that we have to inspect every single system that delivers ionizing radiation at least once a year. Let's assume that we inspect a CT or an angio, which delivers a lot of radiation, in November, and in 2 months afterwards, the image quality starts to deteriorate. Then the system by itself will start increasing the dose in order to maintain the image quality. We might notice that the dose has increased, we might not notice that the dose has increased until the next time we inspect it. So now we can predict that something can go wrong. The X-ray tube may get gassing, or the image detectors might get bad, and so on. But the core question is, can we trust it enough? So in dosimetry and dose calculation, AI algorithms can now analyze complex exposure scenarios from various sources much faster. But I think the key word is personalized. Let's assume personalized dose estimates. Let's assume I am an X-ray user, which means I use X-rays in my everyday life. There are about 1,500 X-ray users in Cyprus. And let's say that I received 80 millisievert. It's a large amount of dose, but it's possible. And a colleague of mine receives also 80 millisievert. Until today, we assumed that the possible consequences would be the same, but they are not the same. We never took into consideration the personal parameters of that individual, but now we can. In radiotherapy, another application of AI already in existence, we can not only target as much as possible and accurately as possible to the tumor, but we can protect much, much better the nearby organs, the so-called critical organs. In environmental monitoring, I wish we had AI in the 1980s. 1986, 26th of April, 1:23, nearly 1:24 local time, we know what happened. The fourth reactor of Chernobyl exploded. And then there was no way to estimate which areas would be affected. Did you know that areas nearby Chernobyl, some areas nearby Chernobyl, were affected less than areas further away from Chernobyl? Of course, there's a logical explanation. But if we had AI in those times, we would obviously be able to predict which areas would be affected more. And of course, in the nuclear facility safety, predictive maintenance is of the utmost importance. But what are the pillars of trustworthiness? How can we actually start trusting even more AI? It has to be transparent. As Professor Gaga said, we should never take it for granted. To most people, AI is nothing more than a black box. And black boxes are trust killers, as we call them. So we should be able to understand why AI made such a decision. If, for instance, the radiotherapy planning an expert medical physicist has made is different from the one AI has made, the medical physicist should never take that for granted. He should see why the AI has made a different decision than him. Another way to start trusting AI, of course, is safety and accountability. The system must be fail-safe. Humans, for sure, should remain in the loop for critical decisions. We should have clear protocols when AI differs than human decision. And who is to be blamed if something goes wrong? We'll talk about that in the next 5 minutes. Now, we must remember, and again, Professor Gaga's mentioned it, that AI is only as good as the input, as it is only as good as the training processes. The Americans say garbage in is garbage out, and they couldn't be more right. So we have to train our AI system, no matter how small or how big it is, by using comprehensive, impartial, and precisely annotated data sets. Now let's go to our case study. The case study is from Sellafield. I'm sure you know where Sellafield is. It's in the north of England. It used to be the biggest nuclear power plant in England, maybe one of the best in Europe. And since 2022, it's used for processing and containing radioactive waste, but also for decommissioning. So they used AI to help them decommission glove boxes. We'll see what glove boxes are. And the code name of the project was ROBO, Risk Reduction of Glove Box Operations. Now, we all have seen some glove boxes. We all have them in the medical physics department. We have them in the nuclear physics, nuclear medicine department. But they can be huge rooms. I used some huge glove boxes in a visit of the International Atomic Energy Agency in Morocco. Now, the thing is that these contain radioactive materials, and after decades of use, their internal radiation field becomes complex, heterogeneous, and it is poorly mapped. So the problem was humans obviously cannot enter these glove boxes. If they are small, fair enough. You just put your hands in lead gloves and you manipulate the radioactive sources. But if they are big, and they are sometimes they are as big as a room, you cannot enter into those glove boxes and start taking measurements. And you cannot enter them, of course, to do decommissioning. You have to dismantle, as they are doing now in Sellafield, they have to dismantle the robotic arms. But in order to do that, you need a very accurate, safe work procedure for the robotic dismantling. You have to be able to identify what sources were used, are still using in those glove boxes, and of course, above all, to ensure worker safety. So what they did, what Sellafield did, they asked various universities. I think the lead university was Manchester University. They designed a robotic arm, and they placed on this robotic arm many sensors. Sensors like gamma spectrometers, neutron detectors, and LiDAR detectors for measuring the spatial room. And they also equipped the robotic arm with what they called the AI brain. And the AI brain was nothing more than a machine learning model, combination of neural networks and Gaussian progress regression. And that AI brain was trained to do two things. The first was to take point-by-point measurements inside the glove box, small or big, and try and predict the exact radiation fields in a 3D manner. But also, it had to be trained in order to do source identification. So to tell which radionuclides are here or where in the past. Now, if the outcome of the project was just to say there's high radiation here, but it didn't provide any reasoning, I don't think that any engineer would trust enough the results in order to enter into the glove box and start a multi-million, we are referring to multi-million demolition and decommissioning process. So you can realize, of course, that if the results were not accurate and we had an underestimation of the dose, that could lead to very, very serious contamination incidents. On the other hand, if the results were not accurate enough and we had an overestimation of the dose inside the glove boxes, that would lead to excessively costly and complex procedures. So AI had to be confident, it had to make confident predictions from the limited number of measurements it took. Now, the system wasn't built to be accurate only. It was built to be trustworthy. And how was it built to be trustworthy? It was trained. It was trained and tested on huge simulated data sets of radiation fields before it was even employed. And also, it didn't just give us a map. It didn't just say, yes, this is the best I can give you. This is the best estimate of the 3D radiation fields. But it also gave the scientists there the uncertainty map. So it told them, well, I am not more than 95% sure that the dose is 5 millisieverts per second, for instance. So it gave them the uncertainty map as well as the prediction map. Now, of course, it was designed having the human in the loop. Medical physicists or health physicists were there to approve. They had to validate and they had to approve the planning. So the results showed that there was at least a 70% reduction in time needed to survey a complex facility like the ones in Sellafield. But above all, there was a dramatic reduction in human dose exposure, as workers did not need to spend long times performing manual surveys. And then they could start a much safer decommissioning plants because they knew the predicted radiation and the confidence level. So the case study had shown that trust was not given. Trust was not assumed, it was earned, and it was earned through demanding validation. We stressed that, the two previous speakers stressed that. It has to be validated continuously. We have to know the uncertainty of the results. And of course, it is the assistive tool and nothing more. It's not on top of everything, it's just an assistive tool. So in conclusion, AI offers tremendous benefits, no doubt about that, but its integration into our everyday work must be guided by a demanding framework of trustworthiness. Trust in AI, especially in radiation protection, was not given. It was earned, and it's a feature that must be deliberately designed, I beg your pardon, designed, tested, and earned. And of course, the collaboration is of the utmost importance. Collaboration between everyone, regulators, scientists, industry, professionals, and so on. But the key question, of course, is in case something goes wrong, who is to be blamed? But I will leave some esteemed scientists from the past to answer this question through a 30-second, half-a-minute video I have taken from a 13-minute video. I got written consent of the organizers of the video to show to this esteemed conference.
Madam Curie, can I ask, in an AI-enhanced lab, who do you think is responsible when things go wrong? The programmer, the physicist, the patient who signs the consent form?
Responsibility must remain human. A tool is only as ethical as its wielder. Even radium, which cured so many, burned my skin. Radiation heals or harms. Electricity enlightens or electrocutes. AI liberates or manipulates. The scientist's task is stewardship. We must teach not only the science, but the conscience.
And yet, ethics evolve too.
So, with the comments of Madame Curie and, of course, the concern of Nikola Tesla, I thank you very much.
And I'm sure everybody agrees. Any brief questions, please? Or comments from the audience?
Dr. Kaplanis, thank you so much. Thank you. Very nice examples, double examples from the world of medical physics. So what's the final question? Who has at last the authority and who is to blame for if anything goes wrong? Is it the developers of the systems, the doctors, the patients?
Well, it is definitely not the patient, although the patient must sign a consent form that my therapy or my diagnosis is done using AI, but it is not the patient. Many believe it's the scientist who developed the software. Others believe it's the user, but it is definitely not the patient.
Okay, thank you so much. Thank you. I think we can now conclude. Thank you so much. We can move on.
Would the delegates please proceed outside so we can guide you to a light lunch reception, please?
se faz? Ο Αντώνης? Αντώνης σε φάει?
είναι pointer, Γιάννη. Pointer είναι αυτό. Αυτό είναι pointer.
Okay. Okay. Ναι, εδώ. Εγώ εδώ. Εγώ εδώ.
Θα το δείχνω
εδώ και θα το δείχνει εδώ.
Λοιπόν, οκ.
Οκ. Θέλετε να μείνετε και στεναχωρήσετε.
Θα καθίσω, απλώς πήγα να τα δω αυτά.
Ναι, θα πούνε να κάνεις αληθέσιο διαδικτυακά.
Αρχίζουμε. Αρχίσω.
Να κάνει ένα χαιρετισμό.
Okay, let's get started. Okay, first of all, I would like to express my sincere thanks to my dear friend Ioannis Patrikios for the kind invitation to participate in this prestigious meeting. And I hope that you are going to enjoy this session. It's a satellite organized by Sports Cardiology Congress, Greece, and it's going to highlight the 6th Panhellenic International Congress of Sport Cardiology. Now, because the chairman of this congress is Dr. Papaioannou, he is going to give a salutation. And I would like to ask him, Spiro, do you read that?
Good morning to everyone. Yeah.
Professor, welcome. And
thank you.
We are very happy to have you with us today and very excited to hear your thoughts and your views.
Thank you very much. Also, I'm very happy. Dear colleagues, dear guests, it is a great pleasure to welcome you to this satellite session organized in the framework of the Sports Cardiology Congress under the title Lifelong Myocardial Preservation. This topic lies at the heart of sports cardiology. It is a continuous effort to protect and preserve myocardial health in athletes and individuals who challenge their physical limits. Over the past 6 years, the Sports Cardiology Congress has established itself as a leading international event in this field. Each edition has grown in impact, attracting famous experts and clinicians who share a common goal: advancing knowledge, improving practice, and promoting cardiovascular well-being in active populations. Its success is a result of the spirit of the scientific community who support it. We are truly honored to have with us Philippos Triposkiadis and Dr. Elias Kanelos sharing in this session, and our keynote speaker, Professor Dionysios Kokinos, an eminent expert in the field of cardiology. My thanks is furthermore expanded to the second speaker, Dr. Yangu, a specialist in the field of sports cardiology, and also Professor Ioannis Patrikios, who has been not only a dearest friend, but also a great supporter of Sports Cardiology Congress. I would like to thank them all for their participation and contribution to this satellite session. Thank you very much.
Okay, thank you very much, Spiros. When are you coming in Cyprus?
Tomorrow I will be with you.
Okay, thank you very much. Now, it's my distinct honor and pleasure to introduce to you Professor Dionysios Kokinos, very well-known cardiology expert and leader nationally and internationally. I have had the honor to collaborate with him for years also in Greece, also in Cyprus, and he's going to give us a lecture on something that he knows very well. He's an expert, lifelong myocardial preservation. Dear Professor, the podium is yours.
Thank you very much, Professor Triposkiadis. We've been lifelong collaborators, and I also thank Spiros Papaioannou for his kind introduction, and Dr. Elias Kanelos, and of course my dear friend Petros Agathangelu. Professor Patrikios, it is a great honor to be here. I visited once more your university, and it is a place of excellence. And let me tell you that what I believe that a teacher should offer to his students is inspiration, enthusiasm, and a sense of destiny. The scientist, the researcher, the man of art, the lady of law or science should have a sense of destiny, that we are producing something which will help other people. I have chosen this subject. I've been working on this subject for the last 25 years. And as you can see, dear friends, we have seen an improvement in health, that is a decrease of cardiovascular mortality up to our time, around 20, but there is a projection that in the next 30 years, this will deteriorate. Aging is one major problem, and with this comes the term cardiosenescence or inflammaging, or, however, there is therapy that is senolysis. Senility, we can lyse, we can combat senility, and we must fight the risk factors, and of course, we must achieve innovations to reverse this trend. And however you see it, cardiovascular mortality is projected to increase within the next 25 years, mostly by ischemic heart disease, stroke, and hypertensive heart disease, and also cardiomyopathy and myocarditis and others. The end result of all these problems is one, is cardiomyocyte or brain cell death. At the end, some category of cells will die. So this is what we are trying to combat. Okay, and despite all our efforts, and Professor Triposiadis, you are an expert in this, however you look at it, heart failure is increasing globally since the last 30 years, despite all our efforts. And the end result of this is cardiomyocyte death. And it is an end result of many noxious interacting processes, many which we don't really know, mechanical. You know, even an increase in blood pressure will set the stage of the cells expanding, then expansion of the cell brings in inflammation, brings in immediately a stimulus for cell death. A slight turbulence of the flow will cause a wound, a lesion to the endothelium. So mechanical is one thing. Metabolic derangement, oxidation, inflammation, disturbed immunity, ischemia, and at the end you have fibrosis. But again, even fibrosis may bring about cell death. So you see that there is an interacting vicious cycle all along. And the horses of Poseidon, of Neptune, are set into motion. The tempest comes with final result, cell death. I have been working, as I showed here, we had our first Congress on myocardial preservation in 2009, and we produced a book in 2019 on this subject, myocardial preservation. I don't want you to see this slide. It's very busy. But what I want you to show is that you have many types of cell death. Ferroptosis, apoptosis, autophagy, necroptosis, pyroptosis, mitophagy. And you can see the extremely busy crosstalk among all those kinds of death. So, dear friends, it is naive to say that I can stop this here and I stop cell death, because this route will take over. I stopped this here, I found one enzyme, and I thought that I stopped cell death. This route will take over. So it is a multi-layered approach. And it's not only our genes, but it is our epigenetics, which are also very important. And as Dr. Papaioannou said, physical activity is a very great factor, but also hydrocarbons, lead, everything. So to have the happiness to get old, you must first live, you must first survive, you must first fight cell death. And you can see many things. For example, cardiometabolic dysregulation. We have the metabolic syndrome of diabetes, glycotoxicity, obesity, lipotoxicity. But heart failure itself does cause metabolic dysregulation. So it is a double-edged sword. You must try to conquer both, to combat both processes to be able to have a good result. There is an imbalance between anabolic and catabolic. The other thing we say, inflammation. It's not infection. It's not that you get COVID, but it's innate immunity, acquired immunity. There is a new term, as many of you biologists know, trained immunity. The vaccines produce trained immunity. And it has been found, for example, that the new flu vaccine causes less cardiac death. It makes a protective round. And today we don't know which comes first, inflammation or heart failure. There is a complete interplay, crosstalk between them. One begets the other. Professor Triposiadis, on Saturday, we are having a round table on amyloidosis. It's not only the classical amyloidosis. Age brings protein misfolding. Our milieu, our environment, our organism cannot well take care of its proteins, so they are degraded. 15% of old hearts, regular old hearts, have protein misfolding. And this, sooner or later, brings about amyloid formation. So, is this a precursor of classical amyloidosis? You know that today we operate on the aortic valve by TAVI. We place a valve. Because of many observations with TAVI, they found that about 30% of very much advanced aortic stenosis has elements of protein misfolding. We may call it amyloidosis, we may call it protein misfolding. there is a general rule emerging. The mild stimulus is beneficial. The harsh stimulus is catastrophic. The ancient Greeks said, miden agan, nothing too much. The yin and yang of the Orientals. Nature itself, I'm not a philosopher, I'm a poor old doctor, but I can say that nature itself promotes moderation and balance. Just to give you a look, there is a form of cardiomyopathy called arrhythmogenic cardiomyopathy. You see how many deaths predominate: apoptosis, autophagy, ferroptosis, necroptosis. Which ones to attack first? So all our therapies must be multi-thronged, multi-level, and multi-targeted. How can we combat it? Prevention. Attack the risk factors. Exercise. Give drugs. I hope you all know what preconditioning is. You give a small stimulus and it protects from an upcoming lethal stimulus. Nietzsche first said, the philosopher, what does not kill you makes you stronger. He was right in saying that as a philosopher. Immediate control, reperfusion, cardioprotective drugs, antifibrotic, and all those things which I'm going to speak about. And there is another hope, anastasis, resurrection. Since 2018, it's 7 years now, there have been studies that show if you stop the death process, the cell can resurrect itself. So there is another hope there. All these are early, do it early. But long term, we must also try continuously. That's why I'm not using the term protection or prevention. It is lifelong cardio-preservation or preservation of any living organism. 3 examples, since we're clinicians. We say that to give to a patient the new drugs, the ARNI drugs, and the Amaray, the new anti-aldosterone drugs, they must go severe heart failure. It is only 2B for those. We keep it for later. But why wait later and not use it very early? Because cell death begets cell death. So we don't have to wait till 40% of our cardiac cells die. Why not start before 10% die of them? A very clinical example. Another thing, we all adore and worship evidence-based medicine, which comes from clinical trial results. But nowadays, with so much knowledge emerging, we must also take into account pathophysiology and mechanisms. Just to say that this drug was good means nothing. We must try to find why was it good. Another, in hypertension with preserved or decreased ejection fraction, we give spironolactone, ARNI, the new drug, and SGL2 inhibitors when they have symptoms. But dear friends, when a guy with hypertension develops symptoms, half his myocardium is gone. What have you gained? And the last one, we say that for LBBB, left band branch block, Philippos, we have discussed this, we make the decision for synchronization when the ejection fraction becomes below 35. But by the time you have an ejection fraction below 35, 50% of the myocardium has been lost, and you cannot get it back. Gene therapy is the great hope. It is still unrecognized, but very recently, late October, they are doing a new effort at personalized gene editing. So this hope is still very strong. Angiogenesis is still ongoing because if you don't have perfusion, you don't have cell life. So angiogenesis is still going. Stem cell therapy. We performed the first stem cell infusion in Greece 20 years ago. It has up to now disappointed. Still, there are many trials ongoing. Why has it disappointed? It does not produce new cells. Only 1% of the cells that we give are retained. What do the new cells do? They are vehicles, they are cars that bring in trophic and anti-inflammatory agents. So, however, the amount of research in this is tremendous. And the holy grail, of course, is regeneration. There are many strategies and tools for cardiomyocyte regeneration. This is a very recent article this year, but it is not only after myocardial infarction. It is for cardiomyopathy, heart failure, and many other instances of damaged cardiac cells. And of course, you have the translational research continuum. From the moment that you have an idea, and a good college, a good medical school, a good any school must try to promote idea generations. Don't stifle the ideas. Make, as President Mao said, Mao Zedong, let all flowers bloom. So we must be President Mao, all of us. And then we must try to find the feasibility, the efficacy, if it can be done, effectiveness, if it is easy to do in a large scale, and finally, try to see how it works. But, dear friends, I believe that a goal of this wonderful Congress should not be just teaching, but we must practice. We must encourage collaborations, protocols, trials, and this Congress is a great opportunity with this excellent organization that you people have. This is where I work now at the Biomedical Research Foundation of the Academy of Athens with a mentoring course 2 years ago. Professor Patrikos, I will send you the programs for our next. And this is the hospital I left, 2005, the Onassis Cardiac Surgery Center. We were a strong clinic, but always having a course towards research. A few slides ago, I showed you the tempest, the horses of Poseidon destroying everything in their path. Myocardial death is still a main factor for cardiovascular global mortality. We need multifactorial, focused, and orchestrated approaches to achieve preservation of the myocardium. Research is long, arduous, but you cannot do anything without research. Research affects both clinical practice and education. It's a triangle of 3 factors. If you break one of the 3, your result is lame. You have a lame horse if one of his legs does not work. So we must always unite efforts, and I thank you for this invitation, which is a great inspiration to further unite our efforts. Thank you very much for having me with you.
Thank you very much, Professor Kokinos, for this excellent presentation. We have time for only one question. Anybody would like? Yes, a short one.
Professor Kokinos, thanks for this fascinating presentation. You are a great teacher. You proved it today. We are honored to have you.
The honor is all mine, Petros. Thank you.
It seems like from your presentation, the ongoing research, it comes back concepts like hibernating myocardium that we don't take for granted, that what we see as a kinetic myocardium might not be a fibrotic myocardium. Maybe that's where the research will bring up new insights in the development of new therapeutic strategy for even secondary intervention.
Absolutely. Hibernating myocardium is a very large proportion in many cases. Stunned myocardium is the same. So this is a continuum which must be broken if we want to achieve good results. And what I try to say, the earlier the better. It's not realistic to say, let's wait a little longer, see what happens. Try to intervene early. So this is the main thing. We have done this with primary PCI in acute myocardial infarction. We must start doing this in chronic conditions as well. Thank you very much again.
Okay, thank you very much. And now we're going to proceed with Dr. Kyriakos Yankou, consultant cardiologist in the private sector, and he's the president of the Cyprus Cardiology Association. And the title of his lecture is Look at the Deep Imaging in Sports Cardiology. And also Professor Triposkiadis informed me that you are also a marathon runner, so you represent cardiology in both sides, prevention and sports. Please enlighten us.
This is true, Mr. Chairman. Dear chairpersons, dear colleagues, thank you very much, first of all, Professor Patrikios, for the kind invitation. I have to be that I'm deeply honored because I participate in the same session with one of my professors, Professor Kokinos, back in the years of the University of Athens, and by the fact also that Professor Triposkiadis, another one of my teachers, is chairing the session. Professor Kokinos, you encompass all the characteristics that you mentioned earlier about the definition, the proper definition of a teacher. I thank you for all the good knowledge and the inspiration you gave us and you still give us. So, look at the deep imaging in sports cardiology. I have to declare my conflicts of interest. As the chairperson mentioned, I'm a keen runner and I'm a marathoner since November 2021. I've participated in many marathons, despite the advice of Professor Triposkiadis, who constantly says that I have to lower my kilometers. After I got married, Professor Triposkiadis, I increased the kilometers and my speed. I don't know why. My wife is somewhere here. I saw her entering. She's adorable. But I stand on the other side of the bench also, dear Chairman, because I'm beyond my special interest in sports cardiology. I've served as a medical staff in the London Marathon with my professor, Professor Sharma, and I have my sports cardiology MSc from the same university. So, without further ado, cardiac adaptation to exercise. The heart adapts to exercise in order to better perform, and this adaptation consists of the electrical component, as you know, sinus bradycardia, LV criteria for hypertrophy, repolarization abnormalities, and structural criteria, which encompass increased cavity size and increased wall thickness, all these in order to better serve the functional component and to increase the heart's performance. These changes in LV, left ventricular mass, and left ventricular wall thickness produce different geometries. We will see that in deep just afterwards. Concentric remodeling, concentric hypertrophy, eccentric hypertrophy is the ideal adaptation of the LV geometry in athletes. And the European Association of Cardiovascular Imaging almost 10 years ago, published a recommendation paper about how we should see the heart in terms of multimodality imaging approach. One question that we may use in our everyday practice, is there a space for routine cardiac imaging? Does it worth it? I mean, if we add on our screening about, if we add the echo, the heart ultrasound, would that help? It seems that we increase cost without adding any clinical information if there is no clinical indication or if there is no finding that makes us need for echo in the ECG. So clinical examination, family history, personal history, and ECG seems to be enough as a routine checkup. However, there is definitely a role of different imaging modalities. The first level, the first line imaging is, of course, compatible echocardiography. On the second level, advanced echocardiography techniques, cardiac MRI, cardiac CT, and nuclear imaging may help in specific cases. The common dilemma is if what we see is something normal or something abnormal, if there is athlete's heart or if there is a heart disease. And the more these two circles overlap, then the more the gray zone is. And our attempt is to minimize this gray zone, is to minimize our doubts if what we see is normal or abnormal. This is an echo of an asymptomatic endurance athlete, it's a triathlete. And what do you see? What do you think? Is it normal or abnormal? Someone would say that there are electrical components of athlete's heart, sinus bradycardia. Someone else would say that there is increased LV cavity, left ventricular cavity, right ventricular cavity, left atrium, right atrium increase in volumes, maybe some increase in wall thickness, some trabeculations. All these things may encompass athlete's heart or may mimic or may conceal a pathology, which is something that we don't want to miss. And this is the MRI of another athlete with the same images in terms of, with the same characteristics of athlete's heart. Regarding LV cavity dilatation, what we have to differentiate is between athlete's heart and dilated cardiomyopathy. Because in dilated cardiomyopathy, there may be an increase in LV cavity size and a decrease in ejection fraction, but sometimes, as you're going to see, this is the same in athlete's heart. This is an MRI of an athlete of a person with a dilated cardiomyopathy. You see the LV dilatation and the decrease in ejection fraction. However, it seems that there are many athletes who exhibit increased LV size and decreased ejection fraction that would somehow bother us if this is dilated cardiomyopathy or athlete's heart, approximately 15%. And 50% of the cyclists, of endurance cyclists that participate in Tour de France exhibit hearts more than 60 millimeters, and 12% of them ejection fraction of lower than 52%. So you realize how important it is to differentiate between these two entities. Regarding LV wall thickness, is it athlete's heart or is it hypertrophic cardiomyopathy? How we differentiate in this gray zone. As we know, as I have told you before, LV may be a little bit more thick in athletes, but it seems that there is no white athlete that has a heart more thick than 12.5 or 13 millimeters. Black athletes may exhibit a little bit more thick hearts. But it's not only the thickness of the heart that matters, it's also the pattern of the LV hypertrophy. If it's concentric, if it's symmetric all around the heart, it's more probable that we are talking about athlete's heart, because pathology normally exhibits as asymmetric or bizarre LV patterns, as you see on the screen. Here you see an MRI of hypertrophic cardiomyopathy, you see that there is asymmetric wall thickness. But going back to echo, these two echoes seem identical and normal. However, if we look closer, there is a pathology in one and a physiology in another. Why is that? Because in the first case, the wall thickness increase inside. Somehow they minimize the LV cavity, whereas in the latter case, the wall thickness increase, but at the same time, the LV cavity increases also. This is what I've told you before, that it's eccentric hypertrophy. So relative wall thickness, if it's below, if it's above 0.45, then most probably implies pathology, HCM. If it's below 0.45, it's most probably athlete's heart. Going to another entity, the LV trabeculations. Trabeculates are those muscle projections in the heart, and we have to differentiate between athlete's heart and LV non-compaction cardiomyopathy. Is this normal or abnormal? Well, left ventricular non-compaction, it has to do with the proportion of the compacted to the non-compacted myocardial layer, and it's something that is prone to arrhythmias and LV systolic dysfunction. There are some imaging criteria, the Chin and Jenny. However, we have to say that these criteria have been extracted from very few cases. Here you see an MRI of an left ventricular non-compaction case. You see the prominent LV trabeculation. But at the same time, there are athletes. This is a study from Professor Sharma's group in St. George's in London. There are many athletes that exhibit LV hypertrabeculation. Almost 1 in 5 athletes exhibits trabeculations, and there are many athletes that exhibit more than the controls. Why is that? Because gymnastics, sports, actually increase preload, so they increase the trabeculations in the heart. Detraining reverses this phenomenon, but at the pinpoint time that we see that, we don't know if it's athlete's heart or if it's LV non-compaction. Another similar case is pregnancy. Sometimes during pregnant women, which is increased preload in pregnant women, we see the same phenomenon. Right ventricular dilatation in athletes, is it athlete's heart or ARVC? We get the normal measurements from right ventricle, but as you can see, a very big majority, a very big percentage of athletes, male athletes and female athletes, exhibit RV dimensions which are fulfill the ARVC criteria. This is an ARVC pathological case, as you see in the MRI. What we have to take also under consideration are some indices of systolic and diastolic function. Normally, in physiological states in athlete's heart, diastolic indices are normal or supranormal, whereas in pathological cases, these are abnormal. I will not enter into details with that. And the indices of systolic function also is the same. So, dear chairpersons, dear colleagues, we have common dilemma in differentiating between physiology and pathology. Is it increased LV wall thickness in athlete's heart? Is it increased LV cavity size? Is it LV trabeculations and increased RV size as part of the athlete's heart? Or is it HCM, DCM, LV non-compaction, ARVC? These are the frames into the gray zone enters. Therefore, if something is too normal, it's too normal. If something is too abnormal, it's too abnormal. but what we are really interested in is this narrow gray zone that we have to differentiate between physiology and pathology. So to conclude, imaging in sports cardiology differentiates, of course, normal from abnormal. The first line modality is echocardiography, upon, of course, the proper indications. MRI is a second modality that provides more accurate morphological and functional details as well as tissue characteristics. Tissue characterization is something fundamental in differentiating between physiology and pathology, and only MRI can do that. And supplementary imaging techniques, which I have not entered into details, such as nuclear imaging and CT, are indicated in selected cases. Thank you very much for your attention.
Thank you very much for your enlightening presentation. And Professor Kokinos is having a question, please.
Thank you very much for an excellent, really excellent presentation. It's the clearest I've ever seen on this subject. Well, as you know very well, in borderline cases, there is the concept of the challenge. Can we use challenge that is after load increase as a challenge? Volume increase or dobutamine to see how they behave and form a clearer idea in borderline cases?
Thank you, Professor Kokinos, for your question. First of all, for your comments. They honor me very much. Thank you very much for that. Yes, actually, if we have doubts, which is something quite common, if we have doubts if a low ejection fraction is too low, or if a heart which seems sluggy and a little bit lazy is something pathological or not, we may ask the athlete to do some squats, to climb some stairs, something very, very brief and very physical in order to see if the ejection fraction goes up. Of course, we can do the afterload test with medicine, of course. This is something more complicated, but definitely enhancing the heart, pushing it to request more supply and see how it behaves, it's definitely a challenge that we can do, of course.
Thank you very much for your answer. I have also one question, if you permit me, comments, last question. So in the last decade, we have seen a lot of cases of especially young athletes and also young people with sudden cardiac death during sports. So maybe it's a hypertrophic myocardiopathy and it's not detectable with the imaging. And also we have also the topic of channelopathies, which is a big topic. And already in the last decade, I have seen in the newspaper almost 15 cases of young people with sudden cardiac death during exercise. So I think that in the future, in the near future, we need to perform during the screening of any, let's say, athletes or any kid before goes to athletes or to sports, to examine except of the ECG and except of a simple stethoscope, to put in the screening at least ultrasound plus the genetics. I would like, please, your opinion mainly for the genetic. It's just a simple blood exam that can really save lives, but the main point there is the cost. So I know that a lot of big football, let's say, players, they are performing all of these tests before they go to have their game. So can we, let's say, apply this kind of test in the population?
Yeah. Thank you very much for your comment. I don't think that we are close to this. To be honest, we have to keep in mind that sudden cardiac death in athletes, it's a rare scenario. However, it's very noisy. Sometimes, many times, it comes on screen live, which actually creates much noise. Therefore, we have the impression that it's very common. It's not that common. It's still a rare scenario. However, the more extent the pre-participation checkup is, it may reveal dangerous entities that may lie underneath. However, it may increase incrementally the cost without equal benefit in who we screen, in how many cases actually we detect, and at the end, who we save. Of course, someone would say the value of one life, it may be priceless, but this is not the case in macroeconomics or when a team pays or when a federation pays. This may not be the case. Regarding your comment on genetic test, I don't agree that it should be a screening test. Genetic test is not a screening test for everyone. You detect genes that you don't know the significance. You detect genes that are not, we know that if we detect genes, it's not sure that it will turn into a disease. So I would say that if this applies, we will get information that we will not be able to use.
Okay. My last question, a challenging one. Now, I have some reservation regarding the term athlete's heart. The reason is if we find the heart of a marathon runner in a weightlifter, this is totally abnormal, right? So the adjustment depends on the discipline. And I believe that we have, and I need your thought, we have to start from the type of discipline of the athlete. Otherwise, something which is normal, let's say in a boxer or in a weightlifter or something we cannot find, may be totally abnormal in a marathon runner. So, and we have to be careful when we use this term for everybody.
This is true, Professor Triposkiadis. We don't have to stick only on sporting discipline. We have to stick on gender, on race. There are now mixed race athletes. They are not, I mean, white athletes, black athletes. They are mixed race. Sporting discipline, years of exercise and all these things. However, this impression that used to exist in the past that aerobic exercise produced dilated hearts, whereas isometric exercise produce thicker hearts, is not black and white, it's not this and that, because weightlifting, for example, if it's performed in high intensity intervals, which is a part of the, let's say, trendy kind of exercise nowadays, it also increases heart rate, which is, it has also a significant aerobic component. So it's not just this and that. Yeah, okay. But I agree with your comment.
Congratulations, Kyria, very good presentation. Further to Professor Triposkiadis' comment, would you consider athletic heart as a normal cardiac alteration as a result, irrespective of the kind of exercise, or it could turn into a gray zone and then into pathologic zone? So at the end of the day, it's a concept that I always worry. Is exercise enough to get beneficial benefit, or it could be a precursor of something that it will come up in a clinical phenotype at some stage, and it's somewhere in the gray zone before it evolves into a pathologic zone?
Excellent comment, Dr. Agathangelu. I have two comments on that. First of all, the benefit and the amount of exercise is not linear. This is the idea of Professor Triposkiadis' comment on how long, on how much I do exercise, because we know that if someone doesn't exercise, there has a risk. If this person starts exercising, the risk goes down, but for a certain point onwards, the danger goes up. It's a U-shaped curve. Which means what? Which means that over-exercise may trigger, as a fact, events of sudden cardiac death. Definitely, and this is my second comment, is that there may be a predisposition of a person of a disease, but if this person doesn't exercise above a level that would actually trigger this predisposition to express itself, then this predisposition may never appear. But if this person overexercises or exercises above a level, it may be a trigger for this predisposition to express itself. That's also, and this is something that we do excellent in Cyprus, we don't check up athletes only once. We check them up regularly, every 3 years, if symptoms occur earlier, but we check them up every 3 years, which means that we will create opportunities of detecting earlier pathologies that may appear.
Thank you very much for your comments and for the answers to the questions. And if there is no more questions or comments, then we can go on with the next session.
Thank you very much.
Thank you very much.
Okay, thank you.
So, good afternoon. We are very happy to welcome you to the fifth session of the day with the title Innovations and Challenges in Pulmonology. I co-chair this session with Dr. Dimitris Grassos, a very esteemed colleague from Greece. This session, the main topics which are going to be covered are sleep apnea, COPD, asthma, interstitial lung diseases, and the environmental influences on lung health. So it's with great pleasure to introduce the first speaker. Is Clinical Assistant Professor Dr. Andreas Zachariadis. He's a pulmonologist and a specialist in sleep disorders. Andrea, the floor is yours. Thank you.
Thank you very much for the introduction. Thank you, Professor Patrikios, for the kind invitation. To be honest, it's quite complex, my topic. That's why I selected this picture to start with, because in 12 minutes we have to say a lot of things to make it clear. Nothing to declare. And the structure of my lecture consists of the definition of central sleep apnea, the phenotypes, the pathophysiology, and the treatment options. Allow me to show you this screenshot because it is what we see. I want you to see what we see in the sleep study, in the sleep laboratory. You see quite a lot of signals. Just pay attention on the arrow, the red arrow here, which is the airflow. That means that the patient, the individual, stops breathing. So, further down, you see that there is some movement here in the chest and abdominal wall. That means that this person tries to breathe, but stops breathing. This is an obstructive apnea if it is more than 10 seconds. So here we have a respiratory effort. On the contrary, I'm going to show you now the central event, just to understand the difference. Here you see again that there is a cessation of breathing, but what is the difference? There is no respiratory effort. So this is a central event. And of course, we have a third type, which is the mixed apneas that usually begins as a central and at the end ends with an obstructive component. So if we want to make all these things, and we have 100 patients with sleep apnea syndrome, and you put all of them in the same basket, the majority of the cases, 90%, will have the majority of obstructive events, obstructive apneas, 5% you are going to have mixed events, and these two categories are treated similarly. So 95% are in one category, and we have 5% of the central events, which is the topic of my lecture. So to define further central sleep apnea, just imagine as a group of sleep-related breathing disorders. It often emerges from other medical conditions. The most important is the chronic heart failure, stroke, the use of medications and substances such as opioids. It is characterized, as I told you before, by reductions, that is hypopneas, or complete cessation of breathing, and of course, no respiratory effort, that is central. And in adults, in order to characterize an individual that he has central sleep apnea syndrome, we need to have 5 events, 5 or more events of apneas, hypopneas per hour of sleep, and the majority of these events to be central. So, what is the definition now? The International Classification of Sleep Disorders categorizes 6 types. The primary CSA, CSA with chain Stokes. Chain Stokes is a specific breathing pattern that we breathe, and we have crescendo and decrescendo in the breathing. We have CSA due to medical disorder without chain Stokes. We have CSA, central sleep apnea, due to high altitude. This usually happens in altitudes more than 2,500 meters. We have the treatment emergent CSA, that is the sleep apnea that appears after we initiate treatment for obstructive sleep apnea. And we have CSA due to medication or substance. And if we are talking about substances and medications, allow me to show you this table. You have various medications that predispose an individual to CSA. The most important representative are opioids that even more frequent. Every day we encounter patients that take opioids due to chronic pain and so on. So bear in mind that these substances and drugs may be the solution of the question and the answer why your patient has central sleep apnea. And as in medicine, in every disease, the last years we start to phenotype, the same applies also to central sleep apnea. So we have phenotypes. And to make things simple, I would say that we have 2 main phenotypes. The one phenotype is people, which is the majority of cases, that have overshooting ventilatory drive and breathing instability. That means they have increased ventilation. So here we do not have increased carbon dioxide. It is non-hypercapnic or hypocapnic. And here we put people with idiopathic CSA, CSA in chronic heart failure, like our colleagues before explained, in high altitude, the treatment emerging CSA, and these are the majority. But we also have CSA, central sleep apnea, that is characterized by reduced ventilatory output and mini ventilation, and here we have hypercapnia. One representative is then drug-induced CSA. Furthermore, this category could be subcategorized into people that will not breathe, and I'm going to explain you what, and people that cannot breathe. So the first category is people that have impaired central drive, like people with tumors or trauma, lesions in the brainstem, opioid-induced CSA, congenital central hypoventilation syndrome. On the other hand, people that they want to breathe, but they cannot breathe. Here we have some neurological disorders like myasthenia gravis, ALS, post-polio, myopathies, and so on. Regarding the pathophysiology, is quite complex. We have some principles. The first principle is the loop gain. We have the controlled gain, which is the brain. We have the plant gain, which is the lungs, and the circulation, which is the mixed gain. What is this principle about? It says that it's the interplay between the compartments of the ventilatory system. So in simple words, if we have a patient that has high loop gain, that means that minor disturbances in breathing prompt exaggerated responses, potentially leading to instability and oscillations in respiratory patterns. On the other hand, people with low loop gain These people have a response that is more gentle to disturbances, so they have stable breathing. Huge swings of the system between hyperventilation and apneas, that is an overshoot and undershoot of ventilation. This is a characteristic of people with high loop gain. Another principle in pathophysiology is the apnea threshold and CO2 reserve. Again, in simple words, apnea threshold is the level of CO2 below which we stop breathing, and it's different from each of us. CO2 reserve is the difference between our actual level of PaCO2 and apnea threshold. And in this image here, if we have a reduction of the reserve, for example, the normal value is 5, and it goes to 1 or 2 millimeters of mercury, that means that we have increased breathing instability. It's more easier to have conditions like central sleep apnea and periodic breathing. And not to forget the regulation of respiration, which is quite complex. Again, a process. We have inputs from central and peripheral chemoreceptors, intrapulmonary vagal afferents, muscle sensors and proprioceptors, as well as cortical inputs. An example is hypoxemia, hypercapnia, fluid accumulation in heart failure, muscle stretching, and psychological stress are all examples of respiratory stimuli. And these inputs, they are integrated in the retrotrapezoid nucleus and the pre-Bozinger complex, which determine the rhythmicity of breathing. So we have all these principles and interactions that lead to the pathogenesis of CSA. What are the options of treatment now? The first therapeutical option, as you see in the picture, is to apply a small mask to the patient that is attached to a device that is called CPAP. CPAP is continuous positive airways pressure. The principle here is to administer a constant pressure throughout the cycle of the respiration. Many studies have shown that it reduces the number of apneas, hypopneas, it improves oxygenation, it improves left ventricular ejection fraction, and it has many benefits to our patients. We have another mode of ventilation that is quite more, let's say, complicated. It's called BPAP. BPAP means bilevel. Bilevel because it gives different pressure during inhalation, different pressure during exhalation. So it should be dedicated only to people that have hypercapnia. And that is very important, and we should always put a backup rate. So a backup rate is important because otherwise it cannot control the central apneas. Bear in mind that fixed pressure support may worsen non-hypercapnic CSA because it will cause hyperventilation and it will drop the level of CO2. So there is no evidence of applying non-invasive ventilation, BiPAP, in people that are not hypercapnic. Another mode of ventilation, if you look at all these devices, they look alike one each other, but they have a different algorithm, a different computer. This is a more expensive device. It is called ASV, Adaptive Servo Ventilation, that works in a different way. It gives a variable or fixed expiratory pressure and a variable inspiratory pressure support. The IPAP, which is the inspiratory pressure, is increased during periods of hypoventilation of the user and is decreasing during hyperventilation. So it auto-adapts according to our breathing pattern. Of course, here we use also backup rate, and ASV has been proven to be the most effective option to treat periodic breathing. New, let's say, treatments are emerging, and the last 1-2 years, we have the phrenic nerve stimulation devices that work by detecting the cessation of breathing during sleep, and then deliver a small time electrical impulse to the phrenic nerve. What does it do? They stimulate. This stimulation causes the diaphragm to contract, mimicking natural respiration. And what is the result? Is to have a restoration of a more, let's say, normal and natural breathing pattern and reduction in apneic events. Many studies have examined oxygen supply. nocturnal oxygen has been tested but has little impact on apnea-hypopnea index and outcomes, especially in our majority of patients that have chronic heart failure. Of course, as we said before, removal of any possible drugs that are associated with CSA should be in our mind, because it can solve the problem if you can do this very easily. And on the other hand, there are studies that evaluate the prescription of different medications. The most important of them are benzodiazepines and non-benzodiazepines, that are hypnotic agents, that they increase the arousal threshold, so the patient is more difficult to wake up. He has a more stable breathing. And despite inconsistent results, they may reduce periodic breathing and CSA in different settings. Lastly, acetazolamide, which we know we give to people that are going to high altitude. It's a carbonic anhydrase inhibitor, decreases the loop gain. So the problem here is that it has a lot of significant heterogeneity between the studies, whether it will help or not. So to conclude, a more precise differentiation and description of the entities of central sleep apnea, embracing the heterogeneity of underlying etiology, pathophysiological concepts, treatment response and outcome is emerging. The identification of the phenotype is key for selecting individualized therapeutic approaches, which should be based on the dominant underlying pathophysiological characteristics. The most prevalent CSA-associated medical condition is chronic heart failure, leading to non-hypercapnic CSA. In this case, we should think of ASV, but it's not our first line of treatment. And future research should focus on describing the prognostic aspects associated with CSA and its associated clinical entities, as well as refining treatment indication, including pharmacotherapy and invasive options. Thank you very much.
Thank you very much, Andrea. Thank you for the thorough presentation. I think for the sake of time, we're not going to proceed with any questions. If we have time at the end, then maybe we can have time for a few questions. I would like to invite Dr. Donia Adamidi. It's with great pleasure. She's the director of the respiratory department of Nicosia General Hospital. She has various interests in many aspects of respiratory medicine, including the topic she's going to present right now, interstitial lung diseases.
Thank you very much, Alexis. I would like to thank to the European University for the invitation, and especially Professor Patrikios. And my presentation is about emerging therapies for interstitial lung diseases. Interstitial lung diseases is a diffuse parenchymal lung diseases, are a heterogeneous group of disorders, but are classified together because of similar clinical, radiologic, physiologic, or pathologic manifestations. The descriptive term interstitial reflects the pathologic appearance that the abnormality begins in the interstitium. However, most of these disorders are also associated with extensive alteration of alveolar and airway architecture. In this busy slide, we can see here that diffuse parenchymal lung diseases consist of disorders of known causes, like rheumatic diseases, environmental or drug-related, as well as disorders of unknown cause. The latter include idiopathic interstitial pneumonia, granulomatous lung disorders like sarcoidosis, and other forms of interstitial lung disease, including lymphangioliomyomatosis and eosinophilic pneumonia. The interstitial pneumonias are further categorized as chronic fibrosing, acute or subacute fibrosing, or smoking-related. Idiopathic pulmonary fibrosis is a chronic progressive fibrosing interstitial pneumonia of unknown cause, occurring in adults and limited to the lungs. It is associated with the histopathologic and or radiologic pattern of usual interstitial pneumonia, UIP. In the past, treatment aimed to minimize inflammation and slow the progression from inflammation to fibrosis. However, the underlying lesion in IPF may be more fibrotic than inflammatory, explaining why few patients respond to anti-inflammatory therapies and the prognosis remains poor. Management generally includes a combination of supportive care, use of selected medications like pirfenidone and nintedanib, consideration for participation in clinical trials, referral for lung transplant evaluation when appropriate, and identification and treatment of comorbidities. Furthermore, supplemental oxygen when needed, education including advice about smoking cessation, pulmonary rehabilitation, and vaccination against respiratory infection. No medication has been found to cure IPF. Two antifibrotic medications, nintedanib and pirfenidone, appear to slow disease progression and reduce the frequency of acute exacerbations. In addition, these agents appear to have a mortality benefit and decrease risk of all-cause mortality. Nintedanib also demonstrated a decreased risk of acute exacerbations. Nintedanib is a receptor blocker for multiple tyrosine kinases that mediate elaboration of fibrogenic growth factors like platelet-derived growth factor, vascular endothelial growth factor, and fibroblast growth factor. Pirfenidone is an antifibrotic agent that inhibits transforming growth factor beta, TGF-B, stimulated collagen synthesis, decreases the extracellular matrix, and blocks fibroblast proliferation in vitro. Nintedanib and pirfenidone slow but do not halt IPF progression. The potential benefit of combined therapy with these two agents is unclear. The safety and tolerability of this combination therapy has been evaluated, and fewer than 25% of patients on this combination need to stop therapy due to adverse events. What about the new medication? Nerandomilast is a phosphodiesterase 4B selective inhibitor that has been shown to modestly reduce FVC decline in patients with IPF and progressive pulmonary fibrosis in phase 3 trials. Has antifibrotic and immunomodulatory effects. Lysophosphatidic acid receptor 1 antagonists at milparant involved in wound healing and tissue fibrosis that is found in increased concentrations in bronchoalveolar fluid and breath condensates in patients with IPF. LPA signaling, mediated in the lung primarily by the LPA1 receptor, increases recruitment of fibroblasts and promotes fibroblast apoptosis resistance. Pendraxin 2 inhibits monocyte differentiation into profibrotic fibrocytes or pro-inflammatory macrophage, as well as reduces the production of transforming growth factor TGF-beta1, a potent regulator of connective tissue synthesis. And lastly, pamrevlumab is a fully humanized monoclonal antibody specifically designed to target connective tissue growth factor, a central mediator in the pathogenesis of fibrosis. What about the non-IPF ILDs? ILD characterized by glucocorticosteroid responsiveness are cryptogenic organizing pneumonia, acute and chronic eosinophilic pneumonia, hypersensitivity, pneumonitis, and drug-induced ILD. Patients with no IPF ILDs can also develop a progressive fibrosis phenotype with a prognosis approaching that of patients with IPF. So, presence of ILD other than IPF with radiologic evidence of lung fibrosis. These patients can show progression within, for example, the past year with worsening restrictive physiology, with absolute decline in forced vital capacity FVC, more than 5% predicted, or absolute decline in diffusing capacity of carbon monoxide DLCO, more than 10% predicted. Second, they might have worsening respiratory symptoms or progression of radiologic fibrosis, like increased extent or severity of reticular changes, lumbar volume loss or traction bronchiectasis, bronchioliectasis, new ground glass opacities with traction bronchiectasis, or new or worsening honeycombing. Nintedanib is the only effective therapy for progressive pulmonary fibrotic lung disease other than idiopathic pulmonary fibrosis. The new medication, nerandomilast, We see in a recent study in a double-blind trial over of 1,000 patients with progressive pulmonary fibrosis, and 45% of whom were receiving background nintedanib were randomized to nerandomilast, either 9 milligrams to 18 milligrams twice daily or placebo, and followed for at least 52 weeks. Compared with placebo, nerandomilast led to a modest reduction in FVC decline over 52 weeks, regardless of dose or background therapy. 60 to 90 ml absolute decrease in FVC decline, 39 to 52% relative reduction. Patients treated with either dose of nerandomilast had significantly fewer acute exacerbations, 9.2 versus 13.3%, and deaths 7 versus 12% when compared with patients treated with placebo. The ARIA was the most common adverse event, occurring in 15 to 25% of patients without background nintedanib, and nearly 50% of patients on concomitant nintedanib therapy. This agent is a promising potential addition to therapeutic options for patients with progressive pulmonary fibrosis. What about the patients with rheumatoid diseases and lung involvement? Interstitial lung disease is a frequent complication in systemic sclerosis and rheumatoid arthritis, with the form of non-specific interstitial pneumonia, NSIP, fibrotic NSIP, pattern of UIP. Initiating immunomodulatory therapy in patients with symptoms like mycophenolate mofetil, cyclophosphamide, tocilizumab, rituximab, azathioprine, and not typically use nintedanib as a first-line agent without first assessing response to an immunosuppressive therapy. What about the patients with pulmonary sarcoidosis? Sarcoidosis is a multi-system disease of unknown etiology and is characterized by tissue infiltration with non-cascading granulomas. The granulomas may occur in any organ. Most patients with pulmonary sarcoidosis do not require treatment because they are asymptomatic, they have no progressive disease or experience spontaneous remission. The severity of pulmonary disease we can see from radiographic feature pulmonary function test that this determines the therapy, and the first choice is corticosteroids and other medications like methotrexate, azathioprine, and leflunomide. So, in conclusion, we can use nintedanib for the treatment of IPF. We can use nintedanib for patients with non-IPF ILD who develop progressive pulmonary fibrosis despite optimal initial ILD management, for example, antigen avoidance or immunosuppressive treatment, or depending everything on ILD subtype. In patients with worsening respiratory symptoms like dyspnea and cough, significant decline in pulmonary function, more than 5% absolute decline in forced vital capacity, or more than 10% absolute decline in diffusing capacity, radiologic evidence of disease progression, and of course, nintedanib reduces the rate of lung function decline. Pirfenidone only off-label to patients with progressive pulmonary fibrosis who are unable to take nintedanib, and the new medication, nerandomilast, is an oral phosphodiesterase 4B inhibitor with antifibrotic and immunomodulatory properties. Thank you very much.
Thank you very much. We can proceed to the next speaker. Thank you very much.
Thank you.
Good morning to all of you. First of all, I would like to thank the soul of this conference, Professor Patrikios, for the invitation, and I would like to introduce with great pleasure the next speaker, Professor Jouvelekis, who is one of the top opinion leaders on respiratory diseases and interstitial fibrosis. Currently is a professor of University of Yale and of University of Patras Medical School. Professor?
So, thank you very much for the kind invitation. Thanks a lot for your kind words, my friend. And special thanks to the organizing committee and my friend Ioannis Patrikios for the kind invitation and for the joy to be here among you in the beautiful island of Cyprus. So without any further ado, I'm going to proceed to the topic of my presentation, which is I'm going to shift a little bit the gears and try to present from a different angle pulmonary fibrosis. There are some evolving concepts at the moment in the pathogenesis of lung scarring. This is my conflict of interest. So pulmonary fibrosis is localized in the lungs. This is the dogma that I used to believe before, but unfortunately, or fortunately, the new concept says it's not localized in the lungs. And as you can see here, you can appreciate from this slide that the fibroproliferative disorders across organ systems, there are more than 240 of these entities across 7 organ systems, starting from the lungs, 49 disorders, the liver, 78 disorders, 36 disorders that consist the so-called intestinal fibrosis. Then we have cardiac fibrosis, atrial fibrillation, heart failure with preserved lung function. Also, it is a type of cardiac fibrosis, kidney fibrosis, skin fibrosis, and all these disorders, if you accumulate the mortality rates, then they are responsible for more than 45% of deaths in the United States. So this is how we should take a look at when we deal with patients with pulmonary fibrosis. We need to have a holistic view, because most of them, they present with several comorbidities that I'm not quite sure they should be called comorbidities. So the answer to the question, is lung fibrosis restricted to the lungs? So the answer is no, because as you can see here, there are patients with pulmonary fibrosis that they present with these entities. We call them comorbidities, but they're not, according to the new concepts. And as you can see, the prevalence of multi-organ fibrosis increases with age. And these are comorbidities like they pre-exist before the development of lung fibrosis, or at least before the diagnosis of lung fibrosis. Like patients with lung fibrosis, they present with pneumonia events before the diagnosis of lung fibrosis. Most of them, they have GRD. Most of them, they have diastolic dysfunction, heart failure with preserved ejection fraction. A significant percentage of them, they have hypothyroidism that can be a type of remodeling of the thyroid gland called fibrosis. Chronic kidney disease, diabetes is a type of fibrosis that can lead to kidney failure due to fibrosis. And as you can, if you want to find some common general principles between all these entities, you could see that most of them, they follow common general principles. Which are these principles? So the first lesson is that in order to understand a tissue, we need to think the structure and the function constraints, the cellular hierarchy and the organization. So every tissue has a primary cell. Every tissue also has support cells that help the primary cell carry the function. The roles are not constant. A support cell in one organ can be a primary cell in another tissue. The terms are relational. Each biological component supports the core function of a higher organ. And what is really important is to understand the role of homeostasis. And there are also organs, the organs, they present with interconnections. And this is really important to understand this. For example, in the context of lung fibrosis, the primary cell is the AT1 cell, and the stem cell is the AT2 cells. These are cells that they carry the surfactant factor, and these are the most hardworking cells. They possess more than 50% of the total mitochondria of the lung. And just to remind you, the lung has about 45 different cell types. But these particular cell types, the AT2 cells, they possess more than 50% of the total mitochondria of the lung. That means they have a very specific function, which is the gas exchange. And as you can see, as you can appreciate here, not only the gas exchange, but also the type 2 cells, they regulate the fluid absorption, they serve as local progenitors, and also they play, once they succumb to death, then they need to be replenished. And then we have, if the tissue damage is not doesn't follow the normal reparative process, then you have lung fibrosis. And remember that a system will most likely fail at its most stressed component. And this is like a very simplistic way to present what I told you before. If you have, for example, a regulated variable, you have the sensor cell that senses the damage of the cell. You have repetitive injurious stimuli to the cell, let's say the type 1 epithelial cells, they succumb to death because of repetitive injurious stimuli, infection, smoking, GRD, or other injurious stimuli. Then you have sensor cells that send the homeostatic signal to the effector cells. The effector cells are the stem cells, the type 2 epithelial cells in the context of lung fibrosis. And if these repetitive injurious stimuli, actually if these injurious stimuli are repetitive, then you have disruption of the homeostatic signal. And you have an aberrant wound healing response. You have epithelial cells that they are not type 2 epithelial cells because you have stem cell exhaustion because of the repetitive injurious stimuli. And you have other cells like bronchial epithelial, stem cell epithelial cells that they move towards the lower zones of the lung in order to cover the denudated basement membrane. And then you have abnormal what? Reepithelialization. That's why you see in the context of lung fibrosis, you see bronchialization of the distal airways. You have bronchioli in areas that they're supposed to have alveoli. But bronchioli, they don't carry with them vascular components. They don't contribute to gas exchange. That's why you have areas that they don't function. Function well. That's why you have an aberrant wound healing response. And in this aberrant wound healing response, you have other components like the immune compartment. You have infiltration of myeloid cells, of macrophages that they change their phenotype from M1 to M2. You have endothelial cells that they change their phenotype, expressing collagen 15. And then in the end, you have, because of this crosstalk of the dead epithelial cells with fibroblasts that they lie underneath, you have activation of myofibroblasts and production of extracellular matrix, and then in the end, a respiratory failure. And I'm going to pass this slide because I presented that before. I'm just trying to tell you that all these processes, it doesn't happen to everyone, but you need to have a genetic predisposition. And in the context of lung fibrosis, the genetic predisposition are usually telomere attrition. Usually it is some functional mutations or polymorphism of MAC5B that make epithelial cells prone to epithelial apoptosis upon injurious stimuli. And I'm going to move forward to the lesson number 3. So as you can appreciate, all these mechanisms that I presented for lung fibrosis, they apply to other organs. They apply to liver, they apply to renal fibrosis, they apply to skin fibrosis, they apply to they even apply to other types of organ fibrosis, like in the eye or central nervous system. And then you have these major pathways, the fibroblast activation, the cytokine storm, the epithelial-mesenchymal transition, and you have the same cells in each organ that they contribute to the myofibroblast pool. You have fibrocytes, endothelial cells, adipocytes, mesothelial cells, and epithelial cells. And what is really important to understand that the type of insult in each organ sets the fibrotic pattern. We have different types of renal fibrosis based on the type of insult. We have different types of lung fibrosis, as it was presented before, based on the type of insult. We have different types of liver fibrosis. If the problem is cholestasis, then we have periportal fibrosis. If the problem is the fat accumulation, you have perisinusoidal fibrosis. And then we also have different types of cardiac fibrosis. If you have myocardial infarction, you have a type of cardiac fibrosis with reduction of the cardiomyocytes. But if you have arterial hypertension-induced cardiac fibrosis, then you have a type of fibrosis with preservation of cardiomyocytes. And all of them, they have a common etiology. It's a different type, it's the different way that we age. It's the accelerated aging and the senescence. And senescence is a very, very complex process that has these 9 pillars, as you can see here, all these epigenetic and genetic alterations that happens, and they lead to accelerated aging. And then the cell cannot have any capacity to grow and divide. And of course, all these patients, they are more prone to develop cancer based on the type of organ, lung cancer, hepatocellular cancer. And what it was found, and it was really important, it seems that these remodeling and these aberrant wound healing responses, irrespective of the type of fibrosis, they start from the brain. And as you can see here in this really elegant study, the gray matter brain age gap, that means the predicted brain age and the difference between the predicted brain age and the chronological age, if you have this big difference, that means you have increased likelihood of developing all these comorbidities that they belong to the umbrella of fibroproliferative disorders. And this is something really fascinating. But there are also some divergent mechanisms. Some can argue why the liver fibrosis can be reversible, whereas the lung fibrosis cannot be reversible. And that has to do with the inherent limitations and weaknesses of some organs versus the others. So for example, the liver has increased reparative capacity. And as you can see here, if we try to make it in a numerical way, the lung during our age undergoes a complete renewal every 100 to 300 days. That means by the age of 75, we're going to have about 100 lungs reparation. However, the liver undergoes a complete renewal every 30 days. So that means we're going to have 1,000 livers by the age of 75. So what we can learn? We can learn that, and we learn from other organs, that there are type of cells like adipocytes that they play a major role in lung fibrosis, and we have underestimated them. And as you can see here, the adipocytes are not only cells that they are thermogenic, they are also cells that they have mesenchymal origin, and they play a major role in fibrogenesis and remodeling. And as you can see here in this paradigm from Florian Reeder in Cleveland, Ohio, that if you culture undernatants from human intestinal smooth muscle cells, and then you put into these undernatants, you put cells from ulcerative colitis or Crohn's disease, you can see here that their proliferation goes really high. And this is important. And the same thing happens with the heart. The excessive fat liver, and with the liver, the excessive fat liver deposition, it leads to fibrosis. We have the non-alcoholic steatohepatosis, and also obesity has been associated with ventricular fibrosis and atrial fibrosis. And the same thing also happens with the lungs. We have underestimated the presence of adipocytes. And there are adipocytes in the lung parenchyma of patients with IPF. As you can appreciate here, at the areas of, close to the areas of honeycombing, close to the areas of fibrosis, there are several adipocytes. And these cells, they don't lie there without doing anything. And they're not, as I mentioned before, they're not thermogenic type of adipose tissue. There is adipose tissue that they express specific factors that they play a major role in lung fibrogenesis, and they contribute to lung fibrogenesis. And if you take conditional medium from this adipocyte and you culture this conditional medium with fibroblasts, then the fibroblasts have an increased proliferation and migration. And the last lesson that we learned is that lymphatics are also largely underestimated in lung fibrosis. And there is a lot of data showing that patients with fibrotic ILDs, not only IPF, they have enlarged mediastinal lymph nodes. What is happening there? Is there a type of mediastinitis? This type is the type of mediastinopathy. Why the lymph nodes are enlarged? And we thought that it was a reactive process, but they're not. And our study group has shown that it doesn't show that they don't play only a role as a prognostic factor, but also this phenomenon has been observed by our group in the experimental model of lung fibrosis. As you can see here, if you give bleo to these mice and you provoke lung fibrosis, you see that their lymph nodes, they go 5 times higher than the control group, and they express high level of PD-1. And this is something that shows that these lymph nodes in the experimental model of lung fibrosis, they have a type of immune paralysis. And if you reduce the signaling pathway by using PD-1 inhibitors like pembrolizumab, which is an anti-cancer agent, you can appreciate from these slides that the cells that they have, the mice that they undergo treatment with low dose of pembrolizumab, they have reduction of lung fibrosis. And the same happens with nintedanib, for example, that started as an anti-cancer agent, and then it was developed as a FDA-approved treatment for lung fibrosis. So are there any organ interconnections? Yes, they are. There are very elegant studies showing that the liver and the lung, they communicate and through the portal vein, and you have movement of cytokines like bradykinin that goes to its receptor from, it's been secreted by the liver and it goes to its receptor in the lung, and it promotes inflammation through upregulation of IL-6 and then remodeling and lung fibrosis. There are many therapeutic implications. I don't have the time to develop them, but as you can see here, many antifibrotic agents, pirfenidone and nintedanib, have been used for the treatment of liver and renal fibrosis without major effects. And there are several clinical trials at the moment that are being tested in all organs and also in lung fibrosis. But I want you to point the interest towards the modulators, the metabolic modulators like the thyroid mimetics. This is a really interesting concept that proves everything that I told you so far. And this is a study showing that the thyroid mimetic called resmetirom reduces liver fibrosis that is attributed to NASH. And that was the first FDA-approved treatment for the treatment of NASH, the non-alcoholic steatohepatosis that leads to liver fibrosis. And this is something really striking, because we have found similar results in this paper published in Nature Medicine a few years ago, that the cells from patients with IPF, with lung fibrosis, the epithelial cells, don't have enough thyroid hormone in order to respond to the increase in urostimuli. If you give them thyroid hormone or thyroid mimetics, then you increase the mitochondrial metabolism, you increase the autophagy, and then you make them more resistant to apoptosis, leading to the stop of the vicious cycle of lung fibrosis. This is something really interesting, because also other metabolic regulators like metformin that reduces liver fibrosis in patients with type 2 diabetes. It has also shown effects in experimental model of lung fibrosis, and you should take into account. And if we change this 5-pillar prevention strategy of the European Heart, of the American and the European Heart Association, 5 ways to prevent heart disease and stroke, 5 ways to prevent organ fibrosis. First is nutrition, exercise, tobacco cessation, reduce the exposures, and also metabolism modulators. Thank you very much for your attention.
Thank you, Professor, for this up-to-date lecture, as usual. We have time from one question. Is there anybody? No. Okay. Is there a question? No. Okay, we can proceed.
Okay, thank you very much.
Thank you, Argyri. So let's carry on with the next speaker. The next speaker is Dr. Anna Ioannou. Anna is a respiratory physician at Nicosia General Hospital, the respiratory department, and she will give the next talk on severe asthma, mucus plugs, from pathophysiology to diagnosis and implications on clinical aspect. Anna, thank you.
Thank you very much. So today we are going to speak about severe asthma. First of all, asthma is a heterogeneous disease characterized by chronic airway inflammation. It is defined by the history of respiratory symptoms such as wheeze, shortness of breath, chest tightness, and cough. These may vary over time and in intensity, together with variable expiratory airflow limitation, is going to give us the initial diagnosis in asthma. Okay, so as you can see, this is the table of the initial diagnosis of asthma from GINA 2025. And once we diagnose the patient, then we give the treatment. And then what happens if the patient comes back and says that the treatment is not working or the symptoms are getting worse? We have to think about severe asthma. Severe asthma is a subset of difficult-to-treat asthma. But first, we have to see what's the difficult-to-treat asthma, which is based on the uncontrolled asthma, includes the poor symptom control or frequent exacerbations that they can require oral corticosteroids or serious exacerbations that they can lead to hospitalization. Uncontrolled asthma, despite adherence with maximal optimized high-dose ICS LABA treatment and management of contributory factors, or that worsens when high-dose treatment is decreased, is what's called severe asthma. It's approximately 3 to 10% of people with asthma. Let's say think that 25% of the whole population has asthma. The 3 to 10% of these people, they have severe asthma. Okay, what happens with the pathophysiology? So here we can see the airway of a normal person and the airway of an asthmatic person. We can see that the airway, it gets narrower, the wall has tightened smooth muscles, and the air is trapped in the alveoli. This is a histology slide where we can see the characteristic features of someone with severe asthma. We can see the altered epithelial barrier, the increased smooth muscle, the mucus plaques, the thickened reticular basement membrane, the goblet cell hyperplasia, and subepithelial fibrosis. Okay, so I try to put the pathophysiology of asthma in one slide. Okay, this is not something that we can put on a slide, but here we can see the type 2 and non-type 2 or type 2 low inflammatory processes that are involved in asthma. The type 2 inflammation, we can see that we have the eosinophilic asthma and non-allergic eosinophilic inflammation, and the type 2 low inflammatory pathways that they involve mainly the interleukins 17, interleukins 18, and the neutrophils. So what happens with mucus production? Mucus content is mainly from water, and then we have proteins, ions, cellular debris, and lipids. In respiratory epithelium, goblet cells and some mucosal glands are responsible for the production of two main primary mucins that are MAC5B and MAC5A. And these are opposing mucins. MAC5B forms a loosely cross-linked hydrated mucus network that facilitates normal mucociliary function, and MAC5AC generates highly adhesive compact mucus plaques that prevents the airway clearance. It is frequently overexpressed in case of inflammatory and allergic stimuli. Okay, so here we can see that we have the goblet cells in the normal epithelium, where you can see that the mucins, they are involved in the mucus layer, and they get brushed with the help of the cilia, and they get out of the airways. And in the case of mucus dysfunction in asthma, the mucus plaque is formed, and the cilia are not working properly, and the mucus is stuck within the lumen of the airway. So the type 2 cytokines, interleucin 13 and interleucin 4, are the ones that they can cause suppression of the MAC5B and stimulating of the MAC5AC. And we can see that the mucin transcription and secretion through the interleucin 13 from exogenous and endogenous stimuli, they can cause mucus overexpression and regulation. Okay, there are different pathways that they lead to overexpression of mucus, and there are complex. There are also the eosinophil peroxidase, galectin 10, and Charcot laden crystals that they are products of eosinophils, that they cause the mucus plaque formation and cross-linkings. and also the eosinophilic extracellular traps released from eosinophilic granules, that they also contribute to the increased viscosity of mucus plugs. Persistent mucus plugs create a hypoxic environment that exacerbate airway wall damage through multiple mechanisms. Hypoxia-induced factors 1A and 2A, they cause the sodium absorption and MAC5B expression, causing mucus hyperconcentration. Hypoxia also leads to glycolysis and this disrupting ion transport homeostasis, causing goblet cell hyperplasia and therefore mucus MAC5AC hyperproduction. Upon secretion, mucus absorb water, a process tightly regulated by ion channels such as CF transmembrane conductance regulator and endothelial sodium channel, which when this mechanism is disrupted, we have a dehydrated, sticky mucus prone to stasis. Okay, so in general, the mucus formation is a complex pathway, and these are all the factors that contribute to excessive mucus formation and impaction. They are divided into increased mucus production, abnormal mucus dehydration, and impaired mucus clearance. So mucus plugging we can see them on the CT imaging. CT imaging is currently considered the gold standard for evaluating mucus plugs due to its high spatial resolution and ability to visualize both proximal and distal airways. They can be identified by hyperattenuating opacities within the lumen of segmental and subsegmental bronchi, often surrounded by areas of air trapping and bronchial wall thickening. And Dunica et al. At 2018, they formed a MAC plug score system, which is used to evaluate the presence and extent of mucus plugs in the airways. The score is ranking from 0 to 20, depending on the pulmonary segments that they are completely occluded from a mucus plug. A higher score indicates a greater burden of mucus plugging. Here you can see CT imaging showing a mucus plug within the airway. And here is another one. This is a patient 40 years old with allergic bronchopulmonary mycosis, which was also he was diagnosed also with MRSA. So we also have the MRI. It offers insight into ventilation heterogeneity, airflow obstruction, and regional lung function via rapidly acquired 3D examinations without the radiation exposure of traditional CT. Hyperpolarized gas MRI enables visualization of inhaled gas distribution within the lungs, allowing the detection of subtle ventilation defects that may remain unnoticed with conventional pulmonary function tests. These defects can be quantified as defect percentage, ventilation defect percentage across the whole lung or within specific lobes or bronchopulmonary segments. The ventilation defect percentage can reflect the extent of regional airflow limitation caused by mucus plug and provide functional complement to the structural data obtained from the CT. So here we can see it's a patient who took dupilumab for severe asthma with mucus plugs. On the first image, there is a CT, which shows that there is a mucus plug system score 18, and the images next to it, it's with hyperpolarized gas. The black is where there is no ventilation and where the mucus plugs are. And below is after the use of dupilumab with mucus plug score at 11. And you can see that there is a difference and the patient gets better. So further to the diagnosis, we can use the sputum analysis. We can use the sputum cellularity to help with treatment later, the eosinophilic, neutrophilic, granulocytic, and sputum cultures, of course. And also we can use the pulmonary function test, elevated FNO, and blood eosinophils. Chronic mucus plaques, if left untreated, are associated with fatal asthma attacks as they can cause complete occlusion of the airways. If mucus plaques are suspected as the cause of poor asthma control, reassessment will be needed in order to provide the proper treatment. And about the treatment, we have the pharmacological and non-pharmacological. Pharmacological treatment is we can use mucolytic and mucoactive agents, although we don't use so much the mucolytic treatments in asthma. We use them in cystic fibrosis more. We use monoclonal antibodies, bernalizumab, dupilumab, and dezepelumab. Long-term antibiotic therapies, we get to think about them when we have recurrent infections, and bronchodilator anticholinergic agents. Non-pharmacological treatment, we can use oscillatory positive expiratory pressure devices in order for the patient to get the mucus out of the airways, and hydration therapy with hypertonic saline and mannitol, but these, again, they are not so much used in asthma, they're used in other diseases. And that's it, thank you.
Thank you very much, Dr. Ioannou. And finally, last but not least, I have the honor to present my dear friend, Dr. Mata Tsikrika. She is president of the Hellenic Union of Pulmonologists. Go on, Mata.
I can not see my slide. Hello, warm greetings, everyone. My name is Mata Tsikrika. I'm coming from Soteria Hospital, Athens, Greece. You can see all my scientific references over there, but first of all, I'd like to thank Professor Patrikios and the organizing committee for this kindly invitation, and I would like to give you some very clear and concise take-home messages, because you will be attending to many presentations I think now, and let's start because time is flying. So, I'd like to present you a very important and timely topic, actually, which is no other than vaccination as a protective tool against smoking aggravating respiratory infections. No cloth for this presentation, and what actually do we need to know? Why smoking increases the risk of infection disease? First of all, damage the airway, epithelial barrier. You have heard a lot of that. Impair the continuity of ciliary oscillation, lead to mucus hypersecretion, delay the clearance. You have lungs that will be colonized by the reproduction of pathogens. And don't forget the second-hand smoking that actually impairs B and T cells response and reduce the production of antibodies. Here we have a systematic review, meta-analysis, very important, and please go through this and review it. You can see it with very delighted messages. And you can see that in conclusions, they are very important because there is a negative correlation and statistical one between every different types of COVID-19 vaccines and pneumococcal vaccine with smoking. Antibody titers were scientifically lower in female smokers. Remember, if you are a female, you might not have protection with any vaccines if you are a smoker. There is a negative correlation between active tobacco smoking and failure of tetanus vaccine, and also a negative association between active smoker and influenza vaccine. Don't forget that the efficacy of the vaccine will be reduced by the exposure of tobacco and depends to the specific typology of every vaccine. So smoking lowers immune cells counts, and the effect of tobacco varies depending, of course, from the individual smoking habits. Lower cytokine secretions persist for years if you stop smoking, probably due to your epigenetic memory. And nearly, is the most important, all the articles showed a negative relationships between tobacco and response to vaccines, whether expressed as antibody titers, vaccine effectiveness, or vaccine failures. Let's continue, let's proceed that all the world societies, all the world associations and organizations declares that we have high groups for vaccination, and these are the group of active smokers. These people are at increased risk for developing diseases such as influenza, pneumonia, and RSV. And furthermore, we have from UAK a very important study with the UAK Biobank for 12 years follow-up. You can see the huge number of subjects that have been participated, and you can see we have more than 20,000 cases of pneumonia. And the important is, I don't know if I have a pointer. Oh, I can do that here. So there was no prior history of major chronic disease. This is important because actually we've been healthy. And the current smoker smoked more than 23 cigarettes per day. And if you realize that in Greece, the majority of smokers actually have 1.5 or 2 packets a day, is a lot. So you can see that the most you smoke, you have higher risk of development, influenza, pneumonia, and even if you have been stopped smoking for many years, the risk still remains there. And another thing, if you are a heavy smoker and you have higher nicotine dependence, according to the Frankenstrom, you can understand that you have more possibility to develop not only pneumonia or influenza, but you can go to the hospital, to the ER, and maybe to the ICU. And please remember all that. And exactly what happened with the relation between the smoking and the risk of influenza hospitalization, and actually how we reduce the vaccines in the elderly. All the articles that have been reviewed actually have been for the patients that are more than the age of 65, because this is the very specific population for major implication. And you can understand that we have a smoking that it is associated with the risk of influenza, and you can see it's statistically correct and significant. And not only that, but the analysis by sex, so that it is higher in females, once more, is very important, than in males. And of course, and the fraction of getting influenza risk is up to 25%. And look at here, if you are a smoker and you get the season flu shot, then you won't go to the ER or you won't be hospitalized. And WHO, from February 2025, in that meeting that I was participating also, what they declare for that, for us, we have the trivalent vaccines actually for the next year. And why? Because our vaccines do not include anymore the B, yetamat, and antigen, because for 7 years now we do know that they produce no more disease, and we have egg-based vaccines and shell culture vaccines. You can do that. CDC, actually, what recommends that we have only one dose. Depends on your age, and of course depends on your comorbidity. We have different types of vaccines, and you can do that. And for the very first time in Greece, and I don't know if it's in Cyprus, we have the flu mist vaccine that actually you can spray in your nose. For Greece, it's up to 5-year-olds, but for CDC, you go to 45 to 50 years old, and you can self-administrate. That's very good. You can see here the recommendation, and this for the Greek students. You can realize that the national program of vaccination for the adults for the next year, you can see the flu season shot. And not only that, I know that you follow the same program vaccination. And okay, we understand about the influenza. What happened with pneumonia? And of course, if you are a current smoker or an ex-smoker, you have a higher risk to develop pneumonia. And of course, This seems to be an independent risk. Ex-smoker who had been stopped smoking more than 5 years have reduced that risk, and this is very important. So you have a profit. And of course, remember, if you are not a millennium like us, but you are more than 65-year-old, and even if you have been never smoker, but you have been exposed to secondhand smoking, then you have the risk, an increased risk to develop pneumonia. And of course, you don't have the risk only to develop pneumonia, but you have the severe type of pneumonia. What about passive smoking? This is an important factor that we have to talk loud and to understand that really affects our lungs. And why? Because 1/3 of the pneumonia, even in passive smoker, actually, they destroy the immune of the lungs, and they can definitely have more medication or definitely can go to the hospital. And actually, from the reviewing, we don't know if this interaction is per se from the age or from the prolonged exposure to passive tobacco smoke at their home. CDC, you can see still cigarette smoking. There is a recommendation. The same from the Greece and the Cyprus national programs. What about RSV? We have a very new vaccine, very important, very high quality. And actually, what is happening with the tobacco smoking? We know, and from the data released, we know that contributes to the immune response to RSV by stimulating and overlapping the signal transduction pathways. And are actually with interleukin 8, this gene, and only responds to the RSV infection, but also to the Helicobacter pylori and the hepatitis C. So if you have been vaccinated with RSV, you have a triple profit. Remember that. Both CDC and WHO for RSV vaccination, you can see the CPDO patient, actually they have a very heavy history of tobacco dependence, and from GOLD, we, the pulmonologists, we refer to that because it's the report for COPD, a very important to us report. You can see with evidence say that COPD patient can actually and should actually be vaccinated with this RSV vaccine. We have 2 actually of them now in Greece. And what about tuberculosis? Do smoking have a negative impact in tuberculosis? And yes, we know there's a key factor both active and latent tuberculosis. This is an independent risk factor for developing severe TB, and patients will create and will have increased mortality. And smoking and passive smoking, I can add, is associated with delayed diagnosis, unfavorable treatment outcomes, and relapse after therapy. So there is a vaccine for TB. Yes, we do know it's BCG vaccine, but actually all the recommendations have been changed, and there actually had been supplied and will be applied only to the patient and the subjects at high risk of exposure. And to conclude, and please remember, take home, this is very important, take home messages. Be no smoker. Have the vision of a smoke-free environment. Why? Because vaccination serves as a crucial protective tool against respiratory infections, particularly in individuals whose lung health is compromised by smoking. Targeted immunization in smokers not only reduce the infection incidence and severity, but also mitigates the exacerbation of respiratory conditions. And by promoting vaccination among smokers should therefore be a central component of health strategies, offering a cost-effective means to decrease both hospitalizations and to improve quality of health. Thank you so much.
Mata, thank you so much for the presentation. So one question, COPD patient, 67 years old, which vaccine?
We have COPD patients that actually they are diagnosed for 40 years old, so remember that.
I know. So I said 67 because that's the main reason. What kind of vaccines would you recommend?
First of all, we are running through the seasonal flu period. So we do know that it has to do with the seasonal flu, the trivalent
So flu vaccination?
flu vaccination, first of all. The same day, but different sites. They can do the pneumological, the vaccine for pneumologic, sorry, but I have to translate in my mind for the English. And of course, you have to understand that there is no specific time, but mainly in the winter time, that will be very good to have the RSV vaccine.
Great. So
that will be great.
Flu vaccination, pneumococcal if he never had one, and RSV
Yes,
vaccination.
and last but not least, we don't say that, but of course it is in our program, the vaccination for COVID-19 disease.
COVID-19?
We don't say it, but it's always in our mind.
Okay, great. Any questions?
Thanks. Okay,
Thank
we
you.
can proceed to the next session. Thank you very much.
Thank you.
So I think we're just on time to proceed with the next session. So if you could please be seated so that we can start. It is a great pleasure of mine to welcome Professor Kypereos, a dearest friend of mine. I don't think that Professor Kypereos needs any introduction. He's well known. He's a professor at Patria University, and he will speak for this peculiar molecule called HDL, and he will tell us what's new about it. Professor.
Thank you very much, Mr. Chairman. I really appreciate being here. It's a real pleasure and a distinct honor to be here, and I would like to thank my dear friend Yannis for making me part of this great conference once again. Thank you very much. Very nice to be here. And indeed, in the next 13 minutes, I will do my best to obey the time. I will try to talk to you about the high-density lipoprotein and the importance of this lipoprotein in cardiovascular risk. I have no conflict to disclose for this particular lecture. I think that everybody knows that in the last 30 or even 40 years, LDL cholesterol has been the main target for attacking atherosclerosis and coronary heart disease. So we have many different medicines that are targeting LDL and aim at lowering LDL cholesterol. However, the clinical experience has shown to us that the reduction in LDL cholesterol is associated with a tremendous benefit, but at the same time with a residual risk, which means that about a third of people who will meet the LDL cholesterol target, they're still at great risk of developing coronary heart disease. And this is because I think we all agree that atherosclerosis is like an iceberg. So we have the obvious factors, and at the same time, we have the non-obvious factors, those that lie underneath the surface. And one of these non-obvious factors is high-density lipoprotein, among others. In my view, high-density lipoprotein is the sleeping beauty of the lipoprotein world. It was first discovered in 1929 by Mikhail Markenbov. He was a professor of biochemistry, and he described high-density lipoprotein as a component of plasma. And in the mid-50s, John Goffman was the first who actually noticed the inverse correlation between HDL cholesterol levels and risk of coronary heart disease. The higher the HDL cholesterol levels, the lower the risk of developing heart disease, or the lower the HDL cholesterol levels, the higher the risk of developing coronary heart disease. Of course, everything we know about how high-density lipoprotein was officially established with the Framingham Heart Study, a long-standing clinical investigation that started back in 1948 and showed, and this is the first publication from the Framingham Heart Study on the topic in May 1977, that indeed if you have low levels of HDL cholesterol, these low levels of HDL cholesterol correlate with increased risk for coronary heart disease. Later on, in November 1986, it was shown again from the Framingham Heart Study that at every level of LDL cholesterol, you have a protective effect of HDL cholesterol. So the higher the HDL cholesterol, the lower the risk of developing coronary heart disease at every level of LDL cholesterol. And in March 1992, when the first survival data became available, it was also shown that the higher the percentage of HDL cholesterol in your total cholesterol, the longer the survival of those people. So that was something that established for the biomedical community the atheroprotective role of HDL in a clinical setup. Of course, numerous other trials and epidemiological studies came to confirm the data that were first established by the Framingham Heart Study. So the ARIC, the Inner Heart, MR-FEAT, EPIC, and PROCAM, all of them supported the same finding. The lower the HDL cholesterol levels, the higher the risk of developing coronary heart disease, and the higher the HDL cholesterol levels, the lower the risk of atherosclerosis and heart disease. And we know now that even at low levels, levels below LDL cholesterol levels below 70 milligrams per deciliter, HDL is atheroprotective. So at every level, as the Framingham Heart Study said, but even at very low levels of LDL cholesterol, HDL can still be atheroprotective. And we also know the opposite, and this is from the Framingham Offspring Study, with the next generation of participants in the Framingham Study, where they showed that at every level of LDL cholesterol and triglyceride levels, not only LDL cholesterol, but triglyceride levels, again, HDL can be atheroprotective. So this information, this clinical information, originally led to the hypothesis that HDL cholesterol shows an inverse linear correlation with coronary heart disease risk. So at first it was believed that this is a relationship that is indefinite and extends as long as you can lower HDL, you can increase HDL cholesterol levels. So this was mainly an extrapolation of the findings that were given from the Framingham Heart Study. Of course, the Framingham Heart Study had people up to 65 milligrams per deciliter, but then they extrapolated that the lower the HDL cholesterol levels, the higher the HDL cholesterol levels, the lower the risk of developing coronary heart disease. Of course, this is not true. We know now, after trials have fine-tuned this relationship, that we have a U-shaped relation. And so low levels of HDL cholesterol, as well as very high levels of HDL cholesterol, they all correlate with increased risk for coronary heart disease. And I'm going to get more into this and give a bit more detail. So now we know that the appropriate range is 40 to 70 milligrams per deciliter. If your HDL cholesterol is lower than 40, or if it is higher than 70, maybe 70 is a gray zone, but we can safely say 70. Most people will agree on this. Then your atherosclerosis risk will increase. And this is because HDL cholesterol, when we measure it, expresses the cholesterol of all particles in HDL preparation, and not only of classical atheroprotective particles. This is very important because this sets the basis for these phenomenon. We know that we have over 70 different proteins and over 400 different lipids that have been identified in HDL preparations. And from our studies in the lab in Patras, in collaboration with Lukianos Ralidis, as well as Yorgos Skroubis, we have tested different populations. With Lukianos, we tested populations of young people who suffered myocardial infarction, and we found that they have some distinct types of population compared to the healthy counterparts. Same thing with bariatric surgery, when you take somebody who has before bariatric surgery and then you operate them and then test them again, you see that the type of HDL that they contain in their plasma is very different. So we decided that we really need to start understanding what is the significance of these different populations and what these different populations may mean. So we thought that the safest way, as Dennis Green said, is to start from scratch and keep scratching. So we moved from the clinical setup and the clinical samples back to the animal world, where we could really do all kinds of modifications. So in this case, we used virus-mediated gene transfer of the main apolipoproteins that are associated with HDL, ApoE1, ApoE, ApoC3, and ApoE2. And then we did some significant biochemical analysis to understand how these proteins may affect the functionality of HDL particles. So I think that from this data, and I'm going to summarize them very quickly, ApoE1 has high antioxidant capacity, high cholesterol efflux, but at the same time, it's pro-inflammatory. So in order to have the anti-inflammatory capacity of HDL, you need to have a little bit of ApoE, because ApoE has low antioxidant capacity, low cholesterol efflux, but it is anti-inflammatory. Now, if your HDL contains ApoC, this may not be very good for you. The reason is that you have modest antioxidant capacity, low cholesterol efflux, and at the same time, you have a pro-inflammatory moiety. And now, same thing happens with ApoE2. ApoE2 is supposedly the second most abundant protein present in HDL, but it promotes ApoB particle deposition to the heart. So it's not a very good thing to have this apolipoprotein in your plasma. So from these studies, we came to conclude that the apolipoprotein content defines the lipid content, and both of them define the functionality, which led us to the hypothesis, which I think that is a prevailing hypothesis now, that HDL quality matters, and not all particles that are present in an HDL preparation are atheroprotective. Sometimes they can be atheroprotective, some other times they can be non-atheroprotective or even pro-atherogenic. Unfortunately, because of this complexity, the marriage of HDL and the pharmacology has not been successful yet. Even though preclinical studies as well as small clinical studies, they have shown promise, and this is what I call the HDL paradox. Large-scale trials failed. And I believe that there are many reasons that the large-scale trials fail, but the most important of all is, and this is an ongoing debate, is the linear relationship that was initially assumed. At first, as I said, we thought that there is a linear correlation between HDL cholesterol levels and the risk of developing coronary heart disease. Now we know that this is no longer the case. We know that this is a U-shaped relationship. And so in the beginning, when we were analyzing different medicines for raising HDL cholesterol, we were simply shooting patients from very low range of HDL cholesterol to the very high range of HDL cholesterol, where again, the risk was very high. So I think that the dose that was used and the main design of the trials that was so that you will increase HDL cholesterol to a great extent is the main flaw, and this is why these trials failed. And I can believe that eventually new medicines will come. For any one of you who has listened to this lecture before, I would like to say a few things about niacin. Niacin is the best known medicine that is currently available for raising HDL cholesterol. Do you have niacin here? No, you don't have niacin. It's unfortunate because I believe that niacin is a miracle drug. It's a miracle drug because it raises HDL cholesterol by 30%, reduces LDL cholesterol by 14%, reduces triglycerides and ApoB levels by 30%, and also decreases Lp(a) by 32%. And unfortunately, two bad design trials, the AIM-HIGH and the HPS-2-THRIVE, low quality trials, and so if anyone performs great analysis on the quality of clinical evidence from these trials, will conclude that the results are not those that we can rely on to make any recommendation. Unfortunately, they gave a bad reputation to this medicine. And I would like to remind everybody that the same would have happened with EPA, because strength showed failure. So if it wasn't for the REDUCE-IT that came and put things into proper perspective, today we will not have Vascepa, an excellent EPA medicine that is currently used for reducing residual cardiovascular risk. So I think that the niacin case should reopen. So as everything, I think that even the field of HDL follows the Gardner-Hype cycle. So if we really have very low or very high levels of HDL cholesterol, then we need to do something about it. And so if somebody has HDL cholesterol 29, then that person would be in the left side of the curve at increased risk for coronary heart disease, regardless of all other lipids, as the Framingham Heart Study has shown to us. And so we need to do something. If niacin is available, I believe that niacin would be the most appropriate medication. If not, then it's important, and this is what I recommend, to upgrade risk and treat all other factors more aggressively, including LDL cholesterol, and at the same time suggest some therapeutic lifestyle changes, including, for example, physical activity, keep away from saturated fats, increase alcohol consumption, etc. But same is the problem when somebody has, let's say, 110, because if you have 110, then you are on the other side of the curve. You are on the right side of the curve, where again your risk is very high. So what do we do here? Unfortunately, right now, there is no treatment for very high HDL cholesterol levels. I think that the best thing to do is upgrade risk and reduce more aggressively all other factors, including LDL cholesterol, and at the same time, look for underlying conditions. For example, any underlying inflammatory condition may raise HDL cholesterol to very high levels. So this is something that we should also look into. I think that the last 25 years have been privileged to investigate and explore the boundless world of lipoproteins, and I think that we not only started investigating, but we keep investigating, we keep on scratching, and soon I believe that we will be able to give a more detailed information of what defines non-functional HDL, what are the factors that show this kind of peculiar behavior of HDL, why at very high levels, high-density lipoprotein is not functional. Just to give you a preview, what we have seen is that because of a certain protein and a certain mechanism, and of course, unfortunately, we have analyzed just a very few low number of clinical samples, we have a reduction in the atheroprotective HDL, and at the same time, we have a production of new particles with a totally different mechanism that will eventually lead to the deposition of lipids to the aorta instead of promoting reverse cholesterol transport. And closing this presentation, I would like to thank you. I would like to thank my dear friend Yanis. Thank you so much for giving me the opportunity to be here. Of course, I would like to thank all my colleagues, and particularly Dr. Anca Kafencu from ICBP Institute in Bucharest, Romania. We ran a European Union grant together and on this particular topic. And of course, I would like to thank all my dear friends and colleagues all these years for their patience, most importantly, and for believing, or at least pretending that they believe in my views on HDL cholesterol. Thank you very much.
Thank you very much, Professor, for an excellent presentation. Are there any questions? Please.
Think that in the next 5 or 10 years it will be possible on an average way to count HDL subparticles? I mean, you could send blood exams and ask, could I please have ApoA, ApoC, ApoC2, etc.?
Yes. As a matter of fact, we can do it now.
But
we can do it now because
you can do it, but not the average lab.
Yes, but we're narrowing down. We're narrowing down, and so we know that there are specific factors, and just these specific factors need to be measured. You don't need to measure everything. So, I believe that in the next, certainly in the next 10 years, this will be a routine, and maybe we will be able to propose also a medication, especially for lowering very high HDL cholesterol levels, because you have the production of particles that will deliver cholesterol rather than receive cholesterol. So you just need to measure those.
Thank you very much. I think we can proceed to our next speaker. Sorry, we have a question. Please.
Excellent as always. But we come across to the genetic polymorphism, which probably dictates who is a good responder in having the small other constituents of HDL, ApoC or ApoA, like lipoprotein A is playing an important role. And I don't know whether it's going to be any genetic polymorphism-driven kind of identification, who is at risk at a lower. It's irrespective of the U-shape relationship with the cardiovascular.
Yes, this is a very good question. I think that with respect to the very low levels, yes, we may see some polymorphism, but with respect to the very high levels, there is a totally different mechanism which is independent of polymorphism. It's like a new de novo mechanism of synthesizing particles that will, instead of receiving cholesterol, will deliver cholesterol. So it's totally different at very high levels. At very low levels, yes, I can see this, especially by silencing genes like ApoE1 or reducing the expression of these genes. So, but certainly I think that this is, HDL should not be something that, because we don't understand it very well, we should just discount it. It's something that we should definitely take into consideration.
Thank you very much. So, it seems that we do have a lot of things to learn about HDL molecule, and maybe in the near future, it could be a therapeutic target. We can proceed to our next speaker, Dr. Richter. Dr. Richter, besides being a good friend of mine, he's the president of the Hellenic Society of Lipidology, so he has the expertise to speak about the advances in lipid-lowering therapies. Dr. Richter.
Dear Chairman, dear colleagues, dear Ioannis, thank you for the invitation. It's always a pleasure to be here. And yes, what we will talk now is more easy, because LDL for the moment is much easier than HDL. Just bring it down and you know you will get a benefit. And we saw that from the 70s, the 7-country studies in which we saw that countries with less cholesterol had less coronary artery disease. Of course, you know, the more we learn and we read about the myth of the 7 countries, one of the myths was that it's only what in Crete and Corfu, which participated in the country, was the positive part. We see that it was also the quantity, what people were eating at that era of the 60s in the villages in Crete and Corfu was very, very low calories. So it also helps. All longevity trials and experts say that we need to eat the less possible. And we didn't know if pharmaceutically driven cholesterol lowering was really useful until we had 4S, 1994, first trial, simvastatin, first statin to be tried in a trial. Until then, all fibrate trials had failed, and we see a 30% reduction in total mortality. And then it starts a storm of new studies trying to explore the lower limit of where we should arrive. And as you see in 4S, we arrived from 180 to 120 LDL. We started arriving to 60, 70. Jupiter and Improve It arrived to 55. And then the PCSK9 trials, evolocumab, arrived to 35. So we are practically chasing LDL down. We are almost reducing it completely. Atorvastatin was the first and most successful drug, the Lipitor saga. It came at the right moment with obviously the right marketing. It made the best studies. It studied everything, every question that existed about statin at that era, and it was much more potent and with less interactions than simvastatin. And after that, still until today, it's high dose of atorvastatin and rosuvastatin, which are considered the high potency statin that America and European Union are suggesting that we should use in the majority of our patients. We know that if we arrive LDL to 70, we can have a halt in the progression of atheroma, and if we arrive at 60, we can see regression. Regression was first seen with asteroid, I think 15 years ago, and it was first story in all the news across the Atlantic because it was the first time we managed to reduce atheroma volume with intravascular ultrasound. IMPROVE-IT showed us that we arrived with ezetimibe very low, and as Kyriakos said, a drug can live or die due to a good or a bad trial. And why I must say that the original design of IMPROVE-IT was you take patients with acute coronary syndrome, you give to all of them simvastatin, LDL 69.9, and then you give in the half of them on top ezetimibe. You plan you will get 2,500 MIs in 2 years and a half. What happened? Because when people plan, God laughs, as we say in Greece, it needed 7.5 years to arrive to that number of MIs. Why? Because each time we calculate, where we are based on data of 10 years ago, and patients are getting treated always better. So this wasn't an event-driven study, and we have the result that ezetimibe is an excellent drug, and it's saving a lot of lives of patients because somebody was clever enough to say, no, we'll not make it time limit, we'll make it event-driven. And that saved the drug. If it was time limited, we would say no benefit. What we needed after statins was something for people with myalgia. Myalgia is considered to be from 5 to 15% of patients who are taking statin. A beautiful study made in UK, published in New England Journal of Medicine with, I think, 120 patients, which is unique. And what did they do? They took patients who were unable to take statin. They said that they were non-tolerant, and so they gave them 12 bottles. For 4 months, you are taking the first bottles was atorvastatin 20, exactly what they had taken, and they said they couldn't stand it. 4 months it was placebo, and the other months it was nothing inside. And what's really incredible is that, as you see in the pink and the red, placebo and atorvastatin were very near in the myalgia. They had only a 2% of difference. With the white are people who had empty bottle. So people are not always having myalgia from statin. They are having myalgia because they take a pill and they believe the pill is the devil who brings all the bad things. And that's human nature. But we shall always remember when a patient tells us about statin intolerability that we need to check and discuss it again and again. So we had bempedoic acid in the latest guidelines, first time a drug that is acting in the same axis as statins, but it's a prodrug that does not exist in the muscle practically, so that's quite useful. It gives us a 25% ulterior reduction of LDL. You see how it acts. It made a study, a big study, in which it showed that it reduces cardiovascular events. So now in patients who have real myalgia, we can have bempedoic acid, which goes together with ezetimibe. And you see no practically muscle disorders. But the big gun are the PCSK9s that we use over statin ezetimibe, 60% reduction evolocumab. You see their study, it arrived at 30 milligrams per DL, significant reduction of the primary endpoint. And here it's a very nice thing, because doctors love waiting a lot of times, especially internists. They think a lot and they act less. So what we saw here, you see the study, half of them had 30 milligram per DL LDL and the others were on placebo. The moment the study finished, they made Fourier-Olé, which means let's see now that all the patients will be taking evolocumab if these first 2.5 years that it was the randomized trial would make a difference. And what's really incredible is that on 8 years, the fact that half of the patients took 2 years more these drugs had a significant reduction in mortality. So don't just go low, do it early, and do it for the longer possible time, because we just see a number on cholesterol exams of patients, but we don't know how much atheroma volume has been created all the period that we're just thinking what to do. So we need to act faster than we do today. We have inclisiran that will help a lot on compliance because it's a 50% reduction, but it's every 6 months. Every 6 months, it's a very big benefit. And we have 2 studies, we believe they will be read in a couple of years, in which practically persons high risk coronary artery disease, we will check if inclisiran reduces cardiovascular events and all, not also LDL, because it's a PCSK9 acting through mRNA, so it needs also a study. At the moment, it's in the market but as a cholesterol-lowering drug. And I believe it will be a revolution because having a drug that you can give every 6 months will change patient's life. The other PCSK9s are every 15 days. And you see here that if we add all the armatory we have, we can reduce LDL by 80 to 86%. If somebody was telling that 30 years ago when people were just eating the white of the egg and leaving the yolks to reduce the cholesterol they were getting through food, it's a miracle. High triglycerides, Dr. Kypreos said it, it's not always the lower the better. Fibrates are beautiful drugs if your risk is pancreatitis, because they reduce them 50%, and same as volanesorsen. But if your question is if you will reduce the possibility of NMI, of a stroke, only EPA are beneficial through the REDUCE-IT study. And what we learned is that things sometimes are more complex than we think. For example, here is the indication from ESC. It's not always the same. We saw that 4 drugs of EPA per day can reduce in a significant way the hardened points, but it's independent if you achieve the optimal triglyceride of less than 50 or more than 150. It seems that high triglyceride is a marker of a pattern that needs to be treated with EPA. Doesn't mean that if somebody goes his triglycerides to 140 and the other to 190, that they will have a real reduction between them in cardiovascular risk. And what we saw in the latest guidelines, they were just published 2 months ago from the European Society of Cardiology. I had once again the honor to be part of the authors. We changed the score. The score now is on events and not on deaths. Is it important? Yes. Because if I tell you that you have a 5% probability of dying, if you are a Greek optimist, you will think I have 95% of being perfect, so I can continue to do whatever I like. If you hear that you have 20 to 25%, because that's the analogy, 1 to 4 to 1 to 5, to get a stroke or an MI, you start hearing the doctor, okay, maybe something's not good here. Check your patients, look their carotids, look their femoral arteries, look if they have atheromatosis. Be more aggressive to those who have risk modifiers. If they get an MI, give them directly the best and the more potent you can. Give them directly statin plus ezetimibe. European Society of Cardiology decided that 25, we wrote it in Hellenic Journal of Cardiology in 2016 as a consensus paper that it should be done in Greece. And in Greece, it's been done also by the Greek EOP 3 years ago. So we were good on that. LPA, yes, everybody now in Greece, due to the prevention program, is looking at LPA. It's not anymore the 30 milligrams, the cutoff, it went to 50 where it really starts, and stop giving dietary supplements. They are very good only for pharmacists because they get a very good reimbursement, but they don't give anything to the patients, and patients don't live longer by getting supplements. And we have seen that in all their way. So, dear Chairman, dear colleagues, by closing, remember, the lower the better, the earlier the better, and the longer the better. Thank you very much.
Dr. Richter, thank you for an excellent presentation. One more time, an excellent presentation. And thank you for the clear take-home messages. I think we have time for just one question, please, if there is one question. Let me ask you something, Dr. Richter. If you had to choose just one biomarker for predicting future cardiovascular events, which would that be? Would that be LDL, LDL to HDL ratio, ApoB, LPA?
If I could choose only one marker in the totality of patients, probably ApoB, because the real difference is that in patients with low HDL and high triglycerides, LDL, because in the majority of patients it's done through the Friedwald formula, and it's completely inaccurate if you have high triglycerides. ApoB would be more real.
Thank you very much.
Thank you.
Dr. Millonis, if you like to.
Lipid-lowering treatment, but I have to defend internal medicine. We are the ones that we think before, during, and after acting, and the super specialists are those who act and they think later.
I agree. My only difference is that a lot of internists think too much before and act too late.
It's not like that.
They are not all as good as your department, Dr. Billion.
It's with great honor to introduce the next speaker, a very good friend of mine, Dr. Professor Charalambos Millonis. Professor Millonis is a professor of internal medicine at the School of Medicine at the University of Ioannina. He's the president of the Hellenic Atherosclerosis Society.
The X1.
The X1, yeah. His research interests focus on the pathophysiology of atherothrombosis and disorders of lipid metabolism, the clinical and epidemiological study of risk factors for cardiovascular diseases, as well as the secondary prevention of stroke and the prognosis of vascular stroke. He is author of more than 400 publications, and I would like to thank him for helping our clinic for the last publication we did at the Bologna Hospital. Professor Millonis is now going to give a lecture with the title Lipid Management in Special Population, Women, the Elderly, Patients with Diabetes, and those with chronic kidney disease.
Thank you, George. It's really an honor to be here. I want to thank you for inviting me to contribute to this great Congress. And always I'd like to comment on the great hospitality we receive here. Thank you, George, very much. I'll try to to address or outline actually the lipid-lowering treatment in these special populations. So I'd like to start with women. When we're going to treat women for hyperlipidemia, we actually have to address sex-specific cardiovascular disease factors, considering the age of the lady, the potential for giving birth, the period before and during pregnancy, the period after pregnancy, and the period before and after menopause. So we have to consider early menarche, the polycystic ovarian syndrome in women, the oral contraceptives they might take, the preterm birth, and the preterm menopause. In pregnancy, we have to address things like diabetes, hypertension, preeclampsia, and in the older women, menopause and hormone replacement therapy. So what are the steps we are going to take in these women? First, we have to screen for these sex-specific risk factors. Afterwards, we have to assess for traditional risk factors like hypertension, diabetes, hyperlipidemia, or metabolic syndrome. Of course, we have to implement lifestyle modifications and aggressively treat the traditional risk factors. And we have always to treat to target, especially if they have a risk that is considered borderline or intermediate, and they have sex-specific factors, as I first mentioned. During pregnancy, HDL cholesterol is stable, but total cholesterol, LDL cholesterol, and triglycerides may actually increase. There is an increase also in Lp(a) levels. And of course, after menopause, there is an increase in the cardiovascular risk. So what we should do in women? We have always to screen for lipids, hypertension, the presence of diabetes, and other modifiable risk factors. And we have to consider lipoprotein, little-a levels, as well as if we can actually test for coronary artery calcium. The mainstay of treatment is encouraging exercise and lifestyle modification. And afterwards, when we should actually seek for pharmacological treatment, statins are the mainstay. So can we give statins during pregnancy? We can. The Americans use statins in pregnancy in women with a history of familial hypercholesterolemia and LDL levels higher than 190 milligrams per dl. We have to consider the danger from giving drugs like ezetimibe, bempedoic acid, fibrates. We can give actually safely the bile acid sequestrants, and we have to consider that with the anti-PCSK9 therapies, we have insufficient data. What about the elderly? LDL cholesterol is a major cardiovascular risk factor for coronary death in the elderly, both in females and males. But the actual benefit from pharmacological treatment is greater in the elderly. The numbers needed to treat in the elderly are lower in order to avoid a future event. So the reduction of the absolute risk is greater in this age. What about intervention trials? In the primary prevention, by prescribing ezetimibe, we have found that there is a decrease in the relative risk of cardiovascular disease when this is combined with statins. And what about the secondary prevention? In the IMPROVE trial, Dr. Richter mentioned it before, the greater benefit, that is the greater relative risk reduction and the greater absolute risk reduction was seen in these patients with an age of 75 years or older. And what about combining statins and ezetimibe in this population? We can start with a low dose of a moderate statin and we can combine it with ezetimibe. The benefit is the same as by using high intensity or very potent statins. What we gain is that we have less adverse effects and more patients actually stay on treatment with this combination. So in primary prevention, we should treat patients of an older age despite any potential risks of statin-associated muscle symptoms, despite any concerns about the new onset of type 2 diabetes, and despite any concerns about drug-induced cognitive impairment. We should treat the elderly in the same way as the younger ones. We should actually aim for the same targets. In the secondary prevention, we should always prescribe anti-hypolipidemic therapy to patients regardless of their age. We should always pay attention to potential drug-to-drug interactions. Renal function impairment should be taken in mind because sometimes this increases the toxicity of our drugs, including statins. We should always take in mind the performance status and frailty in these elderly patients. And we should never discontinue hypolipidemic treatment like statins, except for the frail patient. What about the future studies? We need more data about giving statins in patients over 70 or 75, and we need to analyze the data from this study in patients who receive a statin and they have to stop it. And what about the diabetics? The diabetics who are young, that is, diabetics with type 1 diabetes and an age of less than 35 years, or type 2 diabetes and an age less than 70 years, are considered of medium risk, of moderate risk, and should be treated to a level of LDL less than 100 milligrams per DL. If actually they have a duration of diabetes longer than 10 years, they should be treated as a high-risk population and should be treated to a level of LDL less than 70 milligrams per DL. And if they have more than 3 risk factors or they have a target organ damage, they should be treated as a very high-risk population and should be treated to an LDL of less than 55 milligrams per DL. What drugs we should use? Drugs that lower actually the apolipoprotein B. So we should use statins in combination with ezetimibe or anti-PCSK9 therapies. If triglycerides are higher than 135 milligrams per DL, we can actually use icosapent ethyl, 2 grams twice daily. Or if triglycerides are higher than 500 milligrams per DL, we should actually prescribe fibrates to reduce the risk of pancreatitis. What about Lp(a)? When Lp(a) is increased, the risk doubles in patients with diabetes compared to those without diabetes, where the hazard risk is 1.4, as you can see. But we don't do well in patients with diabetes. Actually, in the primary prevention and in the moderate risk, we can actually treat patients to a low LDL, less than 100 milligrams per DL, in the majority of patients, about 50%. But in the high risk and the very high risk category, we can actually do it where in 1 in 4 of these patients. And what about the chronic kidney disease? Most of us do not know that we have chronic kidney disease. 9 out of 10 do not know that we have actually an impairment of renal function. As EGFR increases or albuminuria is present, mortality is increased. Chronic kidney disease amplifies the risk of other traditional risk factors, for example, diabetes mellitus. Hyperlipidemia increases the risk of cardiovascular event in a renal patient and deteriorates renal function. As renal function decreases, and mostly when it decreases lower than 60 ml per minute, what happens is that HDL decreases, LDL decreases, but Lp(a) and triglycerides increase, and this is more pronounced in those with an eGFR less than 45, in patients in dialysis, and in those with a kidney transplantation, where actually the lipid profile is more atherogenic, with an increase then in LDL cholesterol. We, among others, have shown that in this population, Lp(a) is increased, and mostly the very small apolipoprotein Lp(a) particles. And this is due to a decrease in the catabolism of apolipoprotein Lp(a). In a trial with patients in dialysis, diabetic ones, when they gave atorvastatin in 20 milligrams per day dosage, there was no significant decrease in the risk. What happened is that the benefit was seen in those with a pretreatment level of LDL cholesterol higher than 150 milligrams per dl. In patients with dialysis, when rosuvastatin was given, not only diabetics, there was not a significant decrease in the risk too. In the ALERT trial, in subjects with a renal transplantation, there was not a significant decrease in the risk when they were given a very mild statin like fluvastatin and a very low dose, 10 milligrams per day. But the benefit was seen in the non-fatal MIs and the cardiac deaths. In the SHARP trial, in patients receiving conservative therapy or peritoneal dialysis or hemodialysis, there was actually a benefit from giving a statin in combination with ezetimibe. The most benefit was seen in those patients who were not dialyzed. And this was confirmed in meta-analysis that the benefit is seen in patients who are not on dialysis. And it's also confirmed in meta-analysis with about 200,000 patients. What about the renal transplant patients? In those subjects, if we start early, we can actually decrease the risk of a future cardiovascular event. What about giving anti-PCSK9 in these subjects? There is a benefit in these subjects, although we don't have data for those with a GFR less than 60 ml per minute. And the absolute risk reduction is greater in subjects with actually chronic renal disease, as we can see in this trial. And when we give icosapent ethyl, what happens? The benefit is there. It's independent of the eGFR, even in patients with eGFR less than 60 ml per minute. What do the renal doctors, the nephrologists, suggest and recommend? Then when the eGFR decreases to a level lower than 60 ml per minute, we should actually start with a statin and combine it with ezetimibe. The cardiologists also agree with this agreement of the nephrologists. They say that if we have a stage 3 chronic renal disease and onward, we should give a statin plus ezetimibe. If it's a renal transplant patient, statin ezetimibe is the standard treatment. If it's a dialysis patient and he received the statin before, we should continue, but we should not start a patient at dialysis a statin afterwards. So what we should do? We should always treat the risk and not the stereotypes. When it's about women, they get the equal benefit. and we should take into consideration plans for pregnancy or lactation. When we consider older subjects, the absolute risk reduction is greater in these people, but we have to take in mind frailty and polypharmacy. We start low and titrate to the target. When we treat diabetics, we should consider them as high risk or very high risk and treat accordingly. When we treat patients with chronic kidney disease after stage 3, we should use statins plus ezetimibe. We should avoid fibrates, especially in advanced CKD, and we continue treatment if dialysis starts. And always we should keep in mind that we have to use combination treatment. So we have to treat the risk, to treat to target, and always combine early and be as aggressive as we can. Thank you for your attention.
Thank you, Professor Mignoni, for the excellent presentation. I think that the messages are very clear from the last slide we have seen. We're running out of time, so we have to proceed. We are not going to have any questions. You can ask Professor Mignoni during any time in the Congress. So we move on to the next presentation. Thank you. Thank you.
Ladies and gentlemen, dear colleagues, we have to move now to a bit different field, in the surgical field. And we are going to discuss in the next session aortic dissection. Aortic dissection is a common problem in our societies, in West societies mainly. And we have to discuss this dissection from the root of the aorta to the bifurcation of the aorta. We have with us 4 very dedicated cardiac and vascular surgeons, all of them working in Cyprus, and I'm very honored to be the chair of this session, and I have to express my sincere thanks for this invitation to European University Cyprus, the organizing committee, and especially to my close friend, Professor Ioannis Patrikios. So we are going to start with the clinical professor, Dr. Ioannis Zanavaros, who is an adult and pediatric cardiac surgeon and director of the Cardiac Innovation Center, University of Nicosia Medical School at Apollonio Private Hospital here in Nicosia. Dr. Zanavaros' areas of interest include the full spectrum of acquired and congenital heart diseases, with a particular focus on minimally invasive heart surgery. He has made significant contributions to the field through his research on atrial fibrillation and congenital heart defects, as well as innovations in cardiac surgery techniques. His lecture today has the title of Type A Aortic Dissection, Innovations in Surgical Management, and we are proud to have him here and listen to him. Please.
Dear Chairman, thank you for the very kind introduction. I would like to thank at first Professor Patrikios, a dear friend, for this kind invitation. It's a beautiful venue here, So let's start with this very interesting topic. I don't have any disclosures. So at the right side, you see the root of the aorta of a patient that was referred to us with 10 centimeters in diameter. On the left side, you see dilated aorta of an 8-year-old child with congenital aortic stenosis. Aorta is the first and the largest artery in the body. With each stroke, the aorta transports about 70 milliliters of blood, and this is more than 450 liters in a lifetime. It's quite a job to perform, okay? And because we have a lot of students here, let us remind again that the aorta has 3 layers: the intima, the media, and the adventitia. And if you think deeper, you will see that the aorta is an organ, is a part of an organism which is typically self-contained and has a specific vital function. It's a functional unity. What is aortic aneurysm? We speak of an aortic aneurysm if the diameter is 1.5 times larger than the predicted one. It's in a woman when we have, in a man, if we have more than 45 millimeters. If we have a diameter from 38 to 45, we speak about the dilatation of the aorta, of the aortic root. On the left side, you see a very typical aortic root aneurysm of about 8 centimeters that had to be urgently operated. There are very less data about the incidence of aortic aneurysm. I citate now one of the main findings that I could find, but there are actually no data about Cyprus, no data about Greece, and no general data about the European Union. So if we speak about patients from Canada, the incidence is 3.5 to 7.6 to 100,000 people. It's rare. In Sweden, the findings are similar, and maybe the most precise study about this comes from Iran, and the incidence of an aortic size of larger than 36 millimeters was 12%, and of patients having an aneurysm more than 45 millimeters was 1.2%. Aortic dissection is even more rare than aortic aneurysm, of course. But aortic dissection is associated with significant mortality and morbidity, with rapid treatment paramount. It is caused by a tear in the intimal lining of the aorta that extends into the media of the wall. The topic is about the type A dissection according to the Stanford classification, and we speak about type A dissection when the ascending aorta is involved. So aortic dissection affects 3 to 4 persons per 100,000 people per year. Male, with male preponderance, males are more treated than the women, and it's more common between the ages 50 to 70 years. Most of the people have arterial hypertension, aortic valve disease, family history, a smoking history, or they have connective tissue disease. Without intervention, mortality is 50% by 2 days. And there are reported 75,000 deaths in the US from 1999 to 2020. So it's a major burden for the health system of every country. So what about type A dissection that's treated? The mortality is still very high. Historically, the reports give a rate about 21 to 37%, irrespective of patient's age, and it exceeds 50% in patients who present in shock. This has evolved rapidly, but still the risk of death is high. And there are specific protocols after the diagnosis of a type A dissection. The patients must be referred immediately to a heart surgery center. He must be stabilized with his blood pressure, and should have a pain management, and then he should go to the OR ASAP. We speak about modern trends and everything, but let me repeat again, the goal of this operation is survival. You see a patient referred to us when I was in Germany, in Stuttgart, with acute type A dissection, with pericardial effusion. The target is survival. There are modern managements that I will speak now, but please keep in mind the first and most important thing is that the patient will be alive at the end of the operation. So first, there are changes in the arterial cannulation strategies. We don't cannulate the ascending aorta anymore. We cannulate the axillary artery. This is safer, and it allows us to perfuse the brain during the operation. Alternative strategies such as carotid cannulation or femoral cannulation are reserved for other indications or very complex dissections with malperfusion syndromes. Cardioplegia developments have been, for me, the most essential change through the years. Cardioplegia protects the heart, and recent studies showed that the del nido cardioplegia that we are currently using is quite as safe as the other cardioplegias, but has a lower rate of other cardiac complications. So it helps us during the recovery of the patient. A major issue is cerebral and visceral protection during surgery. Hypothermic circulatory arrest remains a cornerstone of cerebral protection during heart surgery, but moderate hypothermia combined with antegrade selective cerebral perfusion through the axillary artery that I have shown in the previous slides provides superior neurological outcomes compared to deep hypothermic circulatory arrest alone. The combination of NIRS for cerebral oximetry has been essential to control the effectiveness of the cerebral protection. Ascending aortic replacement with or without hemiarch or total arch repair is the standard operation. An extended arch operation may be mandated when there is an arch tear, arch aneurysm, or concern about the heritable thoracic aortopathy. This is a picture of our first implantation of frozen elephant trunk in Cyprus that was performed in our clinic in the Cardiac Innovation Center of Apollonion. So outside of singular aortic or ascending aortic or hemiarch replacement, some people advocate a more extended arch operation to reduce the potential need of future aortic reintervention, promote distal aortic remodeling, and reduce the likelihood of malperfusion. And frozen elephant trunk procedure allows the simultaneous arch and descending aorta stabilization. It's a bigger operation, but it helps the patients in the year after surgery. The surgical techniques of frozen elephant trunks are now established, and this is a current routine also in Cyprus. I have the pictures of my former chief, Professor Haverich and Professor Borst, who developed all those techniques. A new development is the AMDS tool. It's a nitinol frame that is designed to stabilize the dissection flap, promote false lumen thrombosis and aortic wall remodeling, and it also encourages positive remodeling of the diseased aortic arch. It's also used in Cyprus as well, but there is limited data concerning this technique. The first data show a very good result concerning thrombosis and aortic remodeling in the patients. Well, a very important issue is the aortic root. Changing the valve might be the easiest solution for the patient, but definitely the best one is to repair the root. On the right side, you see a valve sparing procedure using the David technique, which is currently also a routine in the daily practice. This allows the patient to have a normal life after surgery. It reduces the danger for infective endocarditis and the need of anticoagulation. And it should be used if the surgery is going well and if you have time during the surgery. This is also a very important cornerstone. This is a 130 kilo patient operated in our department before 10 days because of type A dissection. He was extubated directly after surgery and he was mobilized the next day. So enhanced recovery after surgery is quite essential to reduce the time of hospital stay after type A dissection and after every kind of operation. So speaking about data, what is the current trend? What are the results now? So contemporary surgical mortality for type A dissections range from 5 to 15% in experienced aortic centers and 10 to 25% in general centers, with neurologic complications in 5 to 10%. Use of axillary cannulation, moderate hypothermia, and hybrid techniques has improved the outcomes. There are some important things that due to the lack of time, we have to skip them. I want to show you our results. We had in the cardiac innovations among 1,409 patients operated the last 4.5 years. We had almost 190 operations concerning the aorta and 10 dissections. Patients with dissections were older. We had more reduced in the ascending aortic group. Length of stay was longer in the dissection group. Mortality was highly acceptable in the ascending aortic group that had to do with pental operation, hemiarch operations, hip frozen elephant trunks was 2.1%, and we are quite proud to have a zero mortality in type A dissection, but I must admit we had luck. Maybe statistics are brutal, maybe the next 2 patients die and then the mortality is not so low. I don't want to emphasize on these results. And the other major complications were low in both groups. So let's see about the future. Emerging trends include the integration of intraoperative 3D imaging, patient-specific endografts, minimal invasive aortic access, multidisciplinary aortic teams, hybrid operations that will optimize the care. On the right side, you see the results of endovascular treatments. Endovascular treatment will be the treatment of choice in the future beyond doubt. So to conclude, type A dissection is a pathology with a mortality rate of up to 60% without surgical intervention. Surgery is still the gold standard of treatment. In the last 50 years, there have been significant advances in medical and surgical management, which have contributed to significant reductions in patient mortality. And most recently, there have been a number of both open and endovascular techniques that will likely further contribute to reductions in morbidity and mortality. Thank you for your attention.
Thank you very much for this very nice presentation. We have to move to the next one, and at the end we have a discussion altogether. And I have to call the Clinical Associate Professor, Dr. Neophytos Zambas, a very well-known vascular surgeon here in Cyprus from the University of Nicosia Medical School, working at Areteo Hospital here in Nicosia, and the president of the Society for Vascular and Endovascular Surgery of Cyprus. And as we heard, all data and innovations in type 1 dissection affecting the ascending aorta, now we are moving to the descending aorta, and Dr. Zambas will talk to us about endovascular treatment that is the standard of care in type B aortic dissection.
Dear Chairman, I would like to thank Professor Patrikios for the kind invitation one more year. Dear students and dear colleagues, I'm going to talk about the endovascular treatment about the type B aortic dissection. As you watched before, we have the type 1 and type B aortic dissection. When type B, the tear of the intima is after the left subclavian artery, and we have the non-A, non-B, where the tear of the intima is on the aortic arch. So I'm going to discuss about the dissection distally of the left subclavian artery. As you said before, there is an intima, a tear on the intima, and then there is a flow between the layers of the vessel. So this is called dissection, and that's what we're going to discuss. About the history, looking the literature, I found a reference back in 1965 about the management of acute aortic dissections, and on that time, the management was non-surgical. So we can see here a publication in 1965 about the treatment of dissected aneurysm of the aorta without surgery, and one more reference the same year with the same indication of treatment. So acute dissection is defined as a dissection happening within 14 days of the onset of the symptoms, and thereafter it is defined as subacute between 2 weeks and 3 months, and then after 3 months is called chronic dissection. The last guidelines published from the European Society of Vascular Surgery was back in 2017 about the management of descending aorta disease. And there we can see that the gold standard of diagnosis is the CT angiography. And here you can see the tear on the intima after the left subclavian artery. The management of the non-acute dissection is considered to be medical, and here we can see some references, but thoracic endovascular repair was developed as a first-line therapeutic option in patients with complicated acute type B aortic dissection. So the aim of the endovascular repair is to treat the malperfusion of the visceral branches to cover the primary entry tear and to reduce blood pressure within the false lumen. Here we can see the recommendations about the treatment, and in patients with complicated acute type B aortic dissection, endovascular repair with thoracic endograft should be the first line of intervention, and this is the recommendation 16, and the recommendation 17 is in complicated acute type B aortic dissection, endovascular fenestration should be considered to treat malperfusion. Now, comparing the surgical treatment with endovascular treatment, the recommendation 19 in acute complicated aortic B aortic dissection, open repair should be considered as an alternative to endovascular therapy following failure of endovascular management or where endovascular interventions are contraindicated. Looking to the literature, the treatment of aortic dissection type B is more medical, and has been the standard of care in a complicated type B aortic dissection. Surgical repair and endovascular intervention are reserved for those who present with or subsequently develop dissection-related complications. But from all these patients, about 25% may include organ malperfusion when they're complicated, aortic rupture, periaortic hematoma, and uncontrolled hypertension. So the question raised is if we have to treat these patients endovascularly to prevent complications of the type B aortic dissection. So through the years, endovascular treatment has gained widespread acceptance as a modality of choice for the treatment of complicated type B aortic dissection, and this transition is representative of advances in technology, physician experience with aortic endografts, and lower morbidity and mortality rates associated with endovascular repair of type B aortic dissections. Going on about the treatment of dissection type B, about the trends and updates in the management of acute and complicated type B aortic dissection, again, the guidelines are shifted forward the endovascular treatment, and this emphasizes individual care to optimize outcomes. The American Association of Thoracic Surgery, the American College of Cardiology, the American Heart Association, and the European Association of Cardiothoracic Surgeons have consistently updated their guidelines to incorporate new evidence, notably advocating in particular for the selective use of thoracic endovascular aortic repair for high-risk and complicated type B aortic dissection patients. There is an ongoing study about the aortic dissection international registry of acute aortic dissection, and this it includes analyzed data of about 4,500 acute aortic dissection patients over a period of 17 years. Of these, 33 patients were type B aortic dissection cases, and patients with type B aortic dissection were predominantly male, the 2/3, with an average age of 64 years, and 81% of them had hypertension. The data from this study reveal evolving management strategies, and initially most type B aortic dissections cases were managed medically, about 75%, but this proportion has decreased to 57% as endovascular management increased from 7.3 to 31%. So we see an increase in percentage of endovascular treatment of type B aortic dissection. When open surgery use declined from 17% to 8%, while hybrid procedures grew from 0 to 5%. And the surgical mortality rates improve over time from 30% to 20.1%, reflecting the impact of better patient selection and enhanced surgical techniques. In the same study, the management strategies saw significant changes, and the endovascular therapy rose from 19% to almost 40%, while medical management dropped from 66% to 54%, and open surgery declined from 50% to 7%. The in-hospital mortality decreased from 11% to 6%, with survival rates showing improvement over time, particularly in the later cohorts. This decline in mortality highlights the effectiveness and updated treatment strategies in type B aortic dissection. This is a technique of the preemptive, that means intervening before complications develop, TIVAR in a complicated type B aortic dissections, but I'm not going to spend much time. Now, the risk factors in a complicated type B aortic dissection, there are imaging-related risk factors like total descending aortic diameter of more than 4 centimeters, intimal entry TR of more than 1 centimeters, false lumen diameter of more than 22 millimeters, entry TR of the inner curvature, and entry located within 2 centimeters of the origin of the left subclavian artery. When clinical risk factors is uncontrollable hypertension and persistent pain of the patient. This is an image of the stabilized technique where you can see a tube graft and uncovered stent graft from the visceral arteries. Now, the engineering developments and the computational modeling has highlighted the importance of type 3 arch anatomy, which is an acute angle of the aortic arch, which has been associated with increased wall shear stress and drag forces. Techniques such as fluid dynamics, finite element analysis, and fluid structure interaction modeling are being employed to gain deeper insights into the biomechanical properties of both the aorta and stent grafts. Simulation studies aim to facilitate patient-specific treatment strategies, offering the potential to optimize outcomes by tailoring interventions to individual anatomical and biomechanical profiles. Here we can see some images of the developments of the technology. We can see a T branch, which is a tube graft with a branch for the left subclavian artery to seal very proximal to the origin of the left subclavian artery. So by this way, we avoid a bypass, a caroto subclavian bypass. We have as well fenestrated grafts and inner branching grafts to treat iliac aneurysm and the visceral branches in type B aortic dissection, which involves the visceral branches. Here we have a patient. I'll show you an example of our practice. This patient has a type B aortic dissection, which is after the left subclavian artery, as we said before, and these are the pre-operative images. This is a 3D reconstruction of the aorta. So for this patient, the first step, we treated the descending aorta with a tube graft. You can see that the graft origins from the left subclavian artery, and this was the first step of the procedure. This patient is a 63-year-old patient, which treated last year, but he had a history of type B, of type A aortic dissection, treated surgically in 2015. So about 10 years later, he presented with pain, back pain, severe back pain, and we after investigating this patient, we found this dissected aneurysm type B. So the patient was in warfarin, and in 2019 he suffered a stroke and he had left hemiparesis. So as a first step, we treated the descending aorta to avoid the spinal cord ischemia. In a second stage, we treated the visceral branches down to the iliac arteries and the internal iliac artery, as you can see on the left. This was the first stage of the procedure. This patient, 2 months after, he came back for a third procedure to cover the dissection extending to the left external iliac artery. So to treat this patient, the patient had 3 procedures, and now he's good and he can have a good quality of life despite his hemiparesis. The next patient is a patient who came initially in 2013.
Dr. Zabas, you have to conclude because we are running
this is the last
out
case.
of time. Okay.
So it's a type B aortic dissection. He was treated medically until last year, when we, in a follow-up, 6 years after the last one, we noticed an increase of the false lumen. So this patient treated with a tube graft, as you can see. And we are waiting and we're following the patient, so we didn't treat the visceral branches. He's 61 years old now, so he had the dissection 10 years ago. He was very young. So there are some clinical trials about the type 2 aortic dissection, and we are waiting their results. Thank you very much.
Thank you very much indeed for this very comprehensive review of type B dissections. And now we have to move on, so we have some time for discussion at the end, to Dr. Triandafylos Giannakopoulos, who is a vascular surgeon and co-director of the vascular surgery department at the Mediterranean Hospital in the Limassol in Cyprus, and has a broad expertise across the vascular spectrum, especially in complex aortic repairs, and also an active researcher. So he's going to deal with the title, what are the treatment strategies in isolated abdominal aortic dissections. Now we move from the descending thoracic aorta to the abdominal aorta. Please, Dr. Yankopoulos, please try to be on time to have time for discussion at the end.
Professor Massagas, thank you for the introduction. First of all, I'd like to thank Professor Patricios. I'm delighted one more year to be with you today. I will talk, since this session is dedicated to the aortic dissection, I will talk about the least frequent topology of the aortic dissection, the infrarenal part. So it's encountered less than 2% of all aortic dissections. They are found to be only abdominal, and the usual suspects are men, in the 60s or 70s, with a background of atherosclerosis and hypertension. And what's the definition? It is a dissection which is confined below the diaphragm, without or unrelated to a thoracic entry tear. Mechanistically, it is an intimal tear in the infrarenal abdominal aorta, most usually associated with an intimal atheroma or a penetrating ulcer. And this creates a false lumen that can propagate to the iliacs or the visceral branches. And this false lumen is pressurized and may or may not proceed to form an aneurysm. Clinically, half of the patients have pain, which can be, and most frequently is acute, localized, non-migrating abdominal or back pain, while the rest of the patients are asymptomatic and the finding is only incidental. Complications are rupture, distal embolization, and splanchnic artery malperfusion, mostly renal and visceral. Of course, hypertension is a factor that precipitates the situation and is associated with pain, which means that the false lumen is pressurized. The gold standard for the diagnosis of the infrarenal dissection is the CTA, computed tomography angiography. And what we focus on the CTA is that the entry site and the length of the dissection, the true lumen and false lumen perfusion, and perfusion of the branches, of course, which branches are involved, and of course, max diameter and expansion rate. In order to be on the same page with other colleagues, we need to incorporate systems that code the length and zone of the dissection. And this is the SVS, STS classification systems, which includes type A and B, together with two numbers indicating the entry and exit tier and re-entry tier. And the malperfusion types, of course, it's commonly known that can be static, with an intimal flap obstructing the orifice of a splanchnic vessel, can be dynamic, where the false lumen itself under high pressure causes obstruction of the ostium, or can be both of them. And of course, in order to be able to treat these conditions of malperfusion, we need to know that the intimal flap evolves with time and starts with being soft and mobile, and with time it becomes less mobile, more rigid, and finally ends up in a chronic immobile dissection flap. The natural history of this disease, according to this recently published paper, shows that most uncomplicated isolated abdominal aortic dissection remain stable, just with strict blood pressure control. The risk of rupture is less than 5%. However, aneurysmal degeneration can grow up to 20 to 30% over time. And the predictions of this evolution is initial diameter more than 30 millimeters, false lumen, persistent pressurization, and persistent pain, of course. Management overview, the strategy is medical when the patients are uncomplicated. And the key points to this is blood pressure control with a goal of systolic pressure lower than 120 millimeters of mercury, heart rate control, and serial, of course, imaging to detect complications. When complications occur, then endovascular minimally invasive techniques are the techniques of choice, and indications are persistent pain, expansion, rapid expansion, rupture or contained rupture, or malperfusion of a target of a splanchnic vessel. Of course, open repair is still the last choice for when endovascular techniques cannot offer the solution. However, they come with higher morbidity. And the natural history of conservative management of isolated abdominal aortic dissections is better when patients do not have symptoms. So symptomatic patients fare worse in the long term. And when you compare survival between endovascular treatment and best medical therapy, you can see that patients that were treated with best medical therapy did worse than the ones operated upon with endovascular means. And the endovascular outcomes come with technical success more than 95%, with very low peri-op mortality of less than 2%. The symptom relief is immediate, and the durability is long-term, and of course similar to endovascular aneurysm repair for abdominal aortic aneurysms. Intervention rates are fairly high, 10 to 15%, mainly to manage endoleaks or expansion. And as a tip, I could say that when planning, we should always aim for proximal neck seal more than 15 millimeters. Avoid, of course, covering renal ostia unless we have a way to reperfuse them. And both European scientific societies and across the Atlantic or joint societies guidelines mention isolated abdominal aortic dissection and propose strategy. They all agree that it is a rare pathology. It should be dealt with strict hemodynamic control, CTA-based surveillance, frequent one, especially when we have symptoms, and we should incorporate an endovascular first strategy when intervention is indicated. The main divergence is only on how to aggressively define complicated dissection. So follow-up and surveillance is fundamental in detecting and treating complications. After conservative therapy, CTA at 1 month, then 6 months, and then yearly. And after endovascular management, 1 month, 12 months, and then annually, if stable. And the endpoint should be false lumen thrombosis, diameter stability, of course, and stent integrity. The most recent published paper for isolated abdominal aortic dissections compares complicated versus uncomplicated patients. It's a retrospective, multi-center, 200-patient cohort with 13 years of follow-up, in which the authors report that 38% presented with complicated dissection. And these complicated patients had larger initial aortic diameters, had more frequent false lumen perfusion, and had, of course, higher rate of intervention. Endovascular means were used in more than 80% to treat them, and the technical success was confirmed to be 95%, very low 30-day mortality, up to 1.5%, without late ruptures. For uncomplicated dissection, more than 80% of these patients remained stable on best medical therapy. And let me just quickly mention a case. All dissection cases are controversial. This was not per se an isolated abdominal aortic dissection, but it played out like this in the end. This is a case which came with pain, had an intramural hematoma in the descending thoracic aorta, which presented with rapid expansion. And on the 4th day, you had on the right here, you have a dissection at the inferior mesenteric artery ostium. This is a 3D depiction of the case, where you see that the intramural hematoma spared all the splanchnic segment and ended up here, dissecting and disrupting the anatomic integrity of the ostium of the inferior mesenteric artery, causing a saccular aneurysm. The patient was symptomatic, and of course we treated the patient. I skipped the thoracic tube part, so this is the intra-op angiogram. You can see the saccular aneurysm, 4 days old. We coiled first the IMA, inferior mesenteric artery, and then covered the luminal part with a stent graft. And this is the result, the thoracic part. This is the result, no perfusion of the pseudo aneurysm. This is a 4-day result image, and this is the 2-month-old CTA. You can see full remodeling of the aorta, no sign of intramural hematoma or saccular aneurysm, and this is a 3D model. So what is the take-home message? This pathology, isolated abdominal aortic dissection, is very rare but increasingly recognized. Most uncomplicated cases can be treated medically with surveillance, and endovascular techniques are safe and effective for complications or growth. Evidence remains low level, and we need multi-center registry data. Whatever we do is evidence-informed, not evidence-proven. Surveillance is mandatory irrespective of treatment, because a stable dissection can become unstable in the long term. And always protect splanchnic vessels. Thank you for your time.
Thank you, Dr. Giannakopoulos, for this very nice presentations. And we now have to move to the last one, which is maybe the more interesting one, that we have spared the aortic arch, and the aortic arch had a lot of innovations the last 5 years at least. And clinical professor Dr. Theodosios Bisdas, who used to work in Münster, Germany for several years, and now he's working mainly in Athens, but also in Cyprus, I think, Theodosios, will cover that field. And the title of his lecture is Endovascular Solutions for Aortic Dissection Involving the Aortic Arch. Please, Theodosios, stay on time to have some time for discussion, because at 5 o'clock we have the opening ceremony, and this is very strict.
Okay. Thank you, Miltos, for the very kind introduction. I would like to thank Professor Patrikios for his very kind invitation. So, endovascular solutions for the aortic dissection. We are now in the aortic arch, a step further and closer to the aortic valve. Here are my conflicts of interest. So, who are the candidates for an endovascular aortic arch repair? Regarding the acute phase of dissection, we're talking about type B dissection, where we do not have landing zone behind the left subclavian artery, and in the chronic phase, the cases that Professor Zanavaro showed with already replaced ascending aorta with a post-type A dissected thoracoabdominal aorta, or a type B dissected thoracoabdominal aorta with an aneurysmatic degeneration where we do not have any kind of landing zone just below the left subclavian artery. Keep in mind, type B dissection, of course, everybody wants to stay behind the left subclavian artery, makes the things really simpler. However, if you do not select a healthy landing zone, and this is what happens in a paper in British Journal of Surgery, they have seen that they have higher intervention rate, higher aortic growth, and higher mortality risk. So there are two now scenarios. The first scenario is to have a type B aortic dissection with a landing zone just between left common carotid and left subclavian artery. In this case, we have heard already several treatment strategies. You can do a bypass and a TEVAR. You can do the so-called chimney, that means parallel endografts into the aorta. You can create a small fenestration, a window through a laser cutter into a TEVAR. You can provide a so-called physician-modified stent graft that you are creating a fenestration on the table and then you are implanting this, or you can use the so-called single branch device, the last word of technology that we have, as Professor Zabas showed. I will not focus on this. I will focus in the most, let's say, challenging part, where we have the endovascular post-dissection aortic arch repair, where we may have either an already replaced ascending aorta, or we do not have any kind of landing zone just below the supraortic vessel, so we have to go to the so-called zone 0. Zone 0 is more or less the ascending aorta. There is a systematic review of different aortic stent grafts. If I want to analyze and to summarize in a table, you will see that we're talking about high-risk patients. That means very acceptable mortality rate. All of these patients, they have Euroscore really above 20%. However, the Achilles heel remains the stroke rate. 14% is an unacceptable rate for this kind of treatment strategy. There are several available endografts. We have single branches where we need a total bypass between the different arteries. We have dual branch device, triple branch device, or fenestrated device. With all these devices, as I said, it remains the stroke, the main Achilles heel. And how it happens through the manipulation of the device in an aorta that may have plaques or thrombi alongside the wall. It may happen through the bubbles that the device could have during the flushing, or even due to the cerebral perfusion. Until you open your device, you are stopping the cerebral perfusion for a few seconds. At the moment, looking at the prospective trials, we have seen that only one device has the lowest stroke rate, 3.6%, and this device is the device that we have started using also here in Cyprus and also in Athens. This device is the Nexus Aortic Arch Endograft. Keep in mind, all the arch endografts that we have, they are thoracic endografts with fenestrations or branches. For the first time, we have a total different concept. We have a concept of two devices that they are connected at the zone 0. This is, of course, revolutionary. It's difficult to understand, but the design behind it, the results prove its efficacy. It has a very sophisticated delivery system, and here is the video how it can be implanted through small holes. It gets into the brachiocephalic trunk. It opens nicely with this big hole looking to the ascending aorta. This is the first part, and then you have two branches that you are getting inside. You are cannulating the left common carotid artery. You are cannulating then the left subclavian artery, and at this time you're inserting as the last part the stent graft for the ascending aorta. The connection force between the two devices is 20 Newton. That means it's almost that this device, this connection can keep 2-liter bottle just in the air without having any kind of disconnection. Really powerful connection. So why do we have lower stroke rates? Of course, it's the pre-curved delivery system that mimics the aortic root. We have a very dedicated and sophisticated dual flushing port. That means no bubbles at all. We have pre-cannulations wires. That means quick cannulations of the total of the supraortic branches. And finally, all the majority of the device are between 24 and 26 French profile. One French is about 0.3 millimeter. We're talking about big devices. We have here a 20 French device, and this really makes the difference. There are 3 different types of stent grafts depending on the anatomy that you have, the aortic arch. You can use a single branch device and you're doing a bypass between the carotid arteries. You can use a dual branch device, or the very last device that we have, a total endovascular, no cut downs, everything transcutaneously. So we have an experience from 2020 on, and it's until 2025. It's one of the biggest experiences at the moment worldwide, with 32 patients. We have post-type A dissections patients, aortic arch aneurysms, and post-type B dissection without landing zones. It is almost 26 patients with dissections in the aortic arch. different type of devices. This is a Nexus 1 device where you can see the bypass between the branches. We have the Nexus Duo, and since December 2024, we have now the Nexus 3, and we're almost using, in almost all cases, the Nexus 3 devices. We have published our 2 years experience together, Athens and Areteo, in the Journal of Endovascular Therapy, with really very good results, having 100% procedural success, no strokes, survival at 1 year, 79%, and type 1 SC endoleak 7%, only one patient from the left subclavian artery. This is some case presentations. This is a full metal jacket. This is the very, very first patient that we have done, started from the aortic arch and ending up to the hypogastric arteries. The second one, 56 years male, post-type A dissections, very nice outcome with a carotid subclavian bypass. A very tough case, young lady, Marfan syndrome, previous repair of the ascending aorta, Jehovah's Martyrs. She didn't want to be operated, and she had a type B aortic dissections with a very interesting, you will see the majority of the students here, you will hear it for the first time, the so-called arteria lusoria. That means the left subclavian artery going to the right hand, and that means we have 4 branches here, and here we have done a very sophisticated bypass between the carotid arteries and the left subclavian artery, and we have used the branch for the arteria lusoria with a very good final result. This is how it looks like intraoperatively. This is a patient's post-type A dissection with a replacement of the ascending aorta. Very nice job from the cardiac surgeon with a long ascending aorta, and this is how it looks like inside. We are inserting the stent. We are looking with the angiogram where we have to open, not to cover the right common carotid artery. Now the device is opening. You see the ring. The ring shows the right direction to the ascending aorta. We are cannulating quickly the branch for the for the left common carotid artery. Insertion of the stent. This is the left common carotid artery. This is the left subclavian artery, and also implantation of dedicated bridging stent graft for this as well, and so goes on until the ascending aorta. This is the final result in these patients where you can see a very nice patency and a very nice exclusion of the aneurysmatic aortic arch. However, the big challenge is the ascending aorta, because there are not all surgeons, cardiac surgeons, so let's say not good, but they are not thinking always to create a very good landing zone. And sometimes you have kicking there, or you have a very short grafts to land. And we know from cardiac, from other patients, that if you want to perform the TEVAR at the ascending aorta, you may end up with really big problems and disasters very closely to the ascending aorta if you're using the classical ascending grafts. Why is this a problem? Because it's the only artery, the only part of the body where the inner curve is shorter than the outer curve. So you cannot use any kind of TEVAR devices there. So for this reason, these devices has created, in my opinion, the best model of ascending graft with a short inner curve, long inner curve, and several other features that allows a very precise placement, even in this kind of ascending aortas that you have to be very, very careful. This is the last 2 cases where we end up with the marker of the stent graft just at the level of the left coronary artery, and this seems how now, let's say, confident we are with this device. And it seems in the 4D flow cardiac MRIs that we are performing in our patients that we do not have any kind of myocardial dysfunction due to the recirculation zones of the stiffness that creates the stent graft into the aorta. So prospective data, and I'm closing with this. We have prospective data. It is the only device at the moment in the market that is going to have an FDA approval, and they have the dissection arm with an independent core lab for neurological events. In this study from the US, they have seen 5.6% stroke rate, as I said, the lowest in the literature. So in conclusion, a healthy landing zone is very important, of paramount importance in the aortic arch repair. Stroke remains the Achilles heel for an endovascular aortic arch repair. The Nexus endograft, in my opinion, is the next big thing, and it seems to be the future workhorse endograft, and the ascending module is currently the only dedicated device for the ascending aorta, ideal for this kind of post-type A dissection ascending replacement. Thank you very much.
Thank you so much, Theodosius. Please have a seat, and I call all the speakers to have a seat in the podium. We have just 10 minutes for discussion before the opening ceremony starts. And I'm going to start with this very late talk. We have here a cardiac surgeon and a vascular surgeon experienced a lot of cases in the arts. And of course, we saw that we have a lot of innovation in the vascular surgery and the vascular repair of the aortic arch. But also, during the last years, we have also many improvements in cardiac surgery in the aortic arch, especially with the frozen elephant trunk. So I have to ask Dr. Zanavaros and Dr. Bizdas, what are their opinion of what is the gold standard today in treating pathologies of the aortic arch? Please.
Well, very good question. Very good question. First, the most important thing is the experience of the surgeon or the interventionalist. In a very experienced center, you get excellent results both ways. Especially if you have a combined problem of the ascending aorta, which is the most common thing. You rarely have only a pathology of the aortic arch. You most probably have a pathology of the ascending aorta. So an experienced surgeon is still the best way to treat. But I am convinced that through the evolution of the techniques, of endovascular techniques, that the future, maybe in 10 years, will be maybe completely endovascular.
So I agree. My opinion, the future is the so-called multidisciplinary approach. That means we have to have a discussion between cardiac surgeon and vascular surgeon, and especially if in a center both are really excellent and well-skilled to do the same job. I think we have to focus on the patients. There are several criteria like the Euroscore, like anatomical criteria, where you can say this is not a candidate for an endovascular repair. I would agree that the future looks to the endovascular approach. However, according to my knowledge, what I can understand from engineering point of view, for me it sounds very, very difficult to repair endovascular and sending aneurysm with an insufficient valve. So in this case, I think we are far away of treating the ascending aorta, the aneurysmatic ascending aorta by endovascular means, and due to the fact that, like Professor Zanavaro showed, it is simple and safe to create a very good landing zone for the ascending aorta. And nowadays, the cardiac surgeons, they are doing really with mini sternotomies, with all type of minimally invasive cardiac surgery. I think this part of the body still belongs and will belong to the cardiac surgery.
I also think that a big issue in endovascular interventions that we also use, and it's very good for high-risk patients, is durability. And we know that durability of cardiac operations in the aortic arch is high, is very good through the years. And now with the FET technique maybe becomes much more better, but for endovascular repairs, we don't know the durability of the devices. We don't know yet the durability of such operations in healthy patients that are quite young. And this is an issue for me.
This is totally right. That's the reason why all the prospective trials have started, including first high-risk patients, and now they are starting going very, very carefully to the moderate-risk patients.
Thank you, both of you. And coming to Dr. Zambas and talking about dissections of the descending aorta, type B dissections, what is your opinion about treating uncomplicated dissections? It is a big issue that has not been resolved for the last 20 years that we have the endovascular era. What is your practice in that? And I want the opinion of the other members of the panel of treating uncomplicated type B dissections.
Yes, this is a challenging topic. That's why there are no guidelines. So it's according to the surgeons and the MDT team to decide. The first patient I presented had a type B aortic dissection more than 10 years and was complicated. So I believe that the regular follow-up is very important for these patients. Although we have to prevent the proximal extension of the type B aortic dissection, which could be very more difficult and more challenging to treat. So in case we have increase of the diameter of the dissection, then I think that it's indicated to treat type B aortic dissections to prevent further expansion of the dissection. So my opinion is to follow closely this patient to treat the blood pressure and the other risk factors. And if we notice a change to the dissection, then I think with the new devices is better for the patient to treat the dissection preventative to prevent any complications either of proximal expansion or of visceral occlusion or ischemia.
Thank you. And what the randomized trials showed so far in this field is that when treating uncomplicated dissections, we don't have a special urn at the early phase. We don't have reduced the mortality statistically, but in 5 years, these patients have much better results than the patients treated just with best medical treatment at the first instance. And if there is no other opinion, and as the time runs out, coming to the abdominal aorta, what are you thinking, Triadaphilos, about these cases that are not so often seen in everyday practice, but of course we saw some of these dissections that are dissections that find incidentally in some CT scans, and the physicians tell to the patients, oh, you have a dissection of the abdominal aorta, you have to be careful, you have to be operated. Are these uncomplicated patients have any efforts to do that endovascularly or open, or just let them and just surveillance?
Thank you for the question. As I've said, the evidence is scarce. This is a very rare pathology. So the key to approaching this pathology is symptoms, I think, and of course imaging. When we find out, then we need to evaluate progression and of course evaluate risk factors of the patient. I think endovascular is first choice, if we can do it endovascularly, if we can offer it to the patient. Open is only for cases that cannot be performed endovascularly. And these cases can be tricky because they frequently involve ostia of the splanchnic vessels. And this can be very tricky to overcome sometimes. So the risks are high, and we need to put it on the scale and decide. Patient-specific, of course.
That is a key point. Where is the entry point in the entry tier in the abdominal aorta? How far is from the splanchnic vessels? It is a very critical point. Is there any question from the audience? Yes, please.
Ischemia of the lower limbs as a complication, or has it been reported? And the second question for the panel, what do you use for myocardial protection for the total repair of the descending and ascending aorta?
Very good point. So due to the fact that we're talking about a relatively small profile device, 20 French, keeping in mind that 20 French is the profile that we're using for standard EVAR in the abdominal aortic aneurysm. So those patients are patients that they are post-dissection patients, and the majority of them, they have large vessels or vessels that they are relatively ectatic. So it is very rare. The only things that may happen, and you have to be very careful, is in case that you have difficulties with the false lumen giving blood to the arteries, you have to create fenestrations to do something like this. We still did not have any kind of these cases, but they have been described by opening the thoracic endograft and opening the true lumen and creating then ischemia through the false lumen to the legs. In those cases, there are different treatment strategies like cutting endovascularly the membrane or opening dissection stents without covering the splanchnic arteries. In our series, we didn't have this kind of problems.
Additionally, I would like to ask, it's very important to keep patent the hypogastric arteries for the lower limb ischemia.
Well, to speak about myocardial protection, we use in all cases, pediatric and adult cases, regardless of age and pathology, we only use del nido cardioplegia, and we combine it with moderate or deep hypothermia. It's been extremely effective.
Thank you very much. Unfortunately, we
Yes.
don't have time.
Yes.
We don't have more time. Thank you very much, all the speakers from the panel. And I have to say that I'm very satisfied that in Cyprus the level of cardiac and vascular surgery is almost very high and comparable to any other European country, and this is really an achievement. Thank you very much all for attending this session.
Sorry, we now have a 15-minute break before the opening ceremony. There is no need to go out, it's a break.
Ένα, δύο. Ένα, δύο. Ένα, δύο.
Ένα, δύο. Ναι. Hey. Ναι. Ευχαριστώ. Ένα, hey. Hey. Ένα, hey. Ένα, hey. Hey. Ένα, hey. Ένα, δύο, Pambo. Galiendas. Ένα. Ένα. Hey. Ένα, δύο. Ένα, ένα, δύο,
Βάζεις με εμένα.
Άψε.
Πίσω. Ναι, άστο να δω. Περίμενε, πρέπει να το σώσω εγώ. Έλα, μίλα. Ένα, δύο, ένα. Ναι, πιέσε εδώ. Κάτσε να δω. Tutto damento vogliamo. Ναι, μίλα.
Δεν σημασία.
Επειδή Άμα ήταν post, πρέπει να κάνουμε mute. Κάμε ξεμute, το δοκίμασα.
Ένα, δύο, είστε.
Περίμενε. Τώρα σε βάζεις δαμέ πριν, που είναι καλή. Έλα. Να δουλέψεις post.
Ένα.
Γίνε στο monitor και άμε το. Να σου πω. Το monitor flat πατάς και κάνεις, εντάξει, τούτο το extra είναι
Ένα, δύο,
Surge compressor, εντάξει. Θα το βάλουμε με flat, εντάξει. Το gain του καναλιού και το master του monitor.
Ένα, δύο, ένα, δύο.
Ψηλό το λόγο, ας πούμε, και τι κάνουμε. Βάσεις. Ναι, απλά μιλάμε.
Ένα, δύο, κότσι,
Να σου βάλω και στην
Μα αγάπη μου πώς. Αγάπη μου πώς θα βγω εγώ.
Δεν είσαι καθόλου να μου.
Θα ακούω, με κόφτει. Πάρε εγώ, με κόφτει. Πού να γάμω. Δεν τρέχεσαι ρε. Δεν μου δεν έχασες παρακολουθήσεις. Ερεμήσω.
Να κάνω mute.
European University Cyprus is a leading international university which stands apart for its high academic values, its high-tech campus, and its commitment to the wider community. With a significant regional presence, it has distinguished itself in academic excellence and scientific research, with an impressive rate of growth. Times Higher Education World University Rankings place European University Cyprus among the top universities in the world. While QS Top Universities give European University Cyprus a 5-star rating for its overall performance. Highly interconnected with the economy and society, the university is a hub of entrepreneurial innovation and social engagement. Its auditoriums host globally acclaimed personalities, and its lecture halls welcome world-class academics. Committed to an international growth strategy, European University Cyprus has expanded its presence in the heart of Europe with the establishment of the School of Medicine in Frankfurt. Take one step forward onto the unfolding path of your future. European University Cyprus will give you the knowledge and the power to begin that journey. European University Cyprus, empowering greatness.
Dear Professor Andreas Evstathiou, Rector of European University Cyprus, dear Professor Lois Zosimou, Vice Rector of Academic Affairs, distinguished guests, ladies and gentlemen, dear students. On behalf of the European University School of Medicine, we would like to welcome you to the 13th International Multi-Thematic Scientific Biomedical Congress. As part of tonight's events, we would like to welcome a quick musical piece of art from the group Galesma, who will present an enticing program with Cypriot and Greek folk traditional music.
Test. Λοιπόν, καλησπέρα σας. Είναι μεγάλη μας χαρά που είμαστε σήμερα μαζί σας. Εγώ και οι φίλοι μου, συνεργάτες μου, ο Χαράλαμπος Παντελή και η Κατερίνα Παράσκου, θα παρουσιάσουμε μερικά τραγούδια σε ένα μικρό πρόγραμμα με κυπριακά παραδοσιακά τραγούδια. Ελπίζω να το απολαύσετε. Good evening, everyone. Me and my colleagues and friends, Charalambos Pandeli and Katerina Parascu, are going to perform some Cypriot folk songs, traditional songs. I hope you enjoy. Thank you so much.
Χίλια καλώς ορίσατε όσοι μας αγαπάτε κι εμείς καλά να μείνουμε κι εμείς καλά να μείνουμε κι εσείς καλά καλώς ευρεθήνε και πάλι να βρεθούμε και και περισσότερες χαρές να καταξιωθούμε. Καλώς ήρθαν οι φίλοι μου από τα 1000 μίλια και εγώ θέλω τους φίλους μου και εγώ θέλω τους φίλους μου παραδούκα τα 1000. Ανοίξε γέριμη καρδιά, μένει σε κλειωμένη. Τραγούδισε τους φίλους μου, τραγούδισε τους φίλους μου, τώρα πως είναι αμένοι. Κότσινη τριανταφύλια μου, αμάν, αμάν, και ψούμι μου βασικό και λακλούδα μου να πάμεν φως μου κι ας σε χάσω εναντίκον. Κρέμα στα μαλλιά σου κάτω, αμάν, αμάν, κι αφήσ' τα ξεκρέμαστα και λακλούδα μου να πάμεν φως μου κι η καρδιά μου εβάστα. Κότσινη τριανταφύλια μου, αμάν, αμάν, εύκα απ' έξω στο στενό. Να μου δοκιμεί η ροθιά σου φως μου, να μου γιάνει τον γάμο. Κότσινη τριανταφύλια μου, αμάν, αμάν, πόψε να έχεις ανοιχτά. Να το κι να σε φιλήσω φως μου, ίσια τα μεσάνυχτα. Να το κι να σε φιλήσω φως μου, ίσια τα μεσάνυχτα.
Thank you.
The next song is called Ψιντρή Βασιλιά μου. Το επόμενο τραγούδι είναι η Ψιντρή Βασιλιά μου.
Ψιντρή βασιλίτσα μου και μαντζουράνα μου, ψιντρή βασιλίτσα μου και μαντζουράνα μου, εσύ θα με χωρίσεις από τη μάνα μου, εσύ θα με χωρίσεις από τη μάνα μου. Ευκά στο παραθύρι κορί το γυαλενόν, ευκά στο παραθύρι κορί το γυαλενόν, να δω το πρόσωπό σου το σιμιγδαλενόν, να δω το πρόσωπό σου το σιμιγδαλενόν. Στη σκάλα που ξεβαίνεις να ξεβαίνα κι εγώ, στη σκάλα που ξεβαίνεις να ξεβαίνα κι εγώ, σκαλήν και σκαλοπάτιν να σε γλυκοφιλώ, σκαλήν και σκαλοπάτιν να σε γλυκοφιλώ. Ψιντρή βασιλίτσα μου και μαντζουράνα μου, ψιντρή βασιλίτσα μου και μαντζουράνα μου, εσύ θα με χωρίσεις από τη μάνα μου, εσύ θα με χωρίσεις από τη μάνα μου. Thank you.
Chakara Makara, the next one.
Άιντε πουλί μου κι έρχομαι κι από το σούσμαν το σέρκο τσακάρα μακάρα φωσκέρε κι από το λύσμαν τους άιντε πουλί μου κι έρχομαι, άιντε πουλί μου κι έρχομαι κι αγκαλιά αγκαλιά σαν τη ροθιά τσακάρα μακάρα φωσκέρε και καστανά μαλούθια άιντε πουλί μου κι έρχομαι, άιντε πουλί μου κι έρχομαι κι αγκαλιά αγκαλιά πέφτουμε, άιντε πουλί μου κι έρχομαι κι αγκαλιά
Thank you. Ευχαριστούμε.
Τα μάτια, τα γυαλούρικα, δεν εξώ. Αχ, τα μάτια τα γυαλούρικα, κι όπου τα δω αγαπώ τα. Αχ, τα μάτια τα γυαλούρικα, κι όπου τα δω αγαπώ τα. Αχ, γιατί σεντάκι καλή μου, τσίνοι που αγάπουν πρώτα. Αχ, γιατί σεντάκι καλή μου, τσίνοι που αγάπουν πρώτα. Αχ, τα μάτια σου ενίζιανελιές, πάνω στο κλωνάρι. Οχ, τα βρύδια σου καμαρωτά, σαν δυο μερό φεγγάρι. Οχ, τα βρύδια σου καμαρωτά, σαν δυο μερό φεγγάρι. Αχ, αρέσαν μου τα μάτια σου, άρεσε μου το δι σου. Οχ, άρεσε μου κι σκουφωσιά που έχει στην κεφάλι σου. Οχ, άρεσε μου κι σκουφωσιά που έχει στην κεφάλι σου. Αχ, τα μάτια της αγάπης μου στην άκρα μελένα. Οχ, κι άμα δικλείσουν να με δουν, στα σιγαριά μου γεμάν. Οχ, κι άμα δικλείσουν να με δουν, στα σιγαριά μου γεμάν. Οχ, κι άμα δικλείσουν να με δουν, στα σιγαριά μου γεμάν. Ευχαριστούμε.
Thank you.
It was a pleasure. Χαράλαμπος Παντελή, Κατερίνα Παράσχο.
Thank you. Πάρης Παράσχος. Thank you so much.
Thank you, Galisma, for that beautiful musical performance. Now, we would like to call upon stage Professor Ioannis Patrikios, Deputy Dean of the School of Medicine and founder of the International Multi-Thematic Scientific Biomedical Congress, to please come to the podium for his welcome address.
Good evening, everybody. Dear executives, dear president of the board and CEO, we're going to be meeting him later on. We salute him from now. Government representatives, dear Congress participants and guests, it is my great honor and pleasure to welcome you to the 13th International Multi-Thematic Biomedical Congress, organized by the School of Medicine at the European University Cyprus, in collaboration with the Cyprus Medical Association, that is taking place in Nicosia from November 6 to 8, 2025. I extend a warm welcome to our distinguished keynote and plenary speakers, as well as to the vibrant medical and scientific community of Cyprus and abroad, and the international delegates. Your presence elevates the high standard of this multidisciplinary scientific symposium. I would like to express my sincere appreciation to the Ministry of Health, Cyprus Medical Association, and all supporting organizations for their invaluable support and recognition. This Congress has been institutionalized by Cyprus Medical Association, and I thank the President, Dr. Petros Agathangelu, and the entire committee for their ongoing partnership and support. For over a decade now, our Congress has grown into a leading international platform, showcasing cutting-edge research with more than 300 abstracts, many of which have been published in the respected Cell, Death and Disease Journal, a Nature publisher medical journal. This recognition underscores our commitment to scientific excellence and the status of Cyprus as a hub of knowledge and innovation. Over the years, the Congress has continuously promoted collaboration, education, and the dissemination of new scientific and clinical practices across the medical community. The event not only provides a rich scientific program, but also offers unique opportunities for networking and cultural exchange in the beautiful Mediterranean environment of Cyprus, an island renowned for its natural beauty and history. I would like to thank all the speakers, session moderators, and volunteers for their dedication and effort in making this Congress a success. Special thanks go to our generous major sponsors, Enercolab Equipment, the diamond sponsor, Philip Morris International, Ministry of Tourism, and supporters such Sobin Obro, Deloitte, Ophthalmos Clinic, Cyprus Biological Society, Georgiadis and Associates, Kostas Christodoulou Limited, Proton Medical, Pfizer, Papaelinas, Papaloizou Novartis, Medochemie, Biotronics, Delorpis, One Health, One Road Alliance, and a factory. I would also very much like to express our gratitude to the many delegates that traveled from abroad to attend this meeting. From China, Denmark, Finland, Sweden, UK, USA, Greece, Israel, Saudi Arabia, Germany, Poland, Romania, Austria, and Spain. A special welcome to the esteemed experts in European health policy and initiatives that are joining us to build the One Health, One Road policy track. In a parallel session, you will hear some in the plenary as well. Many from those are originated from Denmark, as we go from Danish European Union presidency towards the Cypriot European Union presidency. This year, among other exciting sessions, we will also experience an outstanding TEDx-like session on Friday afternoon with internationally renowned experts, speakers like never before in Cyprus. But we also have the honor to host one of the greatest living legends in science, and specifically in cardiology, Professor Dr. Valentin Fuster, with an age index of 218 from Google Scholar, and 35 worldwide honoris causa, that is going to receive the title of Doctor Honoris Causa from our university this coming Saturday afternoon in a formal ceremony. Lastly, I wish to note that November is one of the best times to visit Cyprus. Combining excellent weather with inspiring scenery, I hope you will enjoy both the scientific content of the Congress and as well the beauty of our island. Thank you all for your participation. I am confident this meeting will be both productive and memorable. I wish you an enriching experience and a successful, inspiring Congress. Thank you very much.
Thank you, Professor Patrikios. I would now like to call Professor Elizabeth Johnson, Dean of School of Medicine, European University Cyprus, for her remarks.
Distinguished guests, dear colleagues, and of course, my dear students. It really is each time an honor to welcome you to European University Cyprus and of course to the 13th International Multi-Thematic Congress. Now, this Congress represents more than just an annual gathering of great minds. It marks a defining moment in the life of our School of Medicine and actually in the evolution of European University Cyprus itself. Actually, it stands as a testament to our unwavering commitment to scientific excellence, international collaboration, and the creation of a truly global academic community. Now, over the last decade, and I've said this many times over, we've shown as a school a remarkable growth. When we first opened our doors, we welcomed students from Greece and Cyprus only. Today, we've grown into a vibrant, multicultural community representing over 40 nations from around the world. This diversity strengthens our mission to prepare graduates for an interconnected world and for global healthcare. Our vision has always been one of transnational education, an education where students are not confined by geography, but learn and train to serve across all borders. This vision was realized when we opened our campus in Frankfurt, Germany, and I'm happy that we have our chair from Germany here with us. This was a historic milestone. We were the first university in Greece and Cyprus to open a campus abroad. And where? In the heart of Europe, in Frankfurt. Equally transformative is the launch of our global clinical track, where our students are given the opportunity to experience healthcare systems in every corner of the world, an initiative that truly embodies our belief in health without borders. But today, we're celebrating the extraordinary journey of this Congress itself. This was the inspiration of Professor Yannis Patrikios, one of the founding members of our school. Today, as you heard Yannis say, this Congress has become one of the nation's most distinguished scientific gatherings, a true meeting point for knowledge, discovery, and collaboration. Under Professor Patrikios' dedication, his unwavering dedication, this multi-thematic Congress has become a nexus, a meeting point where world-renowned scientists and clinicians and institutions can come together, not just to exchange knowledge, but to forge lasting collaborations that shape the future of medicine. The legacy of this Congress is remarkable. Mr. Rector, Mr. Vice Rector, over the past decade, we've hosted over 180 international medical leaders from over 20 countries, including 12 Nobel laureates, 8 of whom who are now honorary professors of our school. Because of the partnerships forged at this meeting, our students now undertake externships in over 70 world-leading institutions, including Oxford, Harvard, UCL, Johns Hopkins, Imperial College, the list goes on. Today, in just over 10 years, nearly 800 EUC students from the School of Medicine have completed international externships, many working side by side in the labs of Nobel laureates. So each year, this Congress opens new doors to joint research, to institutional partnerships, and to clinical opportunities that directly affect our students and our faculty. It is through this visibility and prestige of this meeting that our school, in just a little over a decade, has achieved a recognition far beyond our island shore. This year, we're honored to welcome many, many renowned scientists. Professor Valentin Fuster, a little bit Professor Ioannidis, Professor Kokinos. There's so many friends in here and so many names that it's hard to name them all. Their presence, along with more than 75 distinguished international speakers, symbolize the depth, the prestige, and the global relevance of this event. Under the direction of Professor Patrikios and, of course, Clinical Professor Petros Agathagellou, the president of the Cyprus Medical Association, who has been a steadfast supporter and friend of the school, this Congress continues to grow in both ambition and scope. Its innovative program spans the full breadth of biomedical science, and every year it continues to raise the bar for academic excellence and exchange in our region. I want to extend my deepest gratitude and warmest congratulations to Professor Patrikios and Professor Agathagellou for their vision, their leadership, and their commitment. But let's not forget, this meeting goes beyond its scientific significance. This is a Congress that also celebrates community, a reunion of old and new friends, united by a shared belief in the power of science, the power of education, and of course, the power of collaboration. So, welcome again to this extraordinary gathering, one that celebrates the pursuit of knowledge, but also the enduring spirit of friendship and cooperation, something that drives medicine and humanity forward. Thank you.
Thank you, Professor Johnson. I would now like to call Professor Andreas Evstathiou, Rector of European University Cyprus, for his opening remarks.
Good evening, everyone. Distinguished guests and participants, I'm deeply honored to welcome you to European University Cyprus for the opening ceremony of the 13th International Multi-Thematic Scientific Biomedical Congress organized by our esteemed School of Medicine. The annual International Multi-Thematic Scientific Biomedical Congress is one of the most prestigious scientific gatherings in Cyprus. It has significantly advanced research and innovation in its various fields of study on the island. The Congress has earned a distinguished reputation, as we heard already from the Dean, for drawing eminent scholars, academics, and researchers in biomedical sciences and medicine from around the globe to Cyprus. This year's event continues that proud tradition. I would like to take this opportunity to say a few words about our university, an academic institution in Cyprus, where increasingly university education, research, innovation, and technology assume a more central role. Our institution has made remarkable progress since its founding over 60 years ago. Today, our faculty and researchers collaborate with leading scientists from top universities around the world. They also lead or contribute to prestigious research projects which are funded by the European Commission, the Research and Innovation Foundation here in Cyprus, and numerous other funding bodies. Indicatively, I would like to say that over the past decade, our research activity has grown steadily at an average annual rate of 20 to 30%, resulting in a significant increase in external funding and a strong presence in peer-reviewed publications. I'm pleased to highlight several recent achievements for the university, which reflect our continued commitment to excellence in research, education, and international collaboration. EUC is already in the top 1,000 universities in the world, according to the Times Higher Education World University Rankings, 500 to 600 in medical and health. This year, we embarked on an exciting journey with our 8 partners in the European Universities Alliance Sunrise. This year, we also had our first graduates at the International Digital Economy College. We operate in collaboration with Minjiang University in China. And last year, we launched our School of Veterinary Medicine, which is housed in the recently completed addition to our Nicosia campus. The establishment of the School of Medicine over the past decade, as we heard again from the Dean, alongside our School of Dentistry, School of Veterinary Medicine, and the School of Sciences, which offers numerous programs in health and life sciences, has significantly boosted our university's research activities, leading to new achievements. The annual International Multithematic Scientific Biomedical Congress provides our faculty with the opportunity to help position Cyprus as a leading center for medical education and research in the region. We are also very proud of the fact that our university 3 years ago began the offer of its program in medicine at the branch of our respective school in Frankfurt, Germany. It is a great honor that this is the first time a university based in Cyprus offers programs of study outside the island. I would like to conclude with my warm thanks and congratulations to all those who worked so hard for the organization of this year's Congress, and especially Professor Ioannis Patrikios, Deputy Dean of our School of Medicine and founder of the Congress. I would also like to acknowledge all sponsors and supporters for their contribution. Best wishes to all for a very successful Congress. Thank you very much.
Thank you, Professor Evstathiou. I would now like to call Clinical Professor Dr. Petros Agathangelu, President of the Cyprus Medical Association and Congress Scientific Committee Vice Chair, for his remarks.
Good evening, Honorable Rector, Vice Rector, Honorable Dean of School of Medicine, Honorable Professor Patrikios, Founder and Chairman of the Organizing Committee, and Deputy Dean, distinguished scholars, keynote speakers, esteemed colleagues, students, ladies and gentlemen. It is a great honor to welcome you to the 13th International Multithematic Scientific Biomedical Congress hosted by the European University Cyprus in partnership with the Cyprus Medical Association. We gather once again under the title Scientific Cyprus, a title that carries both a message and a mission to reaffirm Cyprus as a vibrant center of medical knowledge, a meeting place where science transcends borders and human intellect becomes a shared endeavor for health and humanity. Over the years, this Congress has evolved into one of the region's most distinguished scientific events. What began as a vision has grown into a significant tradition that unites medical professionals, academics, and innovators from every corner of the medical spectrum and healthcare sector. Here, clinical reality meets academic exploration. Here, discoveries from the bench find their way to the bedside. And here, the Cyprus Medical Association stands proudly as a bridge linking scientific inquiry with medical practice, ensuring that what is learned in our lecture halls and laboratories becomes meaningful change in our hospitals and communities. As president of the Cyprus Medical Association, I view this Congress not only as a scientific landmark, but as a symbol of partnership between institutions between generations of physicians, and between disciplines that together form the science of medicine. This year's program beautifully embodies that philosophy. We are deeply privileged to welcome world-renowned keynote speakers, scholars, whose names inspire the global scientific and medical community. Their participation is a testament to Cyprus' growing voice in global medicine. Our country is not defined by its geographical size, but its vision, its scientific excellence, and its enduring openness to collaboration. This is Cyprus. Beyond that, we are very famous for our hospitality, and I'm sure you're going to experience that in the next few days. At the Cyprus Medical Association, our vision has always been to safeguard professionalism while promoting progress. We believe that medical advancement must walk hand in hand with ethics, education, and empathy. Through continuous medical education, regulatory guidance, and our close collaboration with academic institutions such as the European University of Cyprus, we strive to ensure that our physicians remain scientifically equipped, ethically grounded, and socially responsive. Our commitment is to transform knowledge into action so that every patient encounter becomes not only an act of care, but an extension of collective scientific wisdom. This Congress is therefore more than a meeting of a great minds. It is a celebration of unity within diversity. It reflects how biomedical research, public health, and clinical expertise converge to address the pressing issues of our time, from chronic diseases and aging populations to mental health, digital transformation, and global well-being. Behind every abstract and data set lies the human history. The patient whose courage inspires discovery, the researchers whose persistence turns doubt into knowledge, and the medical professional whose compassion and scientific expertise and clinical reasoning give science its true meaning. Allow me, therefore, to express my deepest appreciation to the School of Medicine of the European University of Cyprus. Dean, thank you for your endeavors. Professor Yannis Patrigios for his unwavering commitment to disseminate knowledge and keep up the good job. I'm pretty sure this will be occurring on an annual basis. And of course, the entire organizing committee and all those volunteers who work tireless, and their dedication has once again brought this ambitious program to life. To every speaker, moderator, and participant, thank you for your reaching this dialogue of minds. To our sponsors and partners, your support sustains this shared vision. Together, you form the living ecosystem of Scientific Cyprus, a community where ideas turn into impact and where learning never ceases. As we inaugurate the 13th International Medical Seminar Congress, let us carry forward the spirit of collaboration, curiosity, and compassion that defines science. On behalf of Cyprus Medical Association, I wish you all an inspiring Congress. Thank you once again, and welcome you all to Scientific Cyprus.
Thank you, Dr. Agathangelu. Ladies and gentlemen, please allow us a quick minute to make a small change on the stage. Yeah. All right, ladies and gentlemen, please take your seats so we can continue. I would now like to welcome on stage a representative of the Minister of Health, Mr. Michael Damianos, Mrs. Natasha Anastasiadou, for a quick speech.
Distinguished Rector, Dean and Deputy Dean of the Medical School, dear professors, dear friends, it is a great honor and a pleasure for me to address you at the opening ceremony of the 13th International Multi-Thematic Medical Congress, an event that truly embodies the spirit of scientific Cyprus, a nation that is confident in its ability to promote and share knowledge across borders. This Congress, organized by the School of Medicine of the European University Cyprus and the Cyprus Medical Association, stands as a beacon of scientific excellence and collaboration. It gathers brilliant minds from across disciplines of medicine, technology, environmental science, and policy to explore how innovation can serve humanity. We meet at a time when health systems around the world are being challenged as never before. Climate change, emerging diseases, demographic aging, and technological disruption are reshaping the way we think about health and well-being. The first session of this Congress on environmental realities and public health reminds us that the health of people and our planet are inseparable. In Cyprus, we have learned that environmental health is not an abstract concept, but a daily challenge. The Ministry of Health, together with our academic partners, is working to strengthen environmental monitoring, prevention, and preparedness, integrating health protection into our broader sustainability agenda. Our vision is clear: to build a climate-resilient health system that protects both the people and the planet. The rapid evolution of science is also transforming medicine itself. Genomics, bioinformatics, and artificial intelligence are redefining diagnosis, prevention, and treatment. Session of this Congress on medical genetics, metagenetics, and AI in medicine illustrates the extraordinary pace of discovery, but they also highlight a profound policy question. How can government ensure that innovation benefits all, not just a few? Digital transformation of health must be guided by ethics, transparency, and equity. Technology should augment, not replace the human connection that lies at the heart of medicine. Cyprus is already taking steps in the direction by modernizing health information system, expanding digital health records, and supporting innovation partnerships that connect research with patient care. We are also investing in precision and personalizing medicine, ensuring that genomic advances translate into real benefits for patients living with cancer, rare diseases, and chronic conditions. Future challenges and areas for development in public health are addressing the health axis of the Cyprus Recovery and Resilience Plan, funded by the EU Recovery and Resilience Mechanism and the state budget. The health axis of the plan focuses on interventions that include modernization and digitalization of healthcare infrastructure and equipment, deployment of cross-border e-health services in Cyprus, design of an electronic platform for the surveillance of nosocomial antibiotic consumption and healthcare-associated infections. The establishment of a National Center for Clinical Evidence and Quality Improvement is ongoing and coordinated by the Ministry of Health. Healthcare is dynamic, with new research, treatments, and disease strains emerging all the time. In order to thrive in this constantly changing environment, we must ensure that the healthcare system is able to adapt to these changes in real time. We must remain vigilant, invest in data collection, utilize technological solutions, cross-train a skilled workforce, establish facilities that can cater to high-risk medical needs, ensure effective inventory management of medical equipment and medicines, and ultimately create a sustainable healthcare model that is always ready to meet contingencies with minimal disruption. This Congress coincides with growing European dialogue on health aging. Europe is aging rapidly, and longevity is a triumph of progress. Yet it also demands new models of care, new social policies, and new ways of thinking about intergenerational solidarity. Our goal must be not to add not only years to life, but life to years. To achieve this, we are working towards a system that integrates prevention, primary care, mental health, and long-term support, one that values health promotion as much as it values treatment. The Ministry of Health is committed to strengthening community-based services, expanding geriatric and rehabilitation care, and integrating digital tools that allow older citizens to live independently and with dignity. Health aging is not just a policy priority, it is a moral responsibility towards the generation that build our societies. The Ministry of Health recognizes that true innovation emerges when science meets compassion and policy meets purpose. That is why we continue to support partnerships between academia, public institutions, and private innovators, ensuring that Cyprus remains a hub for medical research, education, and clinical excellence in the Eastern Mediterranean. We are proud to see Cyprus institutions contributing to global networks of excellence, advancing gene therapy, developing rare diseases registries, and engaging in international projects that shape the future of medicine. As we look forward to the future, let us remember that medicine is not defined solely by technology or data. It is defined by trust, empathy, and service. The greatest achievement of medicine is not the discovery of new knowledge, but the application of that knowledge to relieve human suffering. So, as we begin this 3-day journey of dialogue and discovery, let us reaffirm our shared mission to harness innovation responsibly, to make health systems more resilient, and to ensure every citizen, regardless of age, background, or circumstance, can enjoy the highest attainable standard of health. I would like to extend my sincere thanks to the organizers, the European University Cyprus Medical School, and the Cyprus Medical Association for their vision and leadership. You have once again made Cyprus a meeting point for global minds and a catalyst for meaningful progress. To all participants, may this Congress inspire you, challenge you, and remind you why we dedicate our lives to this noble calling. Thank you.
Thank you, Mrs. Anastasiadou, and we thank the Ministry of Health for all the support. I would now like to call back on stage Professor Dr. Ioannis Patrikios, Deputy Dean of the School of Medicine, to present tonight's special speaker.
Okay, I'm going to introduce Professor Dr. John Ioannidis, our keynote speaker in the opening ceremony. Professor of Medicine, Epidemiology and Population Health, and Biocartography, Biomedical Data Science at Stanford School of Medicine. Professor of Statistics at the School of Humanities and Sciences, co-director of the Meta Research Innovation Center at Stanford Metrics. His research focuses on improving research methods, integrating information, and generating reliable evidence. Born in New York and raised in Athens, he earned an MD, top of class, and the Doctor of Science from the National University of Athens, trained in internal medicine and infectious diseases at Harvard and Tufts, and her position at the NIH, Johns Hopkins and Tufts. He chaired hygiene epidemiology at the University of Ioannina, with adjunct roles at Harvard, Tufts, and Imperial. Then joined Stanford as director and board chair at the Prevention Research Center. He launched Stanford's PhD in epidemiology and clinical research and Master of Science in Community Health and Prevention Research, founded Metrics in 2014, and has served in leadership and editorial roles. He has delivered more than 700 invited lectures, held many visiting professorships, and received numerous awards and honorary doctorates. Highly cited researcher according to the Clarivate both clinical medicine and social sciences. Citation indices of age equal to 242, with a current citation rate of more than 6,000 new citations per month per Google Scholar, more than 3,500 new citations per month per Scopus, or Web of Knowledge. Among the 6 living scientists worldwide who are currently the most commonly cited, perhaps also the currently most cited physician. My friend, the podium is yours.
Good evening. What a wonderful honor. I'm really excited and very happy to be in my beloved Cyprus again, and to see the European University Cyprus and its biomedical meeting grow to new heights and reach new heights every year. So my talk is not going to be as happy as the Cypriot songs that you heard early in this session. It may be a bit more sober, and it's going to discuss challenges and even extinction threats for the scientific literature. Are we going to become extinct, and what is threatening us? Well, here's a list of potential threats. Lack of reproducibility, biases on the framing of the research agenda, internal validity, external validity, conflicts, financial, lots of people who want to make money out of science and research, tobacco industry, supporting public health research or medical meetings. Ideological, goodness, so many ideologies. I'm very biased, beware, I may be completely wrong. Political, right, left, center, politicians fighting over the dead corpse of science. We see that increasingly. Science happening outside of the scientific literature, the scientific literature becoming a toy for some people like me who want to publish, but not really what matters. The advent of massive fake literature, I'll tell you more about that. Maybe I'm fake, no, I hope I'm real, but AI could create a fake Joy Ioannidis talking to you. But background risk of overall human extinction, I checked with my AI tool just before the talk, what are the chances that humans will become extinct within 100 years? Reply, 1 in 6. Is that true? I don't know. A couple of days ago, I asked same AI tool, how many children does John Ioannidis, the professor at Stanford, have? 3 children, even gave the names. None of them were the name of my single daughter. So all of these threats may be interconnected. One may build upon the others. Here's the scientific literature. 50 million authors have published at least one scientific paper, okay? 12 million have published at least 5 scientific papers. 200 million scholarly documents published, increasing at a rate of 7 million every year. Recent papers may be equivalent to 1 million papers in the past. In the past, the father of clinical epidemiologists, Bradford Hill, would say, I'm not going to trust anything unless I can repeat the calculations on the back of an envelope. Now you may get petabytes of information in a single paper. Maps of science, like this one that I have drawn with my colleague Kevin Boyack, suggest that there's many thousands of scientific disciplines. Even when we talk about scientific literature and scientific method and research practices, these are applied in very different ways. What is the norm, what is the expectation, how we run things is very different across each one of the dots of this universe that is one scientific subdiscipline. There's about 200,000 scientific subdisciplines in this map. In fact, much like the real universe we know is mostly dark matter and dark energy, we estimate that 27% is dark matter, 68% dark energy, and only 5% is ordinary matter. Maybe what we see, the scientific literature, is just a very thin slice. And there's far more analysis that, I run in my laptop, you run in your lab, or you're in silico, or clinical, or in vivo, or in vitro, or whatever, research that never go anywhere. And also dark energy, incentives, misaligned principles, publication bias, narratives that are not really the truth, quote unquote. Many of us believe that we need a revolution. We need to support reproducible science. This is a paper that the authors come from very different walks of life and very different scientific disciplines. You see a manifesto, like Communism Manifesto or Surrealism Manifesto or, Reproducibility Manifesto. We believe that we're reaching a reproducibility crisis, and I think many scientists, in a survey by Nature, about 70% agreed that science is facing a reproducibility crisis. We have all these millions of papers that we can compare notes and try to estimate how much of that literature is likely to be biased. Almost all of it. So this is one example where we used about 250,000 studies from all 20 major fields of science, trying to see whether the patterns of results, when you have different studies on the same question, is compatible with 18 different types of biases. Most biases appeared in most scientific fields, but not exactly the same. Each field has its own signature and footprint of biases and threats. Empirical studies on fields where replication has become common suggest that most of the initially claimed statistically significant effects are false positives or substantially exaggerated. This is a classic paper that recently reached its 10th year landmark. It looked at 100 creme de la creme, highly cited, highly influential, in very good journals, studies published in psychology. People tried to replicate them very faithfully following what was done in the original investigation. About 2/3 of the time, they could not get the original signal. On average, the effect size that they got was about 40% of the effect that had been proposed in the original study. Worse, we're not very good at self-correcting ourselves. If you tell me that my research is wrong, I will fight back. And perhaps this is human and this is acceptable. If I have good arguments, maybe I might survive. But we see that even in the most thoroughly refuted types of research, like beta-carotene, Nature paper proposing that it will be the most effective chemoprevention for cancer, 6 big randomized trials showing absolutely no benefit, if anything, a trend for harm at high doses. The original paper continues to be heavily cited, more cited than other papers published in the same time. What do people cite it for? Not to say that we were wrong, but to continue saying that, beta-carotene is effective chemoprevention for cancer. We've seen that in every field that we've tried to look. We've seen it, for example, in social sciences that now have multi-lab replications with 50 teams trying to replicate influential signals and seeing nothing. And people continue to cite the original wrong observation. This is one such effort, the Reproducibility Cancer Biology Project, that tried to replicate extremely highly cited influential papers in cancer biology. So foundation of basic science biomedical research. I'm not going to focus so much on the failure rate, which is about 2/3 again. 2/3 of these highly cited papers failed to replicate.
but on the inability to even get started to try to see if something replicates. The vast majority of these 193 experiments that were targeted for replication, someone could not even get them started in the lab. Reaching out to the original investigators, asking them, how did you do it? We can't even get it started. It could not be done, let alone getting some results to see if they agree. And the second worrisome part is that even though these replication studies had been promised to be published in a very prestigious journal right away, eLife said, I'm waiting to see what you get and I will publish it right away. It took on average 197 weeks from designing the replication to publishing it, which means you have a PhD student going for the first week to the lab and the supervisor says, let's find an experiment you can do just to get your hands wet. This paper was published in Nature. It should be classic knowledge. Well, why don't you do it today or tomorrow? You should be done. That takes 197 weeks on average, and most of that will never be done, actually. Can we trust the data? In some cases, we cannot. For example, this is study 329, a very influential study published in 2001 and sponsored by SmithKline Beecham, currently GSK. It showed that in adolescents, paroxetine and imipramine are very effective and very safe for treating depression. 15 years later, independent scientists managed to get hold of the very same data set. They reanalyzed that data set. They concluded that paroxetine and imipramine for major depression are not effective and are not safe. How often is that happening? And how often do we have access to the raw data to be able to do that? There's many interventions that can diminish that threat of lack of credibility that we're facing. A couple of weeks ago, along with Tamarine de Haven from the Netherlands, I published this summary review of different options that may help us to diminish these threats at the level of design and conduct of research, of reporting of research, and of reviewing of research. Red alert, none of them is perfect. And for many of them, I'm not sure that they even work in a positive way. For some of them, we may be just burdening people to do more things, but not necessarily making things more trustworthy. Some progress has been made, though, in some practices that probably are giving us some hope that we can trust more. This is an observatory that we have built, along with my colleagues from Stanford, where we try to map the entire biomedical literature, at least all the papers that we can access in open form, and try to see how many of them are sharing data, sharing code. They have some protocol registered somewhere. So data sharing has gone up from 0% 20 years ago to about 20%. 1 out of 5 papers are sharing their raw data. Code has gone from 0% to 6%. Protocols, 0% 20 years ago, or close to 0%, about 7% at the moment. More people are willing to say, I'm going to try to replicate. And almost every journal has some placeholder for disclosures of conflicts and of funding. We don't know whether they're complete and accurate, but at least someone is asking for them. And then people can place in context what they read in terms of the relationship to conflicts and funding. If you ask in that map of the universe of science that I showed you earlier, where do we see data sharing? You will see some color, meaning that's happening in some scientific discipline, but lots of darkness in most scientific disciplines. You will see code sharing in a subset of these disciplines. If you seek protocol registration, you see some light in other areas, not necessarily those that are sharing data and those that are sharing code. If you want to have the data, the code, and the protocol, that's very, very rare still. At the same time, we don't want to diminish funding for research or science. Science is being threatened by many, many threats. One of them might be that the public or politicians or agencies might say, we're fed up with you and we don't want to support you any longer. Good luck. So we do want to maintain support for science, but to be honest, we lack evidence about what is the best way to support science in a way that we get more credible results and in a way that we maximize progress. I just refer you to this paper that we published in PNAS a few months ago, where we go over some of the deficiencies in our funding system that sooner or later we will need to look at very carefully, because otherwise people will tell us, we've had enough of you, and we've just given too much, and we got very little compared to what we have invested. Here comes AI now. Wonderful development, wonderful tool to play with, to generate tons of possibilities. It may shift the scientific literature and move science outside the scientific literature. I have been told, and I want to believe that my university, Stanford, has the highest computational capacity than any university worldwide. Very proud of it. But within a few miles from Stanford, there's companies like Alphabet, Meta, Microsoft, Apple. A couple of them are not in Silicon Valley. Most are, that have 100, if not 1,000 times more computational capacity than Stanford. Most AI research may grow outside the published scientific literature. These companies have no reason to share with us what they do or what they want to do. These tools may or may not be open source. They're generated by industry primarily. If they're open source, they may become closed source at some point after they have absorbed whatever creativity, contributions from the rest of the community is currently offering. Science happening outside of science is not a new thing. In fact, Wired, which is a great popular journal but also can publish wonderful nonsense, many years ago had a title like The End of Theory. The data deluge makes the scientific method obsolete. We don't need science and the scientific method. Just give me data. And you know, that was the mentality that data is wealth and you just have data, that's enough. Some entrepreneurs think that science and the scientific method are not only obsolete, but research should be done in stealth mode. It should not be communicated. That was exactly the principle behind Theranos, the highest valuation startup at $9 billion about 10 years ago, when I published the first negative paper about Theranos in JAMA. It went through peer review, editorial review, and legal review, because at that time Theranos was like the foster child of entrepreneurship and science and research and disrupting the health sector, and visited by the vice president, getting honorary doctorates and being at the front page of all journals and journalism and whatever. And I said, you know, I don't know whether the valuation should be $9 billion or $9. And of course now the CEO is in jail and it was all fake, it was just fraud. But maybe that was just a single bad apple. Well, when we looked at unicorns, startups with valuation more than $1 billion across all healthcare, we found that about half of them have the same stealth profile as Theranos. They don't act within the scientific literature. They don't care about the scientific literature. And this is a more focal example on immunology. We see that those startups that have the highest valuation have an inverse relationship, have the lowest contribution of evidence to the scientific literature. Very, very weird. AI is not going to stop. It will just accelerate, accentuate, and perhaps clarify some of these evolving issues. We see here the latest index report for 2025. The growth of AI patents is accelerating. Almost all of that is happening in the industry sector. The most popular, notable AI models, you hardly see a couple of them from academic institutions. You see Google, OpenAI, Alibaba, Apple, Meta, NVIDIA, Anthropic, and so forth. All of that is going to increase computational and overall complexity. And LLMs may even defy strict reproducibility because they train on some data today and they drain additional data sets by the end of the day, tomorrow, let alone 6 months from now. AI may also lead to massive transformations of both scientific discovery, appraisal, and misconduct. And in that regard, it can be both helpful and harmful. We have some stunning successes. We have the work by John Jumper and Demis Hassabis that got a Nobel Prize on protein structure prediction. Why? This is a topic that required massive computational capacity and pretty accurate measurements, and that's exactly where these tools are going to be successful. This is another example from a paper published by my colleague, James Zhu, from the Department of Biomedical Data Science at Stanford very recently at Nature, where research was done only by AI agents. You know, a human was there mostly watching, but you had an AI agent being the principal investigator, one being the scientific critic, you know, contrarian, one being the immunologist, one being the machine learning specialist, and one being the computational biologist. They did the work very nicely. They generated the nanoparticles for COVID-19 that they wanted. Was validated, very, very nice. Will we replace researchers entirely? Well, maybe, or maybe not. But all of these tools do not have a guarantee that they will have good performance. They may say that I have 3 daughters, and I don't. So poor performance may still be an issue unless we check. We will not find out. Misinformation, they can massively promote misinformation and disinformation if they're tickled and filtered and probed to do that. They can generate more inequalities, and they have unknown societal impact. The scientific ecosystem, we don't know exactly how it's going to change, whether human researchers, AI researchers, both will coexist, collaborate, fight against each other, who knows? Ethical issues are up in the wind. And many broader issues, of course, you will see and hear every day in the news, both in the scientific literature and mostly outside of the scientific literature, mostly by people who have no clue. Like myself, for example. I have no clue what will happen with these tools. And I just have to be honest with you. I want to monitor what they do. That's all I can say. Monitoring shows that currently LLMs can publish, well, can submit 1 out of 7 papers submitted to respectable journals. So if there's 7 million papers published every year, that means if we accept that a paper that is submitted sooner or later will find a spot to be published, this is what my late mentor, Drummond Rennie, used to say, 1 million fake papers every year. And these data are a bit old. They're a few months old. This is like prehistory now. I wait to see the new information. It may be more. It may be 2 million fake papers now every year. Who knows? We know that we can detect some of them. Most of the retracted papers in the last several years are paper mill products. Paper mills are companies. They have a website. They say, I'm selling papers. Do you want to be an author? Give me a couple $100 and you will be an author. If you want to be first author, that much. If you want to be third, a little less. If you want to be senior, that's the price. Fake papers, massively produced. We just get rid of the tip of that iceberg that is growing very, very fast. It may become an irrelevant and fake scientific literature if these efforts really grow out of control. Can we recognize that this is happening? We have many tools to counter and to detect this fake production. None of them is 100% perfect in terms of sensitivity and specificity. There's another list of potential signals. We reviewed those recently with some colleagues. None of them is perfect. And you realize that it's not easy to start retracting millions of papers, all of the blue. We discussed many of these issues in the latest International Congress on Peer Reviewed Scientific Publication 2 months ago in Chicago. We were flooded with presentations about what AI can do and cannot do and what is doing at the moment. I think no one has a very clue of what exactly it is doing with science and the scientific literature. Another hint that we have, though, is that these tools are not necessarily less biased than humans. They could be as biased as humans because humans have developed them and trained them, and in fact, they can be even more biased. This is a nice paper from PNAS showing cognitive biases in moral decision-making, which means that if you start trusting these tools, you may make decisions that eventually you would say, oh goodness, that was unethical to do. What is your preferred source of information eventually? I have been talking about the scientific literature, and of course, it has lots of problems and lots of trouble. But well, wait a second. We have people who try to sort through that and inform the public. We have secondary sources like formal journalism in legacy venues. Do you trust those? Surveys suggest that very, very few people trust legacy venues. Wide community sources, blogs, podcasts, TikTok, X, Blue Sky, whatever. Many of those I don't even know. Maybe they appeared last week. How many people trust them? Well, those who trust them are those who believe what they say, but not what the others say. That's not easy. Wikipedia, I'm sure all of you are familiar with Wikipedia. Is it ridiculously biased and guarded by polarized partisan zealots? Some people claim that this is the case. Take a look at some articles. I haven't made up my mind. Some of them are excellent, others, goodness, I have to say. I'm stunned. Did you hear about Grokipedia? It came out about a week ago. Elon Musk and his company has launched the competitor to Wikipedia, and it's not human editor-based, it is based on AI. AI is creating that encyclopedia. Is it any better? Is it going to be any worse? Will it show that I have 3 children? I don't know. To conclude, the scientific literature is uneven, unstable, and unpredictable. The unpredictability is not a bad thing. This is what makes science fascinating, that what we believed last year may all be wrong. What I'm talking about now may be completely wrong. That's the fascination. Peer review processes are known to be suboptimal, and they're strained, and may reach or have reached a breaking point. The system has ample opportunities for gaming and only modest defenses. New technologies offer some new opportunities, but also raise massive threats. Important ethical issues remain unresolved, and reproducibility quests are likely to remain important, but may also be weaponized. So watch out, be prepared, still read the scientific literature. Thank you so much.
And now we are concluding the night, and I hope to see you all tomorrow morning for the morning sessions of the Congress. Thank you very much.